Howdy, folks. Welcome to my presentation. I'm going to be talking today about how to work with lawyers before your first legal hire. Start off a little bit about me. I'm currently at Fenwick. Previously was trained as a traditional securities litigator for another big law firm, working on their litigation against the SEC. My current position, I represent companies across the industry, exclusively in crypto, doing everything from supporting token launches to de-risking communications and community relations to representing folks in SEC investigations and litigation and all sorts of other craziness that comes up in our industry. I'm currently also working on a product, a structure that provides D&O insurance to token holders who participate in governance. I am a lawyer, so I have to give you a caveat, which is that this is not legal advice. There may be people out here from projects where I actually am your lawyer, but as we'll talk about later, I would never give you legal advice in this public setting because that would destroy privilege. I also should note that I'm a US attorney. I'm talking about US legal issues. Obviously, there's a lot of cross-border issues in our industry, and I'm not necessarily going to touch on those. All right. Why you should listen to me, why those of you in the audience right now are watching on video are the smartest people at ETHDenver. We're building in an industry that is rife with regulatory uncertainty and litigation risk. I mean, obviously, any lawyer is going to get up here in any industry and tell you that legal is the most important thing and everyone should pay attention to what we have to say. But honestly, it's even more critical for builders and folks in crypto. But most companies in this space, or most projects, aren't going to have a lawyer on staff until very late stages. And so at the beginning, when you're first starting to build, it's going to be developers supervising outside counsel, right? And so the point of my presentation today is to talk a little bit about what that looks like and what you should be doing if you're in that position. Or another way to think about it would be like, what are things that I wish my clients knew before they came to Fenwick and hired me, right? To avoid issues that we have to fix later. So the first question we're going to talk about, there we go, is when to hire a lawyer. Again, to be self-serving, I'm going to tell you as soon as possible, get lawyers involved. But actually, honestly, that's kind of true. The less building that you do without legal review, the fewer problems that we're going to have that we have to fix or undo later. I have to say that. Certainly, of course, anytime you're doing any type of fundraising or token launch or SAFT or something like that, you're going to want legal to take a look. That's an area where there's kind of a clear inflection point in this industry. But also, frankly, any lawyer in this space should be willing to talk to you about like where you're at right now. Is this the time to bring in lawyers? What might that look like later? And they shouldn't charge you for that. So, certainly my team at Fenwick is always willing to have those conversations, and most lawyers in this space will do that. So you should be thinking early and often about when is the right time to bring in a legal team to look at what you're doing. And again, like there are ways to do that are cost effective and to make sure that there's planning for that. So then the next thing I want to talk about is like, what do lawyers do in this space? And sorry, I just have like random memes up here because I was putting this together on a red eye last night, so enjoy. You'll be bringing in lawyers, of course, to flag legal risk and help you figure out how to mitigate it, right? But it's a little bit bigger than that. Like a good lawyer, particularly in this space, is going to be a builder too, right? Like we're going to help you note business risks and benefits of proposed courses of action and really be a partner in what you're trying to put together. One thing I really do want to communicate, though, is that lawyers are not going to be making decisions for you, right? So sometimes clients come in and they're like at a moment of inflection and the considerations are really difficult. And, they're looking at somebody who's got like years of experience in the industry and working outside. And they're like, hey, maybe this person can like just figure this out for me. And that's not like what lawyers are going to do, at least not good ones. Right? Like what we're going to do is make recommendations to you. We'll explain the considerations. We'll give you the pros and cons, both from a business and a risk perspective. But we're not going to tell you what to do. We're going to say it depends. We're going to say, here's some options. We're going to say, here's our recommendation. And we're not doing that to be annoying. We're doing that because at the end of the day, like we have a different role, right? And the risk belongs, and the rewards and the decision point belongs to the business and doesn't belong to us. That said, if you come to a lawyer with a plan and they say, do not do that, and especially if they say, do not do that in writing, you should take that very seriously. Right? Because lawyers are generally loath to tell people what to do and what not to do. So when we do that, it's generally going to be something that is, truly a problem. What are the types of issues that a lawyer in this space should be flagging for you? Of course, given my background as a securities litigator and SEC troll, I'm going to tell you that they should be looking at securities risk and SEC exposure. But there's a lot of other stuff too. Right? There's your tax strategy, there's money transmission and banking laws, there's intellectual property, there's sanctions and OFAC, there could be gambling, there may be others depending on your project. Right? I can't give you an exhaustive list here, but the point that I wanted to make here and why I dedicated an entire slide to this is like, don't get shortchanged. Like, make sure that whoever you're working for is at least conversant in these issues and how they intersect in our space, so they can tell you when. Like, even if you just hire someone to do your trademark or something like that doesn't seem necessarily like a Web3 issue, they're going to be learning a lot about your business. And you want that person to be able to tell you, like, this is outside my expertise, but it's putting kind of flags off in my brain. Let me recommend somebody else to you that might need to look at this, right? Because that's part of what you're looking for too. Like, you're building, moving quickly, you've got a lot going on. You need your legal partner to be somebody who can help you figure out when you need more help you figure out when you're tripping into a red area, help you avoid that quicksand. Do you need crypto native counsel? It depends. I told you that was lawyers' favorite thing to say. If you're looking for advice on an issue that you can explain fully without using any jargon, you're probably okay with a lawyer who's an expert in that field and may not necessarily be an expert in crypto. So a good example of this might be trademark, right? If you're trademarking something, it kind of doesn't matter what you're using the trademark for. Like, that's going to be pretty much the same across the industry, and you want to find somebody who's good at trademark and not necessarily somebody who's good at crypto. But if you're looking for advice on a fundamental decision for your business, right? If you're asking questions that require an understanding of what you're building and how it works and how the industry functions, make sure you get a lawyer who understands what you're building, how it works, and how the industry functions, right? Because there's a lot of lawyers out there who have had like one crypto client and they hold themselves out as like, I'm now an expert, I'm a Web3 lawyer, this is how I'm marketing myself. And when you dig below the surface, you realize that you're not speaking the same language, right? And they're not really understanding what you're asking for here. And so they can't do that important work of flagging issues for you and making sure that you're not taking on more risk than you want to. All right. How do you find a crypto native lawyer? This next slide is not really a GIF, but it's a shout out to Microsoft Teams, which has these like lawyer sharks that I'm low-key obsessed with. How do you find a crypto native lawyer? Come to Fenwick. Just kidding. When I was in-house at Ripple, there were a few things that I would ask lawyers to determine whether or not they were someone who might be a good fit for a project that required a deeper understanding of what we were building and what we were doing. One question was just like, how do you keep up with the industry? Right? I think we all know what the correct answers are, mostly Twitter. But a lot of lawyers will come back and they'll be like, well, I do CLEs and I go to presentations and I read publications. And you're like, what are we talking about here, right? Because if they're learning about the industry from content that's created by non-crypto native lawyers for other non-crypto native lawyers, they're not going to have the depth of understanding that you want. You should also dig in on a lawyer's experience. What types of projects have you represented before? Like, lawyers can't always name our clients, right? So they may not be able to give you that list, although they should be able to give you some kind of references or referrals. But they can tell you, like, I've represented layer 1s, I've represented layer 2s, I've represented token projects, I've represented, folks in the ZK space. Like, whatever the thing is that you're working on, they should be able to tell you if they've worked on that before. I would also ask people, like, do you hold tokens? Which ones? Where do you put them? Do you self-custody? I'm just trying to get a feel for like whether there's someone who's truly like invested in the space and invested in the industry, or if this is just a new hot topic that they're looking to like make a name in or make a quick buck in, or like kind of like they're going to do this for now. If all else fails, if you're evaluating whether to hire a lawyer and you're trying to figure out whether there's somebody who has the expertise you need, you can just start talking and see how glazed over their eyes get, right? So start explaining to them like how your product works, what you're trying to do, like how things work in your industry, like in your particular segment of it, and then just see what questions they ask. And it's pretty easy to tell when you're talking about something very technical if someone's tracking to the point you need them to, or if they're just completely lost and like using buzzwords. And like, to be clear, like, you're not going to find crypto native counsel who understand what you're doing as well as you do. Like, that's not the goal and that's not going to be possible. But you want somebody who can, like, with a little bit of digging and with a little bit of time maybe, like, actually understand how the pieces fit together and how this works. I don't know how anybody could ever do that if they're not themselves participants in the industry, right? Which is why I would always ask the question, like, what tokens do you hold? Where do you hold them? Like, what is your exposure to crypto and how do you use it? But maybe I'm wrong. Like, maybe there are people out there who like deeply understand the industry without ever doing those things, right? Like, I guess it's possible. All right, we're halfway through. We're going to stay on the next slide for a while because this is the bulk, the most important part of the presentation. So if you were sleeping or on your phone, now is the time to listen. We're going to talk about attorney-client privilege. This is the #1 thing that I wish that my clients understood and that I wish that they understood before they hired counsel, right? And when they're working on these kind of like one-off projects at the beginning before they have kind of a comprehensive relationship with a law firm that's really like shepherding through their business. Because this is an area where you can do a lot of good work and a lot of mitigating risk if you understand what you're doing. Attorney-client privilege protects confidential communications between an attorney and a client for the purpose of giving or receiving legal advice. The privilege exists primarily so that people can ask their lawyers for advice without worrying that that will be used against them later, right? So there's all, like, particularly in the US legal system, there's a lot of disclosure. Most of what you say is eventually going to come out in public, or at least in the, public in the context of a litigation. But the conversations with your lawyer are special and they're unique because you want people to be able to come to you and say like, hey, I'm thinking about, selling crypto in Iran. Is that a good idea? And then I can say, no, do not mess with sanctions. I don't know if I'm allowed to curse on stage. And that's the purpose of the privilege, right? It's to make sure that you can really have those open and honest conversations with your lawyers and get the advice that you need. A necessary ingredient to protecting the privilege is a lawyer, right? So one consideration, we talked about earlier when to hire legal counsel, one consideration might be if you find yourself making decisions that you're like, this feels like a legal decision, right? Or I'm getting some informal advice from lawyers, or I'm looking things up online, and I would really like this to be privileged and to be protected and to be in the context of that, protected relationship where I can really test the boundaries and ask the questions that I want to ask without fear of reprisal or without fear of that coming back to be used against me later. The privilege will apply whether you use outside counsel or in-house counsel, as long as it's with a lawyer and for the purposes of legal advice. Why is this so important? Why am I spending probably half of my time talking about privilege? I'm going to back up a little bit and talk to you about what happens when you get a regulatory notice of investigation or subpoena, or when you get involved in litigation. It's not fun. All of your documents are going to have to be handed over, pretty much, right? So when we get, one of my clients gets a letter from the SEC saying we're investigating, or some private plaintiff says, hey, I'm about to bring this claim against you, the first thing that we have to do is protect all of the documents that exist that might be related to that potential litigation or regulatory action. Right? And then as the matter progresses, we actually have to start handing those over to the other side. Again, this is the US, other countries have a different practice. So what that looks like in practice is like we're going to Slack and we're pulling everything in Slack from an admin level. And then we're ingesting it into our legal systems at Fenwick. We're determining what's related to this litigation, and that's going across, right? We're pulling everything from Google Drive, right? And those things are going to go across if they're related to litigation. We're pulling people's phones, right? If you use Telegram, if you use Signal, if you use WhatsApp, if you use text messages, we're taking copies of your accounts on there and we're turning over those communications to the extent that they're related to the litigation. And there's really not a lot that stops things from going across, right? Like, this is the way we do litigation in the US. The whole idea is that, like, you want to, sunlight is the best disinfectant. We want to bring out all the facts so both parties understand what's going on. It's very noble. It's a very big pain when you're actually dealing with it in the real world. The main way that we stop things from going across is if they're privileged. Right, so if you have conversations with your lawyer, right, that are privileged conversations, those are almost never going to be turned over to the other side. They're almost never going to be turned over to the government. So that's why this is such an important area to protect, because you don't want to be in a position where you've been building, maybe getting some casual legal advice. You've got a lawyer who doesn't really understand how privilege works in this context. And then you get, a year later, you've got an SEC inquiry, and all of those conversations that you would have wanted to be protected, or maybe even thought were protected, are going over to the SEC so they can see exactly what you were considering and use that against you and kind of make it look like you were trying to do something that was, illegal or wrong. I don't have time today to go over all of my key points about how to protect privilege, but I'm going to give you a couple of practical tips. I'm talking about privilege for a long time. One really important thing to note is that as the client, you can break privilege by introducing parties who are not part of the attorney-client relationship to the conversation. right? So if you forward emails from your attorney to a friend or another founder or an investor or your girlfriend or whatever, like that can break privilege. So you want to be really careful about emails from your lawyers and keeping them within the safe space. As projects decentralize, this gets really, really complicated, right? Because if you have a project that starts off maybe as, kind of a more centralized project that's coming from a, development team here in the United States, but then as we get closer to token launch or some other event, we start to spin out other entities or other people become involved, and now there's an overseas foundation, and now there's some development companies in Europe, and there's all of these other things going on. Employees are moving around among these entities. People who used to be part of the privilege aren't part of the privilege anymore, depending on the stage of decentralization you're at. Right? And I think this is something where it really becomes important to have a lawyer who understands the industry, because that's so different than in a normal Web2, or even just like regular company context, where it's so easy to tell, you work for the company, you're in the privilege, you don't work for the company, you're not in the privilege. Like, that's not the world that we're operating in. Third point. Only communications that relate to giving or receiving legal advice are privileged. Copying your lawyer on everything will not make it privileged. Copying your lawyer on everything will not make it privileged. People get confused about that. Fourth practical tip. Start new threads for things that you want to keep privileged. So that applies to email, that applies to Slack, that applies to Telegram, whatever. Start a whole new conversation when you're talking about something that you want to keep privileged. It makes it a lot easier when you get to the point of trying to withhold things and not hand them over because you claim that they're privileged, if the conversation is limited to this one privileged topic and there's not a lot of interspersed other things going on. Fifth tip. Questions about privilege are privileged, right? So if you find this confusing when you're starting to work with an attorney, like, this should be an area that you really explore and that you should talk to your attorney about and say, okay, like, at this stage, what's privileged? Who's in the privilege? Who's out? As we decentralize what's privileged, who's in the privilege, who's out? And keep this on your mind. And if you don't have a lawyer who's flagging these issues and who's like helping you manage where documents are going and who has access to them so that we can maintain privilege over them, your lawyer is not doing their job. Right? I think that's an area, again, like, that is so important in our space, that's so different from the way kind of traditional companies are built. Oh my gosh, did I finish with some time left? For the first time ever, an attorney is going to stop before her time is up because I've covered the things that I wanted to prepare today. Thank you guys so much for your time and attention. If you have any follow-up, you can find me on all the social medias. My handle's at Reba Matsumura, or you can just look for Rebecca Matsumura at Fenwick. Have a great rest of the time at ETHDenver. Bye, y'all.
Probably might stagger them a little.
Probably, yeah. Definitely wasn't 20 minutes between.
You're right, like maybe just slightly off a little bit. Check. Mike's work.
Huh?
Mike's work. Better than Ethereum. Those Twitter wars. Just crazy.
Yeah, so we touched Solana. You guys gonna walk around or anything?
I hope not.
Okay, cool.
I mean, I may
One
accident my face, but I should be here.
Pacing is fine.
I should be here.
Brandon, I'm the camera guy.
How's it
Hey,
going?
how you doing? Hey, I'm Ryan.
Ryan.
Kevin.
Kevin, nice to meet you.
I was about to warn them about not
No, it's
spreading
okay.
out too far.
I just want to see what you guys were going to do.
We'll probably generally stay like this.
Somewhere in
It might be a shift when I'm talking and
Yeah.
he's talking, but otherwise
Okay.
we'll be.
Just the way the cameras work, because they're like the technology ones. If you're over there and you're over there and you start talking, and you like throw it to him, I cap the can over slowly.
Yeah.
So just, if you're going back and forth, like that's all.
Okay.
We'll be close
Have
to
fun,
each
and
other.
thanks for teaching me about Bitcoin. I've been learning so much. I didn't know I needed it. So thank you very much.
Thanks,
Have fun with
Greg.
you guys.
We'll be telling you not to invest.
What are you going to tell me?
Not invest. No, just kidding.
Keep doing what you're
We're the
doing.
security talk, so everything we talk about, look for in whatever project you're going to go after.
Yeah.
All systems built on trust.
There you go.
Yeah.
Got a minute and a half. Just keep running the mic.
Okay. Thank you. Try not to pace too much. Sometimes I do. Try and speak into the crowd. Not look at the laptop too much. Probably all I'm gonna do. I'll get up to 20.
Yeah. What's the intro on this slide here? You are both very interested. The agenda slide. Cover what we're going to talk about.
The other slide has our name, or we knew the intro. That slide? Okay. Like we do like a live.
Now we're going to get some crowd interaction.
Really? You think so?
Might qualify.
We'll see what happens.
All right, we're going to get started over here. How's everyone doing out there? Are we awake yet? Let's hear that buffercorn yell. Oh, tough crowd, tough crowd. So we're from Highland Security. We're a security company that helps Web3 organizations to audit their smart contracts as well as just general best practice in securing their protocol. We also do a lot of work with venture capital firms and investors on investing in the space. So today we're going to do a little talk about what we find from both sides of the aisle, so to speak, on what VCs look for, as well as what you kind of need to do in 2024 in order not to get hacked. So my name's Kevin. I'm the head of services at Highland Security. I've been a security researcher on the bug bounty side and got the opportunity to go full-time last year, so really enjoying it. I'm here with Ryan today. Ryan, you want to do a quick introduction?
Yeah, good to meet everybody here. So I've been in the cybersecurity space about 22 years now, blockchain space for about 7. I'm a principal here. I also help a lot in our managed due diligence services for VCs and investors. So we're going to be bringing in some of that knowledge for you guys today.
So here's a quick overview of what we're going to go through today. We only got 20 minutes, so we're just going to go a quick overview, and then we have a PDF takeaway that you guys can get, and we'll be around the rest of the event if anyone has any more questions. So really, the first part of this is going to be kind of understanding who your kind of target market is, and then the last half of the presentation is going to be around the common things that all of the VC companies ask us, and when they're looking to do due diligence, either to make like a investment in a series round, or just kind of buy a token or use the protocol, as well as like some of the things that we would recommend anyone kind of launching this year to kind of build into their protocol. So Ryan's going to start us off here. Ryan, you want to take it away?
Yeah, thanks. So one of the reasons we want to emphasize understanding your market is that, at least for us, we're not necessarily sitting here as security zealots. We're not telling you that security is the utmost thing and it should inform everything about your business. Your business strategy should be informing your security strategy. And your business strategy generally depends on what market you're targeting. So what does your market want? Okay, maybe we're talking more DeFi than anything here, but usually they want some kind of value or some kind of return from working with you, first and foremost. Then they really want to know, where can I get the greatest return that is within my risk tolerance? So we're going to talk a lot about different markets and market segments, but each one is going to have a different tolerance for where they want to put their risks and where they want to get their rewards from. So when we look at traditional finance is getting more and more into the crypto space right now. There are ETFs coming around. Mostly in the Bitcoin area, but they're quickly going to come to Ethereum, and then they're going to broaden out, hopefully, to the rest of the cryptocurrencies and other assets inside the space. They're really used to frameworks like SOC 2, due diligence processes, but one thing that's really key for them is they have a rudimentary crypto knowledge. They're not going to understand necessarily everything that you're talking about in the crypto space. They're going to want to refer that to what they understand today in the finance space. Then you've got your maybe hybrids, the crypto native organizations that are proficient in chains and protocols. They understand the space really well. They're really investing more and more into the crypto space. But often what we're finding working with them is they have more of a rudimentary knowledge in the security space. So they're not necessarily looking at the SOC 2s or the NIST frameworks or those sorts of things, and they're looking at what you're doing in security. And then finally, we've got the degens. They're looking for price action. All they care about is, where the next to the moon is going to be. We're not going to talk about them today. They're not really going to be that concerned with your security strategy and your security policies. We're really going to more talk about the other two groups. So let's go through a couple examples. We've got a more detailed presentation here at the end that you'll be able to get later. When you're looking at transparency and you're thinking about it from a business perspective, often you're wondering, should I be an anonymous collective? Should I be working through? What should I be sharing with my community? Well, traditional finance is going to look for acknowledged identities. They are not going to invest in you or bring their money to your organization if they have no idea who you are. If you've got no corporate structure and you're purely a DAO with no backing of an LLC or something like that, it's going to put them off in some way. They're also looking for published information that is readily available to them. So it needs to be on Gitbook or on your website somewhere that actually details out the questions they're looking for. Or they're going to need access directly to you and your team to answer those questions before they're going to invest, which is going to take time away from them. Now, they're also looking for the same things that the crypto natives are looking for: the public source code repositories, some kind of open governance model if there is decentralized governance. Your vesting schedule needs to be public and needs to be transparent, so they need to know who's getting those coins and what's going on. And they need to have some kind of listing generally. Okay, yeah, you're on DeFi Llama or you're on some of these other crypto sites that they can actually get information about you. Notice none of this generally looks like security information right now. It's because what they're looking for and what all of your clients are looking for is they want to compare your strategy to their risks. And their risks are often things like sanctioned entity risks or KYC, anti-money laundering type of risks that they're looking at today, which you may not even consider into a security policy, but is something that is directly in line with their risk management practices. So what about vulnerability management? When somebody tells you you have a vulnerability, what are they going to look for? They're not just looking for an audit. Often when we're working with organizations today, they're going to have an audit, and it might be some random company that's just shown up 6 weeks ago, but gave them the best price and had some availability. That's not going to cut it for the traditional finance space, and honestly, that's not really going to cut it generally for the crypto native space either. They're going to look for the auditors that they trust, which might be different depending on the organization. So if you already know who your target market is and you have contacts with them, ask them who they would like to see you get an audit from. And don't just take any company that you actually see. Bug bounty programs are a little more open for that. It doesn't have to even be a hosted bug bounty program. It can in some ways be private if you're a big enough organization and trusted enough. But you have to have enough of a bounty to match the amount of TVL you have or the value that they're putting into your project. And then finally, this is something that we see missing in a lot of places. It's how you're actually going to respond to a notification that there is a vulnerability. Do you have an upgrade path, or do you have a migration path, for example, for your clients? And is that something that you're transparent with your user base on? Now, the crypto natives are looking more of like, do you have multiple audits or not? Is the audit over the last code that you've pushed on chain or not? Or is it something from a previous version? And are those auditors actually acknowledging the audits? And what I mean by that is some auditors can post the audits that they've done on their site. Some of them don't. But for things like rug pulls, that kind of thing, nowadays they're actually saying they're getting an audit from a certain organization. They might even claim that they got it and it went great. But if there's no public availability for that audit file as well, and if it's not posted by the auditor themselves, then there's less trust in that audit. So you need to find somebody who's actually going to stand behind the audit that they've done. And then finally, from a control perspective, when you're looking at how much control do you have over the project that you're deploying, you might want it to be incredibly decentralized. No one has control over it at all. It's completely immutable, and you want it to live on its own after you launch. Those are great ideologies for the space, but they sometimes don't line up with the TradFi or the crypto native expectations right now. TradFi is looking more of like, do you have the ability to actively respond? Take USDC, for example, that can blacklist addresses that are sanctioned or that were involved in a hack. They're looking for those types of capabilities. They're also looking for you to have some kind of strategy when it comes to crisis management or managed response capabilities and what you can actually do. And first and foremost, on this entire list, they want to make sure that they limit their exposure to sanctioned entities, which means if you have controls that can help them do that, you're much more attractive. Now, here's where that does not necessarily map with the crypto natives. They're much more accepting of decentralized protocols and capabilities. They want to see some DAO governance. They probably want to participate in that DAO governance. And they want enforcement of things like multi-sig, time locks, et cetera, for things like code changes. Now, there are a lot more examples of this that we'll be able to share after the presentation, but here's just some things that you can look at that might inform your strategy.
Awesome. So now that you have an idea of kind of what your strategy should be and kind of base it off of who your target market is, let's take a look at kind of how most protocols are approaching security today. If you notice that this is a very code-centric, code testing type of methodology, there's this period of kind of building, like a lot of what's going on here this week, where code commits are flying, people slinging around code. You get to a point where you have a good prototype and you want to launch it, and you start talking to audit companies. A lot of audit companies now, you need about a 6-month lead time, depending on who you are, which is kind of crazy. But you go through this loop of audits or multiple audits, fixing vulnerabilities, re-auditing, and this kind of like nth degree circular pattern. And then you ultimately launch. Inevitably, what we've kind of find out that this approach doesn't really work because there's either going to be a hack where you lose money and get it back, or a full kind of compromise where you're out funds. And that's kind of where the response aspect comes in. So if you haven't really thought about some of the security items that you need to do up front, this could be a bad day for your protocol, and sometimes even kind of like protocol ending in a lot of cases. Nowadays, you can usually negotiate to get like something back, but I would say that's not a really good thing to rely on. So the way that we like to look at it is a little bit more of a holistic approach. So we have this long list of security items on the left. We're definitely not recommending that you do everything in this list. Again, it kind of comes back to your strategy and kind of what your target market is going to expect. But what we do recommend is the earlier that you start kind of thinking about this, the more value you'll get in the later half of the kind of development process. So if you look at a little scale here, some of these kind of items, if you think about them up front, really go a long way. So I think out of the top two there, I think really are kind of minimum table stakes nowadays. With the cybersecurity program, a lot of funds are lost just to kind of your Web2 social engineering and kind of phishing attacks. Those problems have kind of been solved. You can get software out there. There's lots of resources out there that you can kind of reuse for Web2. We don't necessarily need to reinvent the wheel for that one. I think a threat model is also a really great place to start. Basically what a threat model is a design document where you kind of just list out all the likely threats that your protocols will face and how you're going to design your protocol to be resilient to those threats. After that, in the pre-launch phase, there's a whole host of things that you could do. I think a lot of this is really based, again, on kind of your code, who your target market is, what your tech stack looks like. I think some capabilities in all of these phases are generally a good idea, just to kind of, the tricky part with security is you're only as strong as your kind of weakest link. It's a very cliche phase in the security phase, but it's unfortunately very true. And then once you launch, again, there's some activities that you should keep in mind here. I think the big one that Ryan kind of mentioned is a bug bounty program. A lot of people kind of associate bug bounty program with like Immunify or some of those other big kind of hosted providers in the space. It really doesn't have to be that. I think you could do your self-hosted one. I think the point is if you just have a public place where people can come to report you vulnerabilities, that's really what you're going for there. All right. Now we're going to get into the meat of the matter here. So with all of that being said, every time we talk to kind of these VC firms, potential investors, and the like, this kind of all comes back to 6 things that they all kind of look at a high level. Within these 6 things, some of them have different kind of tolerance thresholds of like what they like to see. But if you have an element of all of these 6 things, you're going to be in a good spot, particularly with the VC firms. So the first one I kind of mentioned is like a basic cybersecurity program. Again, this stuff is out there in the Web2 space. We don't really need to reinvent the wheel for Web3. I think it's just all about understanding who your threats are and then tailoring something to that. So if you look at things, it seems like most people are using kind of Google Drive, some sort of like messaging Discord, just some like kind of basic hardening and some security hygiene in that space really goes a long way. The next kind of component here is access controls. Really looking for like a tiered access model. That could be through the use of kind of multi-sigs, but then also with something like OpenZeppelin's access control, ownable libraries, really kind of defining each of roles and what they should do, and then kind of having that associated testing, which is the next one, to really test out those roles. A lot of easy, low-hanging fruit vulnerabilities that we find just comes from a function that didn't have the correct modifier, and somebody can set a rate that shouldn't have be able to set, and people lose money that way. So really kind of understanding that in a threat model of who's going to be interacting with the protocol, who's the trusted entities, what should they be able to do, what should they not be able to do, where's the checks and balances. That really can be done at design time, and it pays dividends later. The next one here is really doing some product security testing. So it seems like everyone at least has like an integration test suite done where they're testing different functions, making sure they all work together right. We're telling our clients nowadays to kind of embed some security tests in that. It's not a silver bullet, of course, but you can actually find a lot of like things that you probably shouldn't have an auditor telling you that just like kind of like should be done in the pre-audit phase to during this step. So the other area that we didn't really mention that much is defining invariants. So an invariant is a condition of your protocol or system that should always be held true. These are really good to define in design phase, and then you can actually build some tests to make sure that they are true. Things like for an ERC20 type token, total deposits and should always equal the total supply. Things like very basic conditions like that. And then you can also add some kind of fuzzing around those invariants as well to really find those edge cases which tend to lead to the vulnerabilities. As Ryan mentioned, and I mentioned earlier, there's a lot of hacks still taking place. I think in our primer we said 1 billion last year. It's probably actually closer to 2 billion was lost. So having some sort of plan for the inevitable really goes, it pays dividends, right? So if you have some sort of like, okay, how are we going to detect that something's wrong? Like, ideally, you shouldn't be relying on your community in Discord telling you that something's wrong. Like, you should have some kind of canaries in the coal mine up front to know that, hey, we have an issue that we need to take action on. And then I think another key part of that is like, who is going to take what actions? A lot of teams are very small that we work with, 3 to 5 developers, maybe some contractors mixed in there. Having some understanding of who's going to do what before something happens allows you to kind of respond a lot quicker, pause a protocol, or take some other defensive action to really kind of minimize any kind of impact that happens. Kind of hand in hand with the incident response plan, specifically with crypto native and the TradFi, kind of publishing some elements of your plan also is a very good practice that we like to see and the VC firms like to see as well. Just to have your community kind of knows what to expect if something does happen, whether that's, hey, we'll still be able to withdraw the funds, maybe we just won't be able to do other things in the protocol, or if you can, like how they might be reimbursed, like maybe it's a governance vote, whatever you decide is appropriate for you, this is kind of a good spot to kind of publish that in your docs. And then the last one here is really around secret material protections. So this kind of goes hand in hand with the first point of, it all comes down to your keys at the end of the day, right? Not your keys, not your coin is like a big phrase that I am really a proponent of. A phishing attack can really hurt protocols. So just having some sort of technical solution to protect your key material, whether that's using something like a multi-sig, like I mentioned, where there's an appropriate threshold. It could be something like Fireblocks. That's a good option as well. But just having some strategy around that, like if somebody clicks a link, it's not a total kind of protocol loss, because it's inevitably going to happen that even I hate to admit it, but I've been phished as well too. It just is too common. If it's super targeted enough, it's almost impossible not to fall for it. We're coming up on time here, but we'll be around the event for the rest of today and the rest of this week. If you guys have any questions or want to know some specifics for your kind of protocol, happy to talk to security. We also have a QR code if you want to scan that and you like this content. We're going to be sending out all of this in a guide format so that you can kind of take this and as you're kind of building, integrate it with your protocol. That's all from us, but thanks for listening, and we'll be around on the side if anyone has any questions.
Hi. Hi. The topic of my talk is the hard kind of censorship resistance. So who am I? My name is Eric, and I am the creator and maintainer of Geth, an open source circumvention tool. So a circumvention tool, you can think of it as a VPN for places like China that actually have a lot of technology to block VPNs. So it's like an adversarial VPN. It has more than 500K daily users, mostly from places like Iran and China, where other VPNs don't work. For the past few years, I've also been working on MEL, which is a new clean slate blockchain optimized to interoperate with off-chain code through light clients. That's somewhat of a mouthful, but the idea is that it's a blockchain designed to be consumed through light clients by off-chain code and give their security to off-chain code and not primarily be consumed by smart contracts. So this talk will have two overall parts. First, I want to talk about two different kinds of censorship resistance. There's the kind that we always talk about in crypto, but there's also a much trickier to solve kind that I will want to call ban resistance. And then we'll also look at how can we make Web3 ban resistance, which turns out to be a lot harder than doing it in traditional systems like VPNs. So usually in Web3, when we talk about censorship resistance, we mean something like the protocol can't discriminate against particular use cases, right? Like you can't co-opt Ethereum to freeze accounts, taint coins, or damage the blockchain's neutrality. At least we hope we can't, right? That's what we say when we say we want Ethereum to be censorship resistant. And this is the usual sense that we use the word in the crypto Web3 world. We mean a property of the protocol, that its integrity is protected, that it's, everything inside it is fungible. And we actually know how to solve this pretty well. The nice thing is that decentralization plus encryption is pretty much a silver bullet for this sort of thing. You know, decentralization means there's no central point of control, hopefully. And privacy techniques such as ZK things and encryption reduce visibility by these nodes, et cetera, into actually what users are doing. And the idea is that you can't censor transactions if you can't even know what's going on the blockchain. But there's actually a completely different kind of censorship resistance that's also really important, which is actually a more common notion of the word censorship resistance in the privacy tools and censorship circumvention tools space, which I'm also very familiar with. This kind of censorship resistance means that the entire protocol resists censorship that denies usage of the protocol. So to use Ethereum as an example, we're not talking about nodes censoring transactions or validators censoring some smart contract. We're talking about nation states and ISPs shutting down or blocking access to, let's say, all of Ethereum traffic. And so for clarity, just so that it's not confusing, I'll call this kind of censorship resistance ban resistance, since it's resistance against banning the protocol itself. And there's a whole area of research into this, producing tools like Tor pluggable transports, steganography, et cetera. But the interesting thing is that ban resistance is not actually a common goal in Web3 projects. Even the most privacy-focused Web3 projects are easily blocked in places like China. And that's very unfortunate because a large fraction of internet users actually use networks where ban resistance is important, and perhaps even more important than our usual notion of censorship resistance. And these adversaries are really common, like China, like Iran, like Russia, et cetera. And they use these powers a lot to interfere with new protocols. So how do we actually achieve ban resistance? Well, the first thing to know is that it's actually possible. There is this common misconception that if you want your thing to work in China, it's just like a security by obscurity game and you can't defeat the Chinese firewall. That's not true. We actually have good methods of achieving strong ban resistance. However, they are all rather imperfect. It's definitely not as mature as our solutions for censorship resistance. And the worst thing about this is that all the current methods are hopelessly centralized. And this is really scary because we actually want ban resistance for decentralized apps. It's a little hard to explain what I mean by hopelessly centralized, so let's just look at a concrete example, which is the usual way state-of-the-art circumvention tools, like censorship-resistant VPNs, basically. How do they work? That includes Tor's Snowflake project. That includes my own project, Geth. It includes other projects like Lantern. They basically all follow this architecture. I don't think there's a kind of name for this architecture or design pattern, so I'm just going to call it Snowflake-style bootstrapping. But the way this works is that we first have a broker. And what a broker is that it's a central server that's accessible through a transport protocol that has a property known as collateral freedom. What does collateral freedom mean? It means that if you want to block that service, you have to block a lot of other innocent services and cause a lot of collateral damage. So one example would be, let's say you have a GitHub repo, and you push code to that repo to upload it to the server, and you pull code from that repo to download it from the server, and the server is on the other side looking at the same repo. In this case, it's really hard to block access to the server without blocking access to GitHub, which will ruin a lot of other people's days. And the interesting thing is that the broker doesn't need to be very fast, right? This transport can be really clunky and difficult to use, but the idea is that we now have this unblockable broker that cannot be blocked without massive collateral damage. The broker then gives different users different proxy servers or VPN servers or whatever nodes you want. And this means that if you're the bad guy, you can't just talk to the broker, get the list of all the servers, and block everything. The list of servers you get will be the different list of servers will be different from the list of the servers that your victim gets. So you're only going to be blocking yourself, not anybody else. And finally, the users connect to these proxies with obfuscated protocols. What this just means is that if you're the bad guy and you are the ISP, simply by looking at the packets, you cannot detect that, let's say, this looks like Tor. So you can't block the central bootstrapping point, you can't list the servers, and you also can't can't detect the traffic by their protocol signature, and thus you have ban resistance. This is like an illustration from Tor's website on how Snowflake works with the broker, the client in the little bubble, which is like China basically, and getting a list of Snowflake proxies and then using those to get to the destination. Now, just from that description, we already see this is inherently centralized and Web3 incompatible, so to speak. Well, the broker, first of all, has to be trusted. It knows everything. It can betray everybody to the censor. And not only is that the case, we also rely on external Web2 services like GitHub for collateral freedom. The idea is that you have things like GitHub that, one, they're too big to block, and two, they're actually not under the control of the censor. So the censor cannot tell GitHub to block this repo. And this is something that's true for China and Iran. That's not generally true. This is a very specific case that sometimes happens. And overall, this is very much not in alignment with Web3 goals of trustlessness. We don't want to just imagine that the world outside of China is trusted and we can just trust GitHub and Amazon or whatever. So far, we have a pretty bleak picture. We see that censorship resistance against protocol internal discrimination, the usual sense we use the word, is achievable through decentralization and cryptography. Lots of projects do this pretty well. But censorship resistance against banning the protocol is really hard to reconcile with decentralization. And we looked at a specific example to see how difficult that is. But actually making decentralized networks ban resistance is really important. Because when we talk about censorship-resistant Web3, we really mean stuff like user autonomy, economic freedom, etc. But all these things mean nothing if the system that supports it, the access to that system can be arbitrarily denied to people. And more interestingly, threats of banning a protocol can also subvert internal censorship resistance, like the one we usually talk about in Web3. What if somebody says to a project, please remove your privacy features, or we will unlist you from exchanges, or we'll block all your traffic from China? Then perhaps the internal censorship resistance of that protocol is not that secure either. So how can we build a decentralized system that has a ban resistance? Well, my first idea was, can we build decentralized collateral freedom? Can we make a decentralized protocol have the sort of social dynamics of something like GitHub or Amazon CloudFront, where blocking this one protocol means breaking a ton of innocent apps? This initially sounds really attractive, right? Because first of all, we all want popularity and mass adoption of Web3. Here, it actually helps ban resistance rather than conflicting with it. We don't need to stay under the radar. And even if this one protocol is super slow and clunky, let's say only Bitcoin makes this, maybe we can bootstrap from this like we do in Snowflake and get like composable ban resistance for everybody else. The unfortunate thing is that I don't think this is likely to work. There are two main problems. First of all is that, yes, maybe if Bitcoin really makes it and like every single government thinks that it cannot ban Bitcoin, sure, but how do you get to that scale without somebody killing you while you're still growing? And the other more subtle point is that for a lot of protocols, like cryptocurrency protocols, the censor can block the good part of the protocol that's actually censorship resistant while minimizing collateral damage. Let's say you have a world where you still can use Ethereum, but you have to use custodial wallets, you have to use approved RPCs, and something like the Great Firewall of China makes sure that this is enforced by banning other traffic off the internet. And well, in that case, the collateral damage would actually be pretty small. Most of the ecosystem would still work, except the few things that the censor doesn't like. So instead of collateral freedom, I decided to go another direction, which is decentralized information asymmetry. Remember back in the Snowflake design, we had this broker that gave every person different servers. Can we replicate this every user sees different servers part of Snowflake in a decentralized network? And the really interesting thing is that if you have an invite-only peer-to-peer network, that is possible. So just as a very simple toy example, imagine every user connected to a few friends using obfuscated protocols. So you can't detect these connections by looking at the packets. And we actually have pretty mature technology for doing this. And users only know their friends in the protocol. They cannot ask their friends to tell them about their friends. And they never learn anything more about the network. And users can only join by being invited by people. And then messages can be broadcasted with gossip. So you have a topology something like this, where every node has a few friend neighbors. But if you're the green node there, this is all you ever get to know about the network. So even if you are evil, you can only blacklist those three nodes. And the damage you can cause to the rest of the network by cooperating with a censor is very limited. And this is really ban resistance because censors can't find nodes by looking at packets. And censors can also not enumerate, the nodes. That's the name of a project I was working on. But you can't enumerate the nodes because you can only see the immediate neighbors. And you have to fool every node to manually friend you for you to block them. So this is enough to run broadcast networks like blockchains. This is already quite interesting, this design. Although there are obviously two problems. Broadcast doesn't let you run most interesting things. It pretty much only lets you run blockchains. It's very inefficient for stuff like actually talking to a web server. Also, incentives and scaling, right? Like, imagine you're in this friend-to-friend network. There's no reason why you would add more friends because all you're doing is increasing the chance that you give your information away to somebody you don't trust who works with the censors, and then you get kicked off the network in China. So you have this incentive problem where everybody's interest is in not growing the network, and this obviously doesn't scale. And so how can we extend this to a general purpose network? It actually turns out that it's possible to do so. You can actually efficiently route two-way communication, not just gossip. The solution is that you can actually gossip a global routing table without the IP addresses of the nodes, so that every node has a good picture of where to send packets to get to that particular node. You can also add NIM-like mixed-net features to improve privacy and actually improve like network internal censorship resistance, the first kind we talk about. You want the nodes in the network not to be able to censor each other. And most importantly, you can actually add incentives. You can incentivize nodes to actually find and maintain peering relationships with trustworthy friends, and this makes scaling possible. If I know somebody where the profit I get from peering with that person on the network is greater than the potential loss from that person actually working with the government and blocking me, then I will actually be incentivized to grow the network. So I am actually working on such a general purpose band resistance network layer called Earendel from a character in Tolkien's Legendarium. So what is an Earendel? It's an experimental peer-to-peer communication protocol designed to be the first strongly band-resistant decentralized network. So it uses this sort of friend-to-friend information asymmetry system that I discussed. It has privacy goals similar to NIM or ITP. It has an API similar to the internet, so you have addresses, you send packets to other addresses. And it has a really simple incentive system based on if you send traffic, you just pay your immediate friend who handles the traffic. This is inspired by how you pay for bandwidth on the internet. You pay your ISP, and your ISP pays their ISPs. And this is also a foundational protocol in the larger project which I'm working on, which is called MEL. So MEL is a blockchain, but part of the MEL vision is that the composability happens off-chain, not on-chain. And you want this ecosystem of composable network protocols that judiciously use blockchain-like clients to secure themselves. And they don't run on the blockchain. So in Earendel's case, we just use the blockchain for incentives and anti-spam, and there are no like smart contracts other than that. And Earendel is composable with any network app that needs band resistance because it has the API of the internet. It's not really like a MEL ecosystem project because that doesn't really exist. The MEL project is really about building blocks that any internet app can compose with. So the current status of Earendel is that it's open source, it's in early public alpha. Most things other than the incentive system are done. We already have a few dozen volunteer nodes. A lot of them actually come from places like China and Iran, and the obfuscation does work. The traffic is still flowing. We eventually want to integrate Earendel as a backend to my other project, Geth, which is a currently centralized circumvention tool with a large user base. And we want this to be a kind of experiment to deploy the first large-scale peer-to-peer network that's dark and band resistant to ISP-level sensors. And we also want Earendel to not just be like this project that me and my small team at MEL works on. We want it to be something that has a lot of community input because it's such a composable piece. It has the API of the internet. So you can find our docs at docs.earendel.network, and you might want to help out if you're interested in anything related to protocol obfuscation, mixed nets, payment channels or state channels, or anything related to decentralized networks and band resistance. So yeah, that's our website and GitHub and Discord. And thank you guys for coming to my talk. I'll be around if you have any questions. Thank you so much.
ready to go? All right, awesome. Yeah. Hey, hello. Hi, everyone. I'm Samantha. I am the content editor at Aragon, where we build modular DAO tools for protocols and organizations to govern their assets on-chain. So today, I'm going to be talking about future-proof governance and how that can enable future-proof protocols. So to kick us off, I'm going to talk a bit about the state of governance today. And in order to do that, I have to queue up my burning room. So DAOs today are undeniably having some struggles. There are a lot of people out there who say that DAOs don't work, members don't care enough to participate, voter apathy is off the charts, and DAOs are just facing a lot of headwinds in the current discourse today. And I believe that the reason that DAOs are running into these struggles and that there are a lot of doubters out there is that honestly, they just have a lack of reliable and secure governance options that fit their needs. And the same thing goes for members as well. Like, the members realize when the DAO is using a generic structure that doesn't work for their organization's unique and custom needs. I see most DAO structures today as the generic no-name coffee brand on the shelf. It's mostly just token voting with maybe a little bit of delegation sprinkled on top. But other than that, DAOs are pretty much using the same generic structure copy-pasted over and over again. And so that leaves DAO members to be sipping their generic coffee, sitting in the burning room. And using this type of cookie-cutter governance can cause a lot of problems, especially for large DeFi protocols when they're thinking about their governance. So some of these problems include holding back from decentralizing properly, because when you have the wrong on-chain governance, there's a ton of risk associated with that. So instead, protocols might stick with a trusted structure or just occasionally throw out a signaling vote, but actually decentralizing on-chain is risky. And another problem that they run into with cookie-cutter governance is that they end up using the same model throughout their life cycle. And that's a problem when you have different levels of protocol adoption, because when you start your protocol lifecycle, maybe you have a small group, 5 people, 10 people. You can govern that with a multi-sig pretty easily. But say you're 2 years down the line and you have thousands of users that want to participate in governance, you're going to need a totally different model. And using the same cookie-cutter structure is just not going to work. So why does every DAO out there not have a completely custom build, you might be wondering. But That's because custom governance builds have their fair share of problems as well. If you want to throw a ton of time right into the incinerator, you can go for that. Spend a lot of dev resources on building that custom structure, take on a lot of risk because it's untested, maybe it hasn't been audited yet, all sorts of things like that. And a lot of custom governance builds are very experimental and theoretical rather than being grounded in the real needs of real DeFi protocols. So how can we make custom governance safer, easier, and faster to build? Our answer is to build on a modular DAO stack. So this makes customizing governance much, much easier. So this is one of the few things Bitcoin might not fix, but Aragon OS X actually does. So Aragon OS X is Aragon's new DAO framework, which we launched in 2023, actually about this time last year. So ETHDenver coming around for us. And here's how it works. So at the center of OS X, you have your DAO contract. That contract is built to be extremely lean and simple, and that makes it more secure and much easier to work with. Then within that DAO contract, you have a permission manager. And what the permission manager does is it manages permissions to external smart contracts. And those external smart contracts, which we call plugins, the light blue boxes below, those are the contracts that change the governance logic of your DAO. So most of your DAO's governance logic is actually customized through these plugins rather than inside of the contract itself. So plugins are really what will help DAOs build custom designs for their precise needs. So you can think of them kind of like apps that you install and uninstall on your computer, because when you want to use a new one, you grant it permission through your governance process to perform certain actions. And then when you don't want to use that governance plugin anymore, you just uninstall it via your governance process. So maybe that's passing a vote, or if you have a multi-sig setup, it could be just approving a transaction. And the plugin model is safer because you're making changes to the plugins, not to the DAO vault itself. Everything is happening externally, and the vault where you keep your assets is untouched. And on top of that, you can also manage access control with extreme precision using the plugins, because say you have a treasury management sub-DAO, and you want them to be able to manage your DAO's assets so you can grow your treasury, but you really don't want them to have full access to the treasury and to be able to perform any action. You can use OS X to give them granular permissions rather than a complete blanket, do whatever you want permission. Plugins are also easy to work with because you track permissions via plugins rather than having to track them scattered across an entire DAO deployment. So if you want to make changes, everything that you need to be aware of is front and center rather than tangled up in a lot of other things. And the plugin model is also fast because you can just take advantage of the fact that they're open source. You can fork, reuse plugins. There are plugins built by the Aragon team, plugins built by open source developers, and you can use these projects rather than starting over from scratch every time. So now that you have an idea of what OS X is and how plugins work, I'm going to share a few examples of how you can put plugins together to create completely unique and powerful custom governance designs. So the first one is multi-chain governance. So we live in a multi-chain world, tons of L2s. I feel like it is L2 season these days. And so we created multi-chain governance so that you could govern assets and permissions for a protocol across EVM chains from a single mainnet Ethereum DAO smart contract. So imagine you have a protocol that has that is deployed on Arbitrum, on Base, on Polygon. You can use multi-chain governance to govern all of those parameters or govern all of those assets deployed across those chains. So how it works is you create a custom census with tokens across chains using Layer 0's omni-chain fungible token standard. So you have those Polygon governance tokens, those Arbitrum governance tokens. Just wrap them in an OFT, and then you can bring all of that voting power into one census. Then those members can cast votes for a low cost on ZK Sync, save a ton of money there. And then if that vote passes, that action that you programmed into the proposal can be executed across chains simultaneously using the Aragon OSX permission management system. So here's why multi-chain governance works so well on Aragon OSX. To start, the permission management system is flexible enough to add the cross-chain condition using Layer 0. Also, we have an unopinionated protocol design. This is extremely important in a world where there are tons of chains, and we don't know what next year is going to look like when it comes to where most of DeFi action, DAO action is going to be happening. So the unopinionated protocol design means that our protocol can be deployed across chains very easily. Then the replicable plugin system means that you don't have to rebuild your plugins. Every time you want to deploy on a new chain, you just reuse the one that you already have. And finally, the strong base plugin contracts make it so that most of the logic is already handled inside of those plugin contracts when you're building your new custom plugin. Another example, optimistic dual governance. So this is when DAOs create two separate stakeholder groups with different governance permissions and then execute proposals optimistically. So I'll walk you through it. It starts by an address on a proposal allow list, creating a proposal to the main DAO. So you can imagine these down here, these pink boxes, like sub-DAOs or maybe DAO members' wallets or multi-sigs that represent a service provider that, for example, is maybe trying to provide a service to your DAO. So they're on the proposal allow list. They create a proposal to the main DAO, which then enters the plugin, and that begins the time lock period. During the time lock period, the main DAO can veto the proposal. So the main DAO can be an allow list of a different group of addresses. It can be token holders. It can be NFT holders, whatever you want. If the proposal is not vetoed during that time lock period, then it automatically can be executed. So that means you don't have to pass a vote. That's the optimistic piece of it. And the cool thing about this model that I really like is that you don't need token-based governance to use this model. You can have one allow list on the propose end and then another allow list on the veto end, and no token is required. So why optimistic dual governance works on Aragon OSX? Well, it comes back to the granular permission management that I've been talking about. So here we use it to separate groups, give them different governance permissions, but allow those groups to still exist in the same umbrella DAO. So you don't have to be deploying a million different DAOs. You have one organization with sub-organizations inside of it, all completely on-chain. So what is this all up to? And for me, it's really making governance future-proof and adaptable. So future-proof governance is governance that can withstand whatever the world throws at it. We live in a time when we don't know what's going to happen 6 months from now, 1 month from now, 1 week from now. Everything is changing all the time, and I think if you've made it in crypto this long, you probably agree. So if we don't decentralize our governance now, protocols will be fragile. They'll be fragile to attack and censorship, especially as more and more people enter the space and more large nation states become aware of crypto, like, to be entirely honest. So we need future-proof governance, and we need it now. Future-proof governance is what will underpin truly resilient DAOs, and it's what enables them to adapt and change when the world around them does. So that's what we're doing here at Aragon. If any of this is interesting to you, if you would like to build a custom DAO, scan that QR code. It leads to a form where you can input some interest, share about your project, your protocol, and we'll be back in touch about how we can build a custom DAO for you. So thank you.
Hey, everybody. Thank you all for being here. I'm Slater Heil. I'm the founder of Composable Corp and a few different protocols. The one in question here being StakeUp. It's a yield-bearing stablecoin with treasury bills as its backing. And I wanted to talk today about kind of the first principles of stablecoin. What really is a stablecoin? How does permissioning work within stablecoin systems? And how do these RWA integrations that have become very trendy lately kind of play into that permissioning spectrum? So what really is a stablecoin? I think the best analog for the regular person is kind of like a bank deposit or a bank liability. Basically, it's a system where collateral exists and carries risks of redeemability for $1 related to its mechanisms of issuance and redemption, its collateralization, and its accessibility. And those risks play out in very different ways depending on if it's a more centralized system like a bank or if it's a more decentralized system like a protocol. So just to make a few examples there, right? The risks of a bank deposit are pretty clear and well understood. You often have duration risk, like we saw play out with Silicon Valley Bank and others in the last few years, where let's say you're holding a long-dated bond with a very low interest rate, and all of a sudden all of your depositors want to redeem their effectively stablecoins or their deposits for an actual dollar. You have to go and sell that collateral. And if that collateral is sitting at a loss, there's a chance not all users are going to be made whole. So that's kind of how a traditional banking system works. There are still, of course, clear rule sets, but it's based a lot on human discretion within those rule sets, which affects the risk of actually being able to redeem for $1. With a protocol or a stablecoin, generally, depending on how decentralized it is, you have a much greater guarantee of redeemability, but of course it still does carry risks. And again, those risks are related to the level of decentralization of the different components of the stablecoin system. So before we get into the details of different types of stablecoins, I want to talk about just what's the point of DeFi, right? Like why bring these why bring these bank liabilities, these IOUs of dollars into the on-chain ecosystem? The first and foremost reason is that counterparty risk is the biggest hidden risk in all of traditional finance, right? There's the classic saying, know thy counterparty, because in stressful black swan market situations, that's really what ends up getting you, even at a large scale. When your counterparty blows up, there's not a whole lot that you can do about it, even though it generally only happens in pretty extreme black swan events. So the point of DeFi, from a first principles level, is that we can trade off counterparty risk for smart contract risk. Instead, we can write rules with systems that are going to self-execute and do exactly what they say they are going to do. So we no longer have to trust a counterparty to do what they say they're going to do. What this does at a more specific level is eliminate the risk of discretion and collateral integrity, right? So I already mentioned Silicon Valley Bank. They were holding a bunch of long-dated bonds at 1%. Interest rates went up to 5%. All of a sudden, they're sitting on massive losses, and none of the depositors can really know that, right? Like, without complete transparency about the backing of any specific bank. And really, how can you expect the average person to understand that, right? The average depositor to understand that. And the last piece is you can now enable universal accessibility, right? So once you have a stablecoin on chain, anyone, anywhere that can access the network that it's on can access the stablecoin, rather than having to go through the arduous KYC and identity verification processes that you need to have, as well as regulations that you need to have in a banking system. So there's a lot of value in bringing these things on chain. So what does it mean for a stablecoin to be less or more decentralized? I think there's three different components here. The first is its mechanism of issuance and redemption, right? So in the example of Tether, the largest stablecoin, you have a pretty simple issuance and redemption mechanism, but it's not really decentralized, right? Where you have to have a Tether account, it's kind of a Web2 system, you have some fee baked in there, and they have an internal system that matches up the collateral with the redemption. Now, of course, the actual issuance of the USDT is decentralized, it's an ERC20, it's true of every stablecoin, but the system of issuance and redemption is centralized. A different side of that is like liquidity, right? Where It's completely decentralized. You put in one token and you get out the stablecoin no matter what. Then, of course, there's decentralization of access, which I kind of just spoke about. Whether or not you have to go through KYC constraints to access the stablecoin is a pretty big differentiator, and that's one of the things that's starting to happen more and more with these RWA stablecoins. Last but not least, probably the most important piece is the decentralization of collateralization of the system, right? So there's a few different kind of models you can have here, which we'll get into more as we go, but this is by far the most important because humans can lie, right? So the point of this all is eliminating the risk of humans lying, instead making smart contracts that always do what they say they're going to do. Here's kind of a nice spectrum of the most important stablecoins in my view and their levels of decentralization from Liquidity down to the kind of RWA stablecoins at the end. If I had to give a level, 1 through 3, of the levels of decentralization, the first would be fully decentralized and autonomous, absolutely no governance. And no governance is very important, right? Because even if your governance is decentralized, people can still vote for the wrong outcome that's going to have a negative impact on the system. The second is governance-operated parameters and discretion of collateral, but smart contract issuance. So this is something like MakerDAO, where it is all decentralized in a widely distributed governance mechanism. However, there still can make the wrong decision, as I mentioned. But once those decisions are made, the actual issuance is completely done by smart contracts. It's guaranteed to do what it says it's going to do. The third is fully centralized and permissioned. USDC, USDT fit in this bucket, as well as the ones that have a little bit more of a layer of permissioning, like Athena's USDE, USDM from Mountain Protocol, and USDY from Ondo. They introduce an additional layer of permissioning where you actually have to be KYC'd to issue and redeem, which is kind of against the ethos of Web3. Why does decentralization of access matter? I think this is a fairly self-explanatory question, but of course, the goal of DeFi is to democratize finance, right? To make the best available financial products available to all of the world, not just the privileged. And the more important piece, which is maybe a little bit less spoken about, is composability. The real value of bringing an asset on chain from a practical perspective is pretty much entirely predicated on composability, on the ability to start with one asset, add it into another system to make more yield or provide liquidity, whatever you're trying to do. Composability is essential to really the function of all of DeFi. However, the issuance and redemption decentralization is probably the most important part, because if you have a centralized issuance and redemption process, regulatory concerns could, for example, lead to a total loss for a holder, right? Like maybe Tether, for example, were to get enforced on and their treasuries seized. In that black swan scenario, all of a sudden the millions of people around the world holding Tether could be subject to losses. And of course, like we already discussed, like the Silicon Valley Bank example, a centralized issuer and redeemer can make a bad decision about collateralization. They can make mistakes, or they could even perform fraud, right, and issue more than they truly have the collateralization for. When a smart contract does it, this is no longer possible. Last, again, it threatens composability. If there is a KYC process to issuance and redemption, generally you can't have full composability and stack those yields on with others. Most important thing, again, I've hammered the point home a few times, but humans are flawed. That's why we're inventing the system. That's why we're moving to a DeFi standard. So we no longer have to rely on the decision-making of people, which are by definition flawed. Instead, we can guarantee we get the right output from our inputs using smart contracts. So the big trend of the year so far has been yield-bearing stablecoins. And the reason I wanted to give this talk is because I think there's fair reason to be concerned about the decentralization trade-offs that occur for most yield-bearing stablecoin models. The trend, however, is very positive, right? The ethos of Web3 is to share value with your users as much as possible. So seeing stablecoin issuers go from a model of hoarding all the yield from the backing collateral to now sharing that yield with their users is overall a very positive trend. However, the trade-off is centralization in a lot of cases, as well as KYC constraints. And so KYC constraints, period, are I think generally against the ethos of Web3, but more important from the composability perspective, if your token has a whitelisted, permissioned transferring system, it just can't be compatible with DeFi, because DeFi is permissionless by nature. Not only are DAOs not going to want to take the risk of adding on a KYC potential security asset into their permissionless protocol, it often might not even be possible if your asset can only be transferred within a whitelisted system. A lot of these stablecoins also market themselves as permissionless, but they have US users blocked, right? So that's kind of a contradiction. There are some somewhat clever regulatory arbitrages happening where the layer one, the first issuer of the stablecoin that's actually interacting with the customer, or sorry, with the issuer, is KYC'd, and then permissionless transfer is enabled thereafter. And this is kind of a clever way to get around KYC constraints, but the problem is that other protocols that are fully composable and permissionless are still not going to be able to integrate those assets, because now they're taking the risk of sharing those assets with the US users, which are not supposed to be able to access them. So this is not a long-term solution. Like I said, if you're not truly permissionless, you're going to limit yourself on DeFi integrations. Maybe you'll get a few different partners to integrate here and there, but if you're transferring regulatory risk to the partners that are integrating your products, it's not going to be a good long-term solution. And then, of course, even if you are starting to share more and more of the value of the collateral backing of a stablecoin with your users, as long as you have a centralized entity in existence behind the issuance process, you're still going to be extracting some level of value, right? So as long as you're not a full DAO, full token operated protocol, if you have a centralized issuer somewhere in the process that's taking fees, it's still value extractive, which is going to make it difficult to compete with RWAs on a net-net yield basis. So one of the things we're trying to do at Composable Corp, my company, is introduce what we think is the closest thing possible to the perfect yield-bearing RWA stablecoin. The first piece, of course, is decentralization on all the strata we mentioned. The second piece is yield-bearing with negligible economic risk. So in my view, this means only pulling interest from the risk-free rate. The third piece is 100% value sharing with its users, no value extraction from any centralized entity. And the fourth piece is regulatory compliance and non-security status. You can learn more about how StakeUp does this on our X account, which is kind of posted there. And that's it. I think I'm a little short on time, but yeah, thank you guys for coming and listening to my talk.
Should I start or? Huh? Mic check. All right. How's everyone this afternoon? Okay, so my name is Wei Dai. I'm a research partner at 1KX. We're an early stage focused crypto investment fund. And today I'm here to talk about scalability, in particular about trust minimization and horizontal scalability. So I hope I didn't just lose you guys right there. Raise your hand if you know what trust minimization means. Okay, I see at least 5 hands. Great. What about horizontal scaling? Great, more hands. Okay, so hopefully this is going to be somewhat educational for those of you that raised your hands, and for those of you that didn't, hopefully, hopefully, I will be able to kind of show you something that you didn't know today. Okay. This is the outline. First, I'm actually going to be defining what these terms mean, in particular in the L2 scaling context. And I'm going to be talking about some of the open directions that we have. So first off, what is trust minimization? Largely speaking, there are 2 categories of applications in relation to L1 blockchain like Ethereum. There are those that are trusted. For example, centralized exchanges, Web2 services, banks, they can connect to Ethereum, but they're always trusted, meaning something can go wrong in the case of, for example, FTX, Celsius, and you will lose your funds. And on the other side, you have trust minimized services, for example, smart contract applications, rollups, as well as validiums. These applications keep your funds safe, even though the operator might be malicious. And so that's what I mean by trust minimization. A trust minimized service, it allows you to have self-custody and allows you to not trust the operator outside of trusting the base layer network, for example, Ethereum. So if we go to more detail, there's actually different properties for L2 that require different levels of trust. And largely speaking, there are 3 of them. Liveness and ordering, meaning you should be able to submit transactions, and they shouldn't, the operator shouldn't be able to censor your transactions. Validity, meaning is your funds being used in a safe manner? Are you getting out the right amount of tokens? And third, data availability, meaning can you actually reconstruct the state of the application and then submit new transactions? And the third one is a really, really important thing that everybody's just trying to solve right now for rollups. And it turns out that every single property requires different levels of trust in different scaling paradigms. And I'm going to stay on the very high level here and just tell you that there's a spectrum here. And on the left-hand side, we have something like Uniswap on ETH L1, where you basically are making no external assumptions. And on the right-hand side, you have off-chain services like Coinbase that's completely trusted. But in the middle there, this is where we have rollups, different types of rollups, and also validiums, meaning it's almost like a rollup, but you're not posting data to Ethereum. And OK, let's jump to the second term, scalability. In particular, there's 2 types of scalability. Vertical scalability, we're making a resource bigger. OK, so 4844 is going in that direction, meaning we're making Ethereum a better DA layer, giving it more throughput. And then there's the other type of scalability, which is horizontal scalability. You are simply adding new instances of a system to make a system more scalable, right? So Web2, it's a clear example of you can add more web servers, you can add more websites, right? But we only have 1 Ethereum. So what about this horizontal scalability of the systems we just mentioned? So if you look at horizontal scalability of these systems in relation to ETH L1, you kind of get the following conclusion. On the left-hand side, because smart contracts share the L1 resource, there's always congestion. We don't have any form of horizontal scalability because we run into bottlenecks as we add more smart contracts. On the right-hand side, off-chain services operate off-chain, and they only communicate with Ethereum when they need to, right? When the users enter and deposit and withdraw, in the case of Coinbase. And so you actually have really, really good horizontal scalability. And in the middle is where the interesting thing happen, in my opinion, right? Where we can have trust minimized services, you can have self-custody, but you're able to add more and more systems on top of Ethereum and still not incur any global bottlenecks. And the interesting category here is actually smart contract rollups. So for validity, these are effectively they're like rollups, but data is not all one, right? So there's actually no global bottleneck. And for that, most people will agree. But for smart contract rollups, I actually want to zoom in a little bit more here. So my argument is that there's going to be two types of rollups. And I'm going to show you which one is which. There's transaction data rollups. So optimistic rollups are mostly transaction data rollups. So whenever you make a request, that entire request goes to R1. And there's state diff rollups, meaning the part that goes on chain is not your transaction request, but the difference between the R2 system between batches. Okay. So the examples are basically as follows. All the optimistic rollups today that we know of are of the first category, meaning you post the entirety of the data to R1. And in the case of Starknet and zk-sync, they're actually of the second category, meaning the larger the batches it gets, the data that you post to R1 actually gets smaller. And I'll show you some data in the next slides. And this is something that's unique to zk rollups. Because you can actually enforce validity even though you're not posting the entirety of data. Okay, so here's some data we collected around the end of 2023, and it's guys over a 30-day period, looking at the average data incurred by a transaction on R1, right? So these are R2 systems, and it turns out after zk-sync made this upgrade around December 2023, they effectively enlarged the batch sizes, and the call data per transaction become a lot lower than all the other solutions. And you can see this on various different charts in the form of transaction cost per transaction, because DA cost is actually the number one contributing factor to R2 fees. So, and actually, if you look closer, for the extremely large batches during those inscription events, the call data per transaction actually got as low as 10 bytes. So basically, what's happening here is, for transaction data rollups, effectively you're bounded in the data that you're lower bounded in the data that you post to R1, because transactions are of a certain format. And for state diff rollups, you actually get this aggregation benefits. So as you aggregate more, the less data you need to post to R1 per transaction. Okay, so here's kind of the one of the main points I want to make in my talk today, which is if we want to have Ethereum connected services to scale like Web2 counterparts, we have to not congest Ethereum L1. Otherwise there's no way to get kind of Web2 backend scale transaction throughput, right? And really there's two approaches. One, we don't post any data to Ethereum L1, or two, we post really large batches so that you get really a lot of amortization benefits for for the amount of throughput that you have on the L2. Okay, so here's some common questions that I think always get asked whenever I make this argument. And the first one is, why don't we just use an external DA like Celestia, EigenDA, Avail? Well, my answer to this is, first, this is a temporary solution. Ethereum is also working on a better DA solution, right, on ETH1. But this is still a global bottleneck if you use a shared DA layer. We're basically just kicking the can down the road. And we cannot add infinite number of L2s without congesting these data layers if the class of applications gets richer and richer. And furthermore, these external DA services do not inherit L1 security. And the alternative approach is, I think, we should actually create really large batches for these L2 systems and post state diffs to L1. And that's really should be the base case. We can still use external DA services for the full call data, especially if there are actually independent instances for each rollup. And we should always be posting state diffs to L1 to inherit Ethereum security. And the second question I get a lot is, how does all of this relate to shared sequencing, which is also a buzzword these days? And I think the answer is shared sequencing, just like global shared DA, is also a shared resource. And as with all global shared resources, they become bottlenecks as you add more systems. And But nevertheless, I think that's they're a great invention because they allows you to atomically compose between different L2s as if they're L1 smart contracts. So I guess if you haven't seen shard sequencers, I encourage you to look more into Astria Espresso systems. Okay, so third question that I get a lot is, like what about interoperability? As you add these horizontally scalable systems, you're gonna have more and more of them. They're gonna be more and more siloed. What do you do about interoperability? So first of all, we definitely do not have atomic composability between these L2s, unless we use shard sequencers, which have global bottlenecks. But I think async composability is also a usable solution, right? We can this can be very very seamless to users as well. So like what I mean by this, there's two great examples of recent paradigms proposed by zk-sync and Polygon. So if you look at zk-sync hyperchains, it's really a horizontally scalable system where all L2s and L3s, they call it, are connected, right, via a shared settlement. And the same thing applies to Polygon AG layer. And I think this is basically the framework that I think most of these projects are converging on, which is that we should be able to instantiate more systems, and they should actually benefit from being inside the same ecosystem and inherit the same liquidity. Okay. So finally, let me discuss some open directions I think are somewhat underexplored currently. The first thing is, of course, what do we do about data availability, right? The entire point of rollups is we should be inheriting almost security. And if we don't want to post as much data to L1 because we have a global bottleneck, what do we do? What if the data is gone? Well, so this is definitely a hot topic of debate. And a lot of people in the EF has been kind of there's a resurgence of discussing plasma-based solutions, right? Which is you don't need to put data on L1, but you still get the data somehow, and that's basically the entire class of plasma-based solutions. And encourage you to kind of read more on the post from Barry Whitehat and Vitalik linked here. And second, when there's systems are currently pretty centralized, and there's an argument to be made that they actually give you better throughput, right? Like a single centralized sequencer. But they don't really give you kind of this self-confirmation guarantee in the sense that that your transaction is it will be confirmed, right? If we're going to make these batches really large, it's going to take a long time before they settle onto R1. How do we get more guarantees for the user that their transaction is going through, right? So ideally, you want a really, really fast confirmation, but settlement could be it takes a lot longer. And so one example solution is we could, for example, have a dedicated data availability committee. Okay, I should back a little bit. So the problem is the technical solution to this is really called proof confirmation, where the user, after taking some confirmation from the sequencer, is able to slash the sequencer if the sequencer did not include the user transaction in the place that the sequencer promised they would. So I guess I don't want to get too technical here. So really, there should be a way for the user to prove that the sequencer didn't behave per the commitment. And that mechanism requires data about the system. And that's basically a form of DA problem. And so, there's kind of this, do you actually have the sequencer share data against other to other nodes so that other nodes can help users fraud-proof? In which case, your system's less scalable, or do you keep the data for the sequencer itself? In which case, the sequencer can just do whatever they want, right? So there's definitely some open questions here. But I think taking the midpoint of doing a data availability committee, this is something that Starcore does. I think it's a good immediate-term solution. Okay, and of course, there's a lot of related works. So here's a post on base pair confirmations, which is something that's very adjacent by Justin Drake on ETH Research Forum. Encourage you to take a read. Okay. Lastly, last final direction that I think is really important is we've seen a lot of L2 systems go down, right? Like the centralized sequencer can go down, and they'll just be offline for hours or days, and I think we should be able to recover from these liveness failures much faster, right? If for example, alternative sequencers are always queued up to be able to take over the work if the main sequencer goes down, we'll have much better liveness guarantee. And I think that's like one of the main UX problems of all tools, right? Is that like during periods of high demand, they just centralized sequencers just go down. And I think this is definitely a problem to be solved. Okay, so yeah, let me actually skip this technical slide. Not bore with the technical details. So what is the main point? What is the main takeaway? Yeah, the main takeaway is I think to really scale Ethereum connected services to billions and billions of users, to really compete with Web2 scale transaction speeds, right? We really need to have horizontally scalable systems that is trust minimized, that can interoperate, and this is something that rollups by themselves do not really solve, and we should really look into validiums. Okay, and there's a blog post on this that I recently put out, which is called On Trust Minimization and Horizontal Scaling. And if you want to read further, I encourage you to scan this QR code. But otherwise, I think I will end early. And if you have questions, raise a hand. OK, I don't see questions, and I don't think there's a mic for the audience. So I'm going to be taking questions over there if you do have a question. But yeah, I will stop here. Thank you for your attention.
Hello, everyone. Thank you for being here. I'm Fernando Castillo, and I'm going to be talking about verifiable computation and multi-party workflows. First, a bit about me. I'm a tech startup founder. I'm currently a researcher at TU Berlin, where I'm also doing my PhD, and I'm also a coffee drinker. So first, a bit about the motivation for this is that we want to create a workflow that uses the input from multiple parties and that all the parties that are involved can trust in each other's works. That would mean then to have trust, verification, and auditability. What could be a specific use case for this? Decentralized physical infrastructure network where you have the individual use for the asset and at the same time the asset accounting. Let's say we have an EV charger that produces a specific amount of energy every day, and at the same time it's used to load specific amount for each electrical vehicle. So in an ideal scenario, we would be having only the periodical information aggregated, and every user would have the confidentiality of the use of the asset. So for this, we would need the different properties. One of them would be confidentiality, meaning that only the person or the entity that needs to know about the information would know, and verifiability, for instance, in the example of the accounting, that all the sum on the aggregation of the use is matched up, and interoperability when you have the multiple parties talking to each other. So this could lead to multiple questions. One of them would be, how can the parties then keep the confidentiality in each of the steps? Another question would be, how can the parties do the verification in the whole workflow? So for this, we will have different tools. We will call verifiable computational components. One of them, zero knowledge proofs, another secure multi-party computation, and also trusted execution environments. But all of them had its pros and cons. For instance, a zero knowledge proof could ensure the computation integrity, but we will require that the executioner of the zero knowledge program know about the inputs, but at the same time, they will guarantee the integrity of the computation and the output of the cryptographical proof they generate. Also, we'll have in secure multi-party computation that the confidentiality could be kept at the same time for the input that's being delivered for all the parties that are doing the computation. But here we will trust that the computation is handled correctly for all the parties that are involved. And in the case of the TEs, we could have the confidentiality for the result of the computation that's executed and for the input that's given to the TE. Because in TEs, you would have not access from even for the owner of the machine that's running the code. But here, we wouldn't have the computational integrity guaranteed in terms of a cryptographical proof, like with zero knowledge proof, but here we would have attestation mechanisms that are built in the hardware itself. So we have all of these technologies. What would happen if we would mix them together? Then we would create this type of boxes where you would have mixed properties of confidentiality and at the same time the verification of the proofs that they could generate. For instance, if you mix zero knowledge proofs with a TE, you could guarantee that the data that's being delivered to the TE is only confidential and not even the machine that's running the code could access the information that's being given, and at the same time you could generate a cryptographical proof of the computation that's being made. And hence you could generate workflows like the one illustrated here. So this would require a specific setup, but in which we would require to register all the keys for each verifiable components. For instance, if we would have zero knowledge, like secret snarks, we would need to register the verification keys that are being used to verify the computation, and at the same time, we would need to include the previous keys and the current box that we're using for our VCC. So in the example that was discussed before, we would have the electrical vehicle chargers where they could do an anonymization in the authentication process where a user uses the electrical vehicle charger, and at the same time, then we would have an aggregation verifiable computational component, and finally, this could be verified in the blockchain for public transparency and for the tokenomics that this could deliver. So this scheme could also benefit from an update in the different components that are there. And in this case, we would only need to update the registry in which the keys are registered and only do an update in the VCCs that have direct dependency of the previous in the workflow. So what's the vision for this type of scheme is a workflow in which you could have multiple parties working together and each of them having the confidentiality and the trust in each other works. And all of this could be implemented, for instance, in this example that was described before, you could have the electrical vehicle charger on one side and the electrical vehicle on the other, and at the same time, the owners of those assets could be guaranteed that the use of their assets has been correctly computed for accounting terms. But this might sound that it kind of solved, but currently there are a few challenges, especially these 4 challenges here. One is the high or higher computational cost and overhead for composing or nesting. Also, there's a difficulty when using elliptical cryptographical curves because they need to match if you have a composition of proofs one inside of the other. And as described before, this also requires a specific setup that might be difficult or complex to implement with multiple parties. So the current focus for this is the decentralization of electrical vehicle chargers. Thus, we could enable, on a first step, real-world asset tokenization, and at the same time, increase the confidentiality in the workflow that users are being put into. So, as other type of application for this type of technology would be authenticated machine learning, federated or gossip learning, where you would require training on a specific data set that's authenticated, or also we could use this for supply chain certification, for instance, to calculate or compute a full CO2 footprint emission for a specific product, or to generate green hydrogen certificates. Well, thank you very much. I will be around here. Thank you.
Is the mic on? Okay, I guess I got my answer. Hey, Sam, what's up? I see some awesome people in the crowd. What's up? I see Disco XYZ. I see Fractal. I see Biddlers and awesome people. Thank you all for joining today. Yeah, so my name is Rachel. A little bit about me. I work at Opolis and the University of Ethereum. Some of you might have seen our Blockchain 101 booth. I'm really passionate about educating people on Web3. I see my mentor in the stands here who, helped me get my first job in Web3, and it completely changed my life. I'll go on to the next slide and talk a little bit about my why and why I'm here. So yeah, like I mentioned, my name is Rachel. My why is really aligning with impact and community. So I came here for the community of ETHDenver. I really love the people and just connecting with the Biddlers and people doing amazing things here, building the future of work, and contributing to this financial and collaborative revolution. So I'm going to start with a quote. We're going to take it back to ancient Athens real quick, the birthplace of democracy. And, part of the reason we're all here, right, trying to create a more democratic way for us to work and have a more democratic relation to our finances, to our employment. What you leave behind is not what is engraved in stone monuments, but what is woven into the lives of others. For me, that's a huge quote for me. Like, I'm actually publishing a book this year called Impact-Driven Entrepreneurship, and I start the book with this quote for a reason, because I think we're all here really trying to create a legacy, right, of our generation, to leave something better for the next generations, right, to educate a new way, to have a better relationship with your money, with your work, and with each other. So legacy is also a big part of what I do. And some of you might know me from my work at Opolis. So as you might have seen, Opolis is a presenting sponsor this year. To give you the high-level TLDR of Opolis is a member-owned digital employment cooperative. So we help Biddlers and people earning in the space to have access to W-2s, pay stubs, and employment services. So what this means is basically people can have more ownership of their work and not have to be scared to jump into Web3, right, and have that safety net of benefits. So for me, that's really helped me level up my life. And I've done a bunch of events. Some of you might know OX Joshua from the ETHDenver team, one of my colleagues on the Opolis team. I've done a lot of events. Funny enough, so this symbol up here, I saw it at my, I think my second ETHDenver, and I just thought the branding and the style was really cool, and it made me want to look into the project more. I was like, okay, they have something special going on here. And the more I looked into the project, I realized it's such a needed thing in our space, right? Working at Opolis, we've helped independent contractors and people working in the space to earn compliantly and take the target off of our backs, right? Those of us who are based in the US know, with compliance and regulation and all these things, it's kind of difficult in our industry to earn and take the target off of our backs. So Opolis is doing that by helping folks to earn compliantly and have access to corporate level benefits and be in business for yourself. Okay, so a little bit about the agenda today. We're first going to go through the mission, and then we're going to go into what the community wants to know. And I kind of had an unorthodox approach to this presentation, and we'll get into that in a little bit. And then we're going to go into DAO synonyms, right? What are other ways that we can say DAOs that are more in layman's term for people to understand? And then going into working in Web3, part of this deck too is to also show you some tips and tricks to working in Web3, personal brand development, networking, and the power of social capital. And then lastly, we're going to go into Opolis, and we're going to go into other resources like the University of Ethereum for folks who are interested in learning more about blockchain. Okay, so my mission for you today, I would like for you to gain a deeper understanding of DAOs. Essentially, I want you to be able to leave and explain DAOs to your grandma, to your mom, to your dad, to your Lyft or Uber driver. And this presentation is by the community for the community. And I say that because I came with a blank slate, right? Intentionally to garner feedback from the community on what you all want to learn about DAOs and working in Web3. So this presentation is actually the product of those conversations. So I hope you enjoy it. Yesterday you might have seen me walking around interviewing people. I was doing the media for ETHDenver and asking individuals, in some of those conversations, like, what would you like to learn about DAOs? What would you like to learn about working in Web3? I see someone in the audience who, gave me some insight to this yesterday too. Here's the feedback I received from the community. Okay. The very first thing, I kept hearing this from so many people. How do I get paid for working on DAOs? How can I get paid? Where's the incentive alignment on some of these projects? Something that I was told yesterday is we individually have the responsibility to advocate for ourselves. So your time is valuable. Advocate for yourself and know your worth. Know the value of your time. That's number one. Number two, Above Average Joe said this one. Nonviolent communication. If anyone knows Above Average Joe from the Bankless style community, this is a big one right here. So communicating on a DAO is so important. The communication style is everything because how we work together, how we respect one another, compassionate communication is at the root of us being lit up to work with one another, right? I feel like it's just more, you get more of a net positive outcome when you respect and communicate compassionately with one another. So that's a really big one for DAOs or any organization, right? Then I got another one on the future of DAO tooling. What does that look like? How do we optimize DAO operations? And then the individual experience on a DAO. This is so important. What is the individual's experience working on this project, right? Because at the end of the day, a DAO is an organization made up of individuals. So how they're experiencing it and how they're showing up is really important. And then someone also said, to enter a DAO, it has to be easy. I don't want to go into Discord and see all these channels and just feel overwhelmed. And like, you know, it needs to be a simple onboarding process. That's another thing that I've heard in the community. And then lastly, so somebody told me yesterday, I want to leave and explain DAOs to my grandma. That's what I want to learn. So here's Charlie Day. If anyone's seen Always Sunny in Philadelphia, you know, me trying to explain DAOs to my grandma. I feel like this has been my life, trying to explain Web3, crypto, and DAOs to anyone in my family. So this has kind of been I felt like a meme that was fitting for this. So something I put together to kind of combat this, right? Is anybody familiar with the curse of knowing? Like, when we know something so well, it's kind of difficult to explain it to others because we start to speak that language and that lingo and vernacular, and like, it kind of becomes difficult to break it down in layman's terms. So I looked up yesterday, like, what are some synonyms for DAOs, right? How can we say this in another way? So the first one is digital on-chain cooperatives. That's one that keeps coming up for me. Is I feel like maybe a more appropriate way to say it, right? Blockchain-based organizations. This next one, tokenized governance structures. I don't know if grandma would understand that one, but still another way to say DAOs. Self-managing businesses, community-led organizations, and shared decision-making networks. So I challenge you all here, you know, how many people are familiar with DAOs or know what a DAO is? Okay, awesome. Keep your hand up if you think we got everything figured out with DAOs, so the future of work, we got all the problems solved. No? Okay. Okay, so yeah, moving on. Okay, so the reason I asked that is because there's a bit of duality in the space as far as sentiment on DAOs, right? So to reflect that, I actually got two quotes from Vitalik on DAOs. So he says one thing on this hand, right? Spiritually, I love DAOs. Creating a new and better way for people to coordinate and cooperate around projects is definitely close to my heart, he says. Then he also says, I criticize DAOs because I love them. On-chain algorithms open to vote probing, plutocracy gives me heartburn. So as you can see, like basically the perspective of Vitalik on DAOs, it's like, this is a new novel way for us to show up and work together. And I feel like we all see that and we all know that, right? And it's why I think DAOs are still a part of this space. But without a doubt, we still have problems and challenges we got to overcome if it's going to work. And just like, you know, going back to ancient Athens in the early days of democracy, you know, there were iterations of democracy that didn't work. And that's okay. There's going to be iterations of DAOs that don't work. And we're just going to fail forward and learn, right? Okay, so another thing someone from the community asked me, they said, I keep hearing what doesn't work about DAOs. Can you tell me what works about DAOs? I keep hearing about all the challenges, but what actually works? So I just brainstormed last night and came up with a few of these. So the number one thing for me is individuals with a shared vision. I think that is the thing that really makes DAOs work, when there's value alignment, when there's vision alignment. Inclusive frameworks, straightforward design, and easy onboarding. I think tribalism is a thing that is kind of cannibalistic on a DAO, right? I think having a more inclusive design where everyone's welcome and able to participate, that is the true Web3 ethos. Yeah, so community collaboration and coordination. How we show up and work together is also so vital to a DAO success. And also a feeling of fulfillment, making an impact, doing something that makes a tangible difference in the world. Some of the work we're doing at the University of Ethereum, like I'm so blessed to be aligned with these conversations that now we're actually going to be building wells in the village of Bumpe in Sierra Leone. And it's like, after 3 years of working in Web3, it's like, I finally made it to a place where I can see like a real world manifestation of positivity, making impact in people's lives. And like, that's just the dream to me. Like that makes me want to get up out of bed in the morning and work. You know what I'm saying? Like, so the impact is so important. Like, what good are you doing for the world and for your fellow man, So a feeling of fulfillment, making an impact. And then this is something another person said to me, code being at the center. So code governing DAOs, right? They need to be on chain, right? Decentralized autonomous organizations. There needs to be some element of funds and on-chain activity, right? So having it governed by code at the center. Okay, now, we talked about what works about DAOs. Now, what challenges do DAOs need to overcome? And I think this is equally important, right, for us to be aware of the problems to solve them. So I think over-engineering and over-complexity is something I've seen with DAOs that just, can kind of create stagnation. When something becomes overly complicated or too complex to onboard, it can be a bit off-putting to people who aren't familiarized with the process. So I'd say the best thing we can do with DAOs is create a clear mission, vision, and onboarding experience. Poor incentive alignments, this is another thing. I have seen really wonderful, talented people work for even multiple years at a time and not get paid for their efforts on a DAO. I think there needs to be proper incentive alignments, and I definitely believe that people should be compensated fairly for their time, because your time is the most valuable currency that you have, your time and your attention. Like I mentioned also, tribalism and coordination failures. I think that's something that will just, drag the sentiment of the DAO right down. And I've seen it on different projects, and it just works a lot better when we're all respectful and create inclusive design for these organizations. And then lastly, compliance. So how many people have earned in crypto here? Yeah. So something that Opolis helps with, right, is helping folks who are earning in crypto and who are working in Web3 to make sure they're compliant. I'm actually going to skip forward here. So how does Opolis go hand in hand with DAOs? So contributor and DAO compliance. So Opolis helps the individual, right? And then there's other projects, I don't know if anyone's familiar with my DAO here, that helps with the DAO LLC creation. So for individual DAO compliance, if you're earning in cryptocurrency, what we can do is help you off-ramp your assets, get a neatly packaged W-2, LLC, semi-monthly pay stubs, and make sure you're federally and state compliant with your taxes, which is huge in this space, right? It's like taking the target off of our backs and just making sure we're compliant. And self-sovereignty also, so like offering ownership of work, which is very ethos aligned with DAOs, right? So that's something we're doing at Opolis to help individuals in the space. And then the benefits too, right? Having a safety net for contributors. Some people have a spouse and families and children. So jumping into Web3 can be a bit scary, right? It's like, how am I going to get health insurance for my kid or my wife or my husband? So having that with Opolis has been just a huge relief for me, right? Just knowing that I'm able to work in Web3 and do the work that I love and not have to stress about the benefits. And then also crypto-friendly payroll. That's a plus. Okay, now zooming out from DAOs, let's talk a little bit about working in Web3. I'm just going to go over a couple things that I think have really helped me in my personal journey, working 3 years in Web3, and some things that might help you. So number one, personal development and brand building in the space. Reputation is essential, right? How you show up, how you work with others, reputation is everything in Web3. So that's like my number one thing right there. Number two, it is important to not underestimate the power of social capital and relationship building. A bridge you build today may cross you over to an unexpected opportunity tomorrow. Friendships and camaraderie matter. Okay, so that being said, we're actually hosting an event. This is the first career hub we're doing. This was actually birthed out of a Twitter space that we had. So, we were all talking on an ETHDenver24 space and talking about, so many people go to ETHDenver looking for jobs. So we decided to get together with our partners at MetaIntro and HireChain to put together a job board and create a job fair, which is now the career hub, because we're also offering employer services too to folks who are already working in Web3. And we have some really awesome panels lined up for you too. So if you scan the QR code here, this will take you to our Luma. That job board is also on the Luma page too, so you can see different jobs that we're offering as well. Okay, and then just to give a little more information on Opolis, so like I mentioned, it helps you navigate the world of Web3, getting payroll, you have group rate health coverage, income tax remittance, and proof of income. So all of those things, I think, working in Web3 just make the experience so much more like you're able to do what you love and not have to stress about the compliance factors, right? So Opolis has been a complete game changer for me and so many people I know in the space. Okay, and if anyone's interested in joining Opolis, this is the QR code if you want to pre-qualify and see if it makes sense for you. Take a few seconds, you can fill this out and see if it makes sense for you. And some of the qualifying factors I'll go over here is that you have to be based in the US, making the minimum annual wage in your state or jurisdiction. And yeah, that's it. Oh, also, and you can't be a W-2 worker. Sorry, I missed that one. So this is for independent contractors and independent workers. Okay, and then I mentioned earlier my work at the University of Ethereum. So if you're new to the Web3 space, if you're looking to just learn more, brush up on your skills, or get involved as a local chapter lead and get compensated to work on events, we have our educational platform here. If you want to scan the QR code and go to ueth.org, you can actually complete our beginner learning module and win a signed shirt from Vitalik at our booth. And by the way, if anyone here wants to chat more about this, we have our Blockchain 101 booth where I'll be with my team. Okay, and then lastly, so this is to connect with me. I'm really open to collaborating with the community. I like forming partnerships, friendships, and working together collaboratively. So this is my link here. If anyone wants to connect, my calendar is there if you want to book a time and talk about potentially partnering with either Opolis or the University of Ethereum. Also, all my socials are on there as well. And yeah, shout out to Little Fresh Sam who designed my fit today. I'm not sure if she's here. And yeah, thank you to everyone that showed up and supported this talk today. And yeah, can we give a round of applause for the ETHDenver team too, for the work they do to continuously make this event free for us. Yeah, thanks ETHDenver stewards, if any of you are listening anywhere. All right. And yeah, thank you all for having me.
Hello, everyone. How you doing? It's ETHDenver. It's awesome. I'm here, I think, for a very interesting conversation to be had in the next 20 minutes, which will provide you all with a bit of a foundation to create a framework for a DevRel playbook in the Web3 context. Before we get going, my name is Ben. I'm the head of DevRel at a place called Fuel. I'm also a longtime Rubyist, maybe like Ruby, blockchain on Rails one day, not really sure. And I do happen to love a lot of dad jokes, so if I do throw one in there, please forgive me in advance if you don't find it too funny. You can find me on all social at Hummus on Rails, the Rails part because of Ruby, and the hummus part because, who doesn't like a good hummus for breakfast, lunch, or dinner, let's be honest. So let's get going. The first thing that we need to understand is it seems like more and more, increasingly every single day, if you are building a developer-facing company, if you are a large company, a small company, a brand new startup, there'll be some investor in the room. Some VC, somebody's going to say to you, what about DevRel? Your deck looks great, your product market fit is really awesome, but there's this thing called DevRel, and you should have it. Everyone wants DevRel. It's like the thing everyone thinks they need to have in a developer-facing context, but not everyone actually knows. I would say very few people have a good articulation of the understanding of what the discipline of developer relations is in an organization, which leads to a lot of frustration. Frustration on behalf of the practitioners working in those DevRel contexts, and frustration from the business side trying to understand what exactly do these people do that are working in this company that I have. And that kind of frustration can really lead to some churn and unpleasant outcomes for everyone. So in our time, for the sake of this conversation, we're going to propose a three-pronged definition of what the purpose of DevRel is. This is not an all-encompassing definition. It is not meant to provide you with the one and only answer for all of developer relations, but for our conversation today, it will ground the next few minutes we have together. So a clear definition of DevRel may be something along the lines of enhancing product quality, nurturing authentic community, and driving developer adoption. Those three things, those three prongs together work in tandem. So when DevRel is centered on product, DevRel can exist in many different functions in an organization. It can be in engineering, can be in product, can be in marketing. But when DevRel is centered on product, it is in its root, at its core at that point, is building authentic community developers who are trying to enhance that product, whether it's SDKs, tooling, blockchain, it doesn't matter what it is. They're trying to enhance the product quality in the open source community. And as a result of that, it is, by nature of doing those activities, driving exponentially, hopefully, developer adoption of those tools. So that sounds like a lot. That's a lot of activity to do. Enhance product quality, drive adoption, build genuine community. That's a lot for a team of 30. It's definitely a lot if you're a solo DevRel member in your organization. How do you even begin to approach that problem? So in our time together, we're going to talk about four different frameworks, four different aspects of our framework that may be helpful for you as you are building out your DevRel strategy. First, we're going to talk about the importance of an origin story. Then measurements that are impactful. What is the Web3 difference in this whole conversation? And lastly, we're going to look at what is called in the business world and can be adopted here, a BHAG. Who's heard of BHAG before? Anyone? Amazing. There's something you're going to learn from this talk. At least one thing you're going to get. And you'll be like, Ben, what's a BHAG? You're going to find out in about 10 to 12 minutes. Okay, ready? Let's dive in. So first of all, your origin story is absolutely integral. Why is it absolutely integral? Because you are a team that crosses so many different functions in any organization. You are developers who are friendly, sometimes. You are developers who like to talk to people, Sometimes. You're developers that can write not only code, but maybe English as well. You're developers that can work with grantees. So who wants to work with you? BD, marketing, product, engineering. Everyone wants to touch upon you and be involved in your work, which means you need to show value across the entire organization, not only because it's beneficial, but if you want your DevRel organization in the company to have long-term viability. And long-term viability is a politically correct term for what? To not be let go of. You need to be able to show value across and up. How do you show that value? You show that value the same way that Spider-Man shows that value. Spider-Man knows exactly where he came from. He knows his origin story. His origin story helps direct what he gets involved in and what he doesn't get involved in. It helps drive who he is every single day. And the same is true with every single superhero, whether it's Marvel or DC or any new one, it doesn't really matter. They all have an origin story. And that becomes the grounding by which they can build and move forward from there. Your team also needs an origin story. So let's dive into what an origin story may be for your DevRel team, whether you are the only DevRel person or you're a team of 10 or a team of 30, it doesn't matter. What is your origin story? It sometimes goes along something like this. DevRel started here because ellipses. Well, what is the ellipses? DevRel started here because developers didn't know we existed. We had built this great thing and no one's using it. And no one's involved. DevRel's here because our tooling is super, super complicated. That never happens in blockchain, right? Tooling is never complicated at all. Totally intuitive, totally easy. But it's really complicated. And we got no dev tooling. We're an anti-dev tool DevTools club. We got no dev tooling to help our developers. Or our docs are always not current with our versions. They never are up to date. A new method's been added and it's not in the docs for like 2 months. A method's been deprecated and people are still trying to invoke it because the API reference still talks about it. So whether your team was created for one of those reasons, two of those reasons, all of those reasons, or something entirely different, you understand where you come from. Because probably the truth is, since you have joined as a DevRel person in your organization or your team was created, you probably have been doing a lot of things that don't directly relate to the work of DevRel. Because you are those kind of friendly developers that can interact with people. And you have had a lot of doors open that you have walked through. I would say, if you're not doing so already, now is precisely the time to return to the thing that is your highest impact in the organization. And that has to be rooted in your origin story. Okay, now that you understand where you come from because your developer tooling doesn't exist or your doc story is out of date, what do you do with that? Well, you have to start building impact. How do you do that? So it starts with that origin story. So taking that one example, our product is really, really complicated. Okay, what do we build? What kind of initiatives directly answer that question? That we can draw a very clear line from here to whatever's going to be over there. That's what you have to do as a DevRel team. So one great example, of course, is time to hello world. Can you create measurements that show over time the amount of time it takes for a new developer in your ecosystem to commit their first meaningful lines of code in your community? And is that line trending down as your initiatives and activities trend up? That's a great, impactful measurement. What's another one? Time to resolve issues. How long does it take and how complicated is it to answer a question on your discourse forum or in a GitHub issue that's raised or in Discord? How many processes, how many steps does it take for a developer to go from, help me, I don't know what to do, it's broken, to be able to answer and resolve that problem? How much friction do they have to go through? These are two classic examples of direct line from origin story to activity. But how do you measure those things? Sometimes it's obvious. Other times it's not so obvious. I chose those examples precisely because I think they articulate a very clear framework for how one measures these things. And it's coming from the SMART measurements, SMART goal setting, but not all of SMART, just the key ones in my mind, which are specific, achievable, and realistic. I want goals for a DevRel team that are as specific as they possibly can be. I want somebody higher up than me in the org chart to be able to look at that goal and get it on first read, because they typically don't have the time to dive into it and all the nuances. I want that goal to be able to be achieved and be realistic within the time frame that it's allotted for it, because I want our team to have success. And I want our developers to continue to move forward. Because if we build incremental progress, step by step, whether it's you measuring time in quarters or half year or weeks or whatever your sprints are, if you can measure incrementally improving with these specific, achievable, realistic goals that tie right back to your origin story, you're doing something right. But that's only a part of the puzzle. There is a critical piece that needs to also be employed. And I think it's part of an age-old question, a philosophical conundrum that has boggled the minds of philosophers for millennia. If a tree falls in the forest, does anyone know this? You may know this more than BHAGs, right? If a tree falls in the forest and no one's there, doesn't make a sound. Let me offer you the DevRel version. If a DevRel person does work, but no one knows about it, did it matter? Did it even happen? The sad truth of the matter is, if you don't communicate all the time, you can do the best things, the best programs, the most amazing work, but it'll be all for nothing. Because if no one knew about it, it didn't happen. Which means we all collectively need to start flexing that muscle of not bragging, because society's taught us that bragging is bad, but being good communicators of our achievements and accomplishments. We need to shout these things up and across. We did this and we achieved this, and this how many people went to this, and it was great. If you're a manager of a DevRel team, do this for your people a lot. If you are an individual contributor on a DevRel team, do this and teach your manager to do this for you too. If you are communicating all the time and following the metrics and achievable, impactful, all the good things, then you are actually working towards creating a sustainable and viable DevRel organization, which is all great. But what's the Web3 factor? Because everything we said thus far kind of pertains to all dev companies. Dev first, dev second, dev whatever, dev third, dev tangential, dev lovers, all the dev companies. It all applies to them. But the Web3 nuance adds a different dimension to this, which I think is really important. And there's many ways we can tackle this. We're going to tackle it by talking about socks and t-shirts. Anyone ever heard of Hacktoberfest? Anyone participate in Hacktoberfest? Anyone? You got a shirt? You have the shirt still? Sometimes. It depends if it's clean, right? Shirts and socks is how we've classically incentivized people laboring for hours and hours on open source problems and building open source communities. This is the way we've addressed the problem of we want to build a sustainable and dynamic open source community, which is part of creating an authentic developer community. And we do that with shirts and socks. This quote from a maintainer from a couple years ago, I think is so poignant. In the past few years, have maintained a couple relatively popular open source repos in a Web2 context. And I had the great distinction of having to do that during a Hacktoberfest. I very much empathize with this. Hacktoberfest can feel like a distributed denial of service attack on your repositories. everyone trying to get something in to qualify for a t-shirt. It's overwhelming. Now, lest you say, ha, that's just been a Web 2 problem. That's not our issue. We've got it solved. We know financial incentivizations. We understand self-interest. We build. We help people build. My friends, only 2 words for you that tell us this is also a Web 3 problem. If you have ever been in the context of an emerging layer, emerging project, where airdrop campaigns may be starting to manifest, and you've had to deal with the manifold PRs of adding a comma, or adding an extra, or putting 2 spaces between each sentence, or other, nonsensical pull requests to qualify for those airdrops, it's the exact same problem. So how do we address that? I think we address that in the Web 3 context by looking back on sociological research on why people join communities to begin with. Why do they take part in human communities? Because whether it's a technical community or a non-technical community, it is all the same a human community. And there are basically reasons. There's tons of research on this, why people join these communities. And it boils down to intrinsic and extrinsic reasons. Intrinsic reasons are things like a sense of belonging and fulfillment and purpose. It's getting to say, I'm part of something bigger than me, and I matter. Extrinsic reasons are networking, getting paid, getting rewarded, getting recognized for your accomplishments. And I would say that in the Web 2 model, it has for all too long over-indexed on that belonging and passion, and threw socks at the problem of the extrinsic issue. Literally threw socks at the problem. While at the same time, we in the Web 3 community often over-index on airdrops and forget that people also want to feel like they matter. They want to feel like their being there makes a difference in that space. A sense of belonging, of passion, and fulfillment. So what is the answer? Well, the answer might be a synthesis in our Web3 DevRel context of merging the intrinsic and the extrinsic, bringing them both together with bounties, with airdrops, with rewards, with great swag, but at the same time, recognizing that people want to feel like they matter, that their presence there makes a difference. This brings us to our last point, which is remember your BHAG, because that will be the thing that drives you forward in all of this. A BHAG is essentially a big, hairy, audacious goal. It's a way to stimulate progress. It is to be simultaneously long-term thinking, but driven with like a monomaniacal sense of like relentlessness and passion. It is not a vision statement you hang up in a hallway. It is driving you every single day. So a BHAG for a DevRel team might be around creating a community of developer advocates, because you can only hire so many people on your team. But you can build your team exponentially by pointing your North Star towards this big, hairy, audacious goal at all times. So to recap, you start with your origin story, which informs your BHAG, which then builds your OKRs, which leads to initiatives that feed and answer those OKRs, which you measure impactfully, which then feeds back into iterations on your BHAG. That, I think, it's a lot to do. It's easy to say, a lot to do, but that's what sums up a successful playbook for DevRel in a Web 3, or really any, but specifically a Web 3 context. And of course, don't forget to talk about it all of the time. I do want to mention that we have launched a program at Fuel trying to balance between the intrinsic and the extrinsic, offering bounties and rewards, and also building purpose and fulfillment. I think we're doing something unique in this Developer Champions program. And I do have some extrinsic reasons. I have really cool hats. So the first, not socks, not t-shirts, hats, right? That's the difference. The first 5 people that complete the small challenge will get a hat if you come and see me after. Just show me you've completed it. And you can watch this. If you don't want to join, you can watch it and get a sense of how we're trying to blend the intrinsic along with the extrinsic. Thank you very much.
Hello, everyone. Yeah, and welcome, and thanks for joining my presentation. So today I'm going to do a little Solidity workshop on how to build the next generation of token and NFT on Luxo using the LSP standard. So a bit of intro about myself. So my name is Jean. I'm the lead smart contract engineer at Luxo, and aside of Luxo, I'm also the author of All About Solidity article series. I'm really passionate about smart contracts, so this is basically the repo that I work on a daily basis, LSP smart contract, and aside of that, I publish articles on Medium called All About Solidity. So today, the agenda is that we're going to have an overview of LSP 7 and 8 standards, the token standard on Luxo, and the benefits. And we're going to build a very basic proof of attendance NFT as a proof that you intended to this talk. And we'll look at the Solidity code. And I advise you to use the Universal Profile browser extension available at this link. So, what are the benefits of Luxo standards? Basically, there are multiples. First, they are more adaptable for different use cases. You can use them to do things like dynamic NFTs or collection of sub-collections, so you can create more complex applications that are more tied to the real world. They can hold a little amount of metadata. The interface, you will see, is more unified compared to the other standards, and they have safety and notification feature. But yeah, as the code says, let's look at the code and stop talking. So if you go to this link, it's available also here on this QR code. You will get head into the GitHub repository. So if you go there, you just have to click on Remix, the Remix link here, and you will have magically the whole code loaded. Yeah, and so I'm just going to give a quick overview on the slide. So first of all, as you can see, this contract uses the LSP smart contract. I think I'm going to do it like that. From the NPM package. And first of all, we're going to look at the deployment parameter. So I think if I do it here. Sorry. Yeah. Okay, yeah. So if you look at the deployment parameter of an LSP8 identifiable digital asset, we can see several things. First, we have the type of token. We can represent NFTs and token in multiple ways. And second, we can represent each NFT also in even more multiple ways, like basically a number, or we can have more unique identifier, or we can have more complex use case like collection of sub-collection. So now we're going to see how we can set metadata. So basically the way it works is that in the constructor here, we are setting what we call the token metadata. The way it works is that LSP8 uses a flexible key value store that you can see as a mapping. But we are developer, not a smart contract. And as you know, smart contract understand bytes. But for us, we are more oriented toward a more human-readable form of how to read this metadata. So this metadata can be represented with these schemas. And you can see you can store things like the metadata of NFT or like who created the NFT, a list of creators. So the way things like array data keys work is that we have one entry for the number of creators, like for the length of the array, and then each index is accessible through the next 16 parts of a key. So a bit of a walkthrough to the code here. So the way it works is that first I set up some predefined metadata here at the top. And then we are going to set the list of creators. So there is only one creator. Then I have set up my the address of my UP as a creator here. And we have utility libraries like LSP2 utils in our package to make all of that heavy lifting easier for you. And then we basically set which type of creator it is. So he's an ERC725 account, and it's at index 0. And all of that is available in our docs. It's just that in 20 minutes, I cannot cover all the detail. So yeah. So what's the second benefit? We saw that there is a unified interface and functionality. So if you look at other standards like ERC20 and 721, each of them have their own way to do approvals and do token transfer. In comparison, LSP7 and 8 have the same function interface. The only difference is the parameter for what you are transferring. LSP7, you transfer an amount of tokens. LSP8, you transfer a token ID, an NFT. But yeah, so let's see a bit that in action. How does that actually work? So I built a little D app for the purpose of a workshop. Oh, yeah, with internet that will be better. Okay, cool. So yeah, so the way it works is that, as you're gonna see, we're gonna first deploy our NFT. So we're gonna go in Remix. I'm gonna connect my account. So this is our universal profile browser extension. I'm gonna connect this account. And this is connected, and I'm gonna deploy. So you're gonna have a pop-up window appearing. Okay, I don't know what's happening. Yeah, I think it's my internet connection that's not working great. Okay, well, I will just carry on with the slide. So the way it works with LSP8 is that assets are automatically registered. So here's a basic question. If I send token to someone or an NFT, but I don't tell you, how do you know that you have received it? And the answer is that basically you don't. You don't, and the only way you know is by adding the address on MetaMask, by importing it. But how do you know the address of a token that you have received if you don't know actually that you have received a token? And the way we have built that at Luxo is by using a common interface function called universal receiver, where you have a type ID to specify the type of token or NFT or information you are receiving, and the data that was sent alongside the notification. And the way it works is that let's simulate a token transfer scenario where you have two universal profiles. One is transferring the token to another. the token contract is going to notify both the sender and the recipient. And what will happen is we have what we call an LSP1 delegate contract that is going to handle the registration of the asset on the token contract. So I have 9 minutes left. I'm going to try again to connect to reload the page and show the demo. No. Which one, sorry? Thank you. Okay, so I'm going to now deploy the contract. So this is the bytecode of the contract. You can see our browser extension in action here after fighting against the Wi-Fi. So you can see if I open the browser extension, there is like the transaction in progress. We can go on the advanced view and we can look at the transaction hash. Yeah, so the contract is basically here. So yeah, this is the contract that we just deployed. And if I go into the sample app that I created for the purpose of this talk, you can see this is basically the like the metadata that I've preset beforehand. So yeah, let's do a bit of a demo. So the way it works is I will connect another user. I'm going to call it Alice to the app, and the way the code is built is that there is a claim function that basically creates the token ID as the hash of of a caller, and we're going to mint. And the way the parameter works is that we are minting for the claimer, the token ID. True is a parameter called the force in the LSP 7 and 8 standard. So this is for, by default, everything is false because a recipient of token need a way to register the assets. But here, like I put it as true in case for if anyone wants to trade out with a MetaMask or an EOA. So I'm gonna claim the NFT with Alice. So you can see the browser extension here. So yeah, we have like different tabs in our browser extension, like the who has access to the smart contract-based account, like the activity. You can see there's a transaction coming in right now. Let's have a look if it has already been validated. Yeah, it looks like it went through. Okay, cool. Yeah, and if I go to if I connect with Alice and I go to her wallet, we can see that Alice has this collectible. But one interesting thing is that we can see that the asset is unverified. So the way it works with Adluxo for verifying the asset is that to make sure that you're actually interacting with an asset that is genuine is that as me, as the creator, I have to register this asset in my list of issued assets. So I'm going to just do that right now. I'm going to disconnect and I'm going to reconnect with my actual account. And I am going to click on registered issued assets. And what I'm going to do here, basically under the hood, is that I'm setting the entries in the storage of my UP for the LSP 12 issued assets, the list of assets that I've created. Yeah, it's probably a bit slow to update, but yeah, basically, if I go now and I refresh the page, you can see it already appeared live. You can see now that because I registered the asset, now the asset is verified, and yeah, this is the proof that we have a cross linking between the list of creators in the asset contract and the list of issued assets in my metadata contract. And yeah, that's basically it for the demo. I have 30 seconds left, and it was a bit of a bumpy road with Wi-Fi, but hope you liked it. And if you have any more questions, feel free to ping me. I will be around in ETHDenver for the whole week. In 20 minutes, I cannot go into the whole detail of the code and the standards. But yeah, you can learn more by going to our docs at .loxo.tech, or you can just feel free to ask us in the team for more detail. Yeah, and thank you everyone for attending to my presentation.
Hey everyone. Ooh, I can hear myself. Hey everyone, hope everyone is having a great Monday afternoon. My name is Eunice Giarda, and I am co-founder and COO of Monad Labs. And today we're here to talk about accelerating the EVM with superscalar pipelining. Firstly, maybe we should quickly define what is superscalar pipelining. So to do so, I have an example here. This example is a series of tasks associated with doing laundry. We're all familiar with that. This is doing laundry without pipelining. Let's say that for whatever reason, you have accumulated just a ton of laundry. You're doing your linens, you're doing colors, you're doing whites. The naive way of doing laundry would be to do them all, to do the full task for each load before starting the next. So that would obviously take a really long time. Like if I did colors first, and then moved it from the washer to the dryer, then folded, then put it away before then starting on the whites. This little example here shows that I would spend most of my night just doing laundry. We don't want to do that. We want to think smarter. So this is pipelining in the context of laundry. So here, I'm going to start on my colors at 6 p.m. It's going to take about an hour. At 7, I move my colors to the washer, to the dryer. Now the washer's free. So I have a free resource to use, and I can then start loading my whites. And that's what I do. And so suddenly, a task that would otherwise have taken several hours and my entire evening is done in a much more efficient manner. Superscalar pipelining, effectively, is efficient scheduling of your available resources. All right, so what does this mean in the context of Monad? I'm going to talk about two optimizations that Monad employs. The first one is asynchronous execution, and the second is parallel execution. Yeah. All right, so first one, asynchronous execution. So a little bit of background. Today, most blockchains have interleaved execution. What does that mean? It means that for every block, both execution and consensus need to happen before a block can be finalized and before the next block can begin. So consensus, however, is really expensive. Like you have nodes distributed across the world, and you've got messages that need to be sent from one node to the next. It just takes a really friggin' long time, which means that execution, since it needs to fit within the bounds of a given block, only has a fraction of the block time to complete. So let's take an example, Ethereum. Ethereum has a 12-second block time. This little block here will be our 12 seconds. Within that 12 seconds, only 100 milliseconds is actually dedicated to execution today. That is a tiny budget, just barely 1%, which means everything else is dedicated to consensus. What we're trying to do, more examples of interleaved execution here. So here are our series of blocks with both execution and consensus, execution the darker color, consensus the lighter color. And here is how blocks are completed over time. However, with asynchronous execution, which is what Monad does, we separate out consensus from execution, so that consensus is no longer a limit for the ability to execute transactions. How we do asynchronous execution is by deferring the execution. So a block is finalized with consensus, and execution happens independently. So here's the series of blocks with just consensus, and then execution that happens in a deferred manner. The reason why this can exist is because the ordering of transactions is canonical as soon as blocks are produced and consensus is confirmed. So in the, here's our pipelined look, where now we can allocate consensus whenever consensus is available, not taking into consideration execution and vice versa. Now, it may not really look like that much of a difference here, but what we now have is a greater opportunity to fill block space with execution in its entirety. So that basically means much more execution bandwidth per block. So more room for more transactions per block. All right, so in summary, nodes come to consensus prior to execution. And execution will run in a deferred fashion. So execution for block 1 happens while consensus happens on block 2. Couple of notes here, since it is a little bit different than the way other other blockchains create blocks, but we have thought about ways in which there is a delayed Merkle route to confirm the state executed across all nodes, as well as something called a, and now I'm blanking on it. We have a form to prevent spam transactions as well. Carriage cost, I believe, is what it's called. All right. Now, part 2. Oh, I'm already at part 2. I think I'm going really fast here. I'll slow down a little. All right, so the second one is parallel execution. So today, as we had already discussed, transactions are linearly ordered. And they are also serially executed. So there is a canonical and prescribed ordering for all the transactions within a block. 1 comes before 2, which comes before 3, so on and so forth. Which is fine, but as we had noted, it's a little bit inefficient. So the goal is, can we do this faster? What is it, or what is this? Can we get to the end state, the eventual end state of execution, as if we were executing serially faster by doing work smarter and not harder? The way that Monad does this is through parallel execution. Which is what? It's a simple algorithm that has a lot of fancy terms. One example is OCC, Optimistic Concurrency Control. Another one you may have heard is STM, Software Transactional Memory. Complicated terms, but it all boils down to just doing the intuitive thing. Just realizing my cursor's over there. Doing the intuitive thing, which is to do things naively and optimistically. So essentially, we're going to try to execute as many transactions as we can at the very same time. And what we do is we check the assumed inputs and the outputs of these transactions prior to confirming them and updating state. By doing this, we can check to make sure that the transactions and the results are valid, and also reschedule transactions in the case of conflicts. And then, yes, eventually committing back to state. OK, so this here is a very basic visual of transactions. We're going to zoom into, and for the sake of illustration, these lines right here will denote some dependencies. So we'll see here that the first transaction in this array of transactions is a dependency for the third, and a few others down the stack here. Basically, this happens when when the same smart contract is called across different transactions, or the same account balances. Whoops. Sorry. OK, so we're just going to zoom in. Ooh, working backward. We're just going to zoom in to the first 5 here. So we have transactions 1, 2, 3, 4, 5. The way that serial execution handles this is by scheduling them all sequentially, right? Like the first one needs to be fully executed before the second one, before the third, fourth, and fifth. So it's not the most efficient, as we know, because this is exactly the same as doing a full load of laundry before going on to the next laundry pile that you have. In parallel execution, we'll discuss the intuitive algo here. It really depends on the number of resources that you have available to execute transactions. For this example, we're just going to assume we have 3 different resources available to transact. And again, the goal is to execute and shove in as many transactions as we can at the same time. So here, we're going to do so in order, because again, we're maintaining the linearity of transactions and executing transactions 1, 2, and 3 all at the same time across these 3 resources that we have. And as each of these transactions complete, right now we have transaction 3 that completed, we will add the pending results to a queue to then be committed to eventual state. All right, so in this example, we have transaction 3 that completed first, so we have that. pending result. And you can see here, is there a pointer? Oh, you can't see it. You can see then that the next available transaction is slotted in the resource that is available. So T4 is then starting to be executed on that open resource. And so now we have pending results for each of these as they come available, and scheduling that happens for outstanding transactions for when these resources are available. OK, great. So we're going to zoom in now on the pending results that we were talking about. Because again, we're doing things very naively. So we can't just blindly start committing transactions in the case that there are conflicts. So here's an illustration. You recall in our example that transaction 3 is dependent on the results of transaction 1. So what we did previously is schedule all of the work at the same time. And so we're recording the presumed inputs of all of these transactions along with the expected outputs of these transactions. All right, so we don't really care about 2, 4, and 5 because they have no conflict. They'll be able to be merged and committed to state appropriately. But anyway, let's say that I am the commit queue. So I'm taking a look first at the pending results of number 1, confirming that the inputs match what I have in committed state. So right here, I start with 1,000 USDC in my account. And I plan to send 100 USDC to Alice, who starts with 0. So what I do is make sure that my assumed inputs match what exists. Great, they do. I can go ahead and commit this and update committed state. The second transaction, fine, because again, there are no collisions here. Now when we get to the pending result of the third one, again, recall that we optimistically executed it. And so our inputs, our assumed inputs, are now actually out of date because our committed state has been updated by the output of transaction 1. So I can't commit this because then it would throw the real execution state out of whack. So what I can do is send this, send this for rescheduling. So we'll go back to our queue here. And now I'm going to be rescheduling transaction 3 to the next available resource, which is the middle one right there. You'll notice, though, that the time that it takes to re-execute transaction 3 is much smaller than the original one. Why? Well, it's because we already have all of the memory required cached. We've already been working with it recently, and therefore, it's very easily accessible. And what I mean by this is memory that you have to fetch from SSD or a hard drive is multiples more than fetching something that's immediately in memory and in RAM. So anyway, quick re-execution. Great. So now we have a revised input and a revised output. Does it match? Yes. And now we have updated the state. And that is my example. OK, so I'm not sure what this slide was for. But anyway, some takeaways here. Again, parallel execution is to optimistically attempt to execute as many transactions as possible across all the open resources. It produces a lot of pending results as a result of inputs and outputs. And what we're trying to do is confirm the data that the input data for a transaction that is up for commitment matches what is available or what is already committed to state before finalizing. If there is a conflict, easy. We just reschedule immediately. And reschedules are generally cheap because data is cached and available. This is a simple and a compatible way of boosting the number of transactions that can be executed at any given time. No access lists are required, which means completely backward compatible. And I think that pretty much wraps it up. So superscalar pipelining, the two things that we highlighted today within execution are asynchronous execution and parallel execution. I hope you guys enjoyed, and let me know if you have any questions. More than happy. I don't know if this is like there's an opportunity for a Q&A session, but happy to do so as well. Give me a follow on X or Twitter if you'd like, along with our main account. And a quick community artwork featuring Keone's PFP there for accelerating the UVM. Thanks so much, everyone.
4. So, yeah. Wireless 1, yeah, I hear it. It's on now, I can hear it.
Have fun.
It's fun.
Some energy.
Yeah, I'll try. It's,
Still got a lot of time.
all right, GM everyone. Should I pull this up here? So I'm Alton, and I work for the Near Foundation. And today, I'd love to break it down a little bit about how I see the future of DeFi and how I see Near can play a big role in it. I'm a bit jet lagged, so if I lose any technical details, forgive me for that. So when we look at DeFi today, it's very fragmented, right? So crypto has always been fragmented in a way. Like Near started as a separate L1 than Ethereum. But the modularity summer that we've been seeing lately is taking to the extreme. If you go to L2Beat today, you'll see like 41 active L2s. And with those of, sorry, I'm trying to get the clicker. But anyway, with those of 36 coming on the way. So we'll have roughly around like 76 L2s coming up soon. And just like we heard about Monad, there's also new L1s coming in. And this is just creating and fragmenting the whole space. Now, when we go back to user experience, obviously a lot of you folks know MetaMask and use MetaMask. But you can see that there's tons of wallets, right? I mean, if you're using Starknet, which has been a bit of a discussion on Twitter, you probably use Argent. And there's also other wallets like Leap and that are like beyond the EVM ecosystem. Now, there's also the problem of bridging. So if you want to bridge from, I don't know, Near to Ethereum, you would use Rainbow. And then if you use, I don't know, trying to do L2 bridging, you use an alternative. And this is just going to grow. Like as the number of chains grow, the reliance on different wallets and the reliance on bridges is just going to increase. And yeah, again, highlighting that point of new wallets having sort of their own wallets too. And there's actually a funny tweet about this from Mert. If you look at how many L2 stacks are emerging, and you look at the sort of like the combination of that, there's like 1,000 different rollups you can launch today, and developer experience is just getting harder and harder every day. And the problem with this is that developers need to marry a stack, sort of, right? Like you would just pick OP stack and go with it, and that's just creating a lot of problems in the space. Now, if we look at liquidity, liquidity is just fragmented. So Ethereum has roughly around, when I checked yesterday, has 47 billion TVL. But then that liquidity is now going up to L2s, which Arbitrum 1 is roughly around 12 billion. And the rest of the folks that are following Arbitrum are 7 billion, 1 billion. So even though Ethereum has the most sort of liquidity, the liquidity is still going to L2s. And taking to the problem to the bit of the extreme, really, you have different stacks launching now. So Arbiter Morbid has chains, right? So then be more chains that's coming up and fragmenting the liquidity. And you see the same problems with OP Stack and Polygon. So now, let's come back to Near, right? So how do we solve this problem? We think about chain abstraction is the new sort of solution to the problem that we're seeing in the market today. And there's sort of a couple ways to think about it. The first way to think about it is just we're playing with zero-knowledge proofs to sort of aggregate the liquidity in a couple of different layers. And also, chains will keep getting abstracted. We're playing with decentralized front ends, but also Near's account model as well, which I'll talk later. And just to sort of set the mood here, why we're the sort of the best one to work on chain abstraction. Near's vision has always been sort of building the open web, and currently a lot of apps that are on Near are abstracted. So we've seen roughly around 35 million wallets being created on Near since its start, and actually as of last month, this number should be now 18 million with Hot. We've been seeing a lot of sort of normie users coming into crypto and interacting with Near on abstracted user interfaces. And yeah, Sweatcoin, if you're also in the US, Sweat had their launch last year, this year, and they have roughly around 1 million active users as well. And when we think about sort of how we're building into chain abstraction, it's good to start from the bottom to top, how this works. So last year in NearCon, we announced a ZK WASM prover, which is just a research collaboration between Near and Polygon to build sort of like ZK WASM-enabled chains. And we think that this works for sort of unification of security and liquidity across chains. And the other benefit of this was that we're trying to bring Near to closer to the Ethereum ecosystem. The other partnership we did is with EigenLayer. Then we're building, actually, it's coming to the testnet now. We're building a fast finality layer where rollups can settle in. The layer is actually sort of secured by the EigenLayer validators. And these will eventually, they will settle on this layer and eventually will settle down onto Ethereum, but they can use this layer for fast finality, meaning you can do fast draws for L2s, and any bridging that you want to do, you can on this layer too, which allows sort of the security side of things. And the other one that I actually worked on, which is the data availability for Ethereum rollups, which is essentially building Near's cheap DA layer to Ethereum L2s. Currently, it stands around sort of 8,000x cheaper than Ethereum, and also it's roughly around cheaper than 30x than Celestia. And there's more stuff coming up about DA and the roadmap too in the conference. Now, going back to sort of like a bit more on the application side, there's a new application coming which is live called DapTap. So DapTap's vision is to have this one front end that you can interact with different, let me start the video actually. Let it play at the back. So the idea is you have one front end and sort of 100 different applications from 13 different chains. And the benefit of this is when you think about L2 space today, the whole of the DeFi is separated. So you have to go to different bridging protocols, different DEXs, and all these different applications. But the benefit of DapTap is to have this in one place as sort of like React components. And what you can do is you can connect with your MetaMask and then do whatever you want to do with it in DeFi. So you can lend, you can borrow, you can stake, and swap in just one interface. And the great thing is the front ends are decentralized, and it's quite cool. So if it's live on daptap.net, but it requires an invite code because you can collect points. And what you can do is you can search DApp on Twitter, and you'll find some access codes that people have been sharing. So I didn't share mine because there's only 4, and they're already kind of gone, so I can't send more. Now, going back to sort of up the stack and thinking about wallets, really, Near has this unique account model that's been sort of active since its mainnet launch. It has sort of this account abstraction from the start. And the cool thing about is that you can have one account that can hold many keys. So in this case, what we're building towards is you can have one Near account, and that Near account can control an Ethereum address, an OP address, and even a Bitcoin address. And the cool thing is you can have just one wallet, and that's the one crypto wallet you have, and you can interact with any other chain you want to interact with. So the cool thing is that it's currently compatible with EVM and Bitcoin, but we're working towards getting this into to be integrated with Solana, all the other sort of chains as well. And the way it works is those keys live in the Near blockchain. They live in the Near validators using this technology called multi-party compute. And when a user comes in, this is all abstracted from the user, but the user can recover those keys from the blockchain itself. And if you're a developer, this is actually pretty simple. So you're just going to use this sign sign function, where you can just send a payload to transact on the other chain. So you have a Near account, and you sort of like do those transactions on Near, and then that would send that sort of payload to the other chain using a sort of like an RPC provider. And coming to the sort of the end, really, how this would work is in a chain abstracted world, you definitely want to just have one wallet, but also have the ability for developers to pay gas fees, right? So if you're going to Sweat today, and if that's a multi-chain experience, the idea is that users shouldn't pay anything on the network because they don't want to deal with the blockchain. The way it works is pretty simple. All the sort of complicated stuff works at Near protocol. That sends a sort of a chain transaction. So the transaction actually lives on the Near protocol. It's the indexers would take that transaction and send it to a sort of a relay service, and that relay service would handle all of that, right? So it will, if it's a sort of a transaction go to the BSC network, it will just all handle that for you, and the user doesn't have to even think about it. So yeah, what's next? With the cool primitives that chain signature allows, we expect there's a lot of sort of different applications you can build. Some of these could be cross-chain lending and borrowing. Imagine a world where you just have an account, and then you can lend in all different chains and borrow in all different chains. So DApp is going towards this vision, where although it's not integrated yet, you can do this all in just one interface. You can also do cross-chain swaps. That actually have one DEX in Nearest thinking about doing this, where you can swap from OP to Arbitrum in just one atomic fashion. Although it will take some time and take some sort of like research to do this, it is possible in using the Near account. And if you're in the conference, there's a chain abstracted day. That's, I believe it's tomorrow, where the founder of Sweat will talk about it too. They've actually tested sending a transaction from Near to BSC, where you can pay something on BSC with just Sweat, which is a token that lives on Near but makes a payment in another network. And obviously, we want to see more chain abstracted apps where the interface is just a mobile app or a Telegram bot, whatever you want to think about it. It just abstracts all the sort of the complexity, and you can just do anything you want, really, not thinking about the blockchain. And finally, the other ways that you can, Telegram bots have been sort of very popular in the Solana space, and you can even think about a future where you can swap different assets, and you just do that on a Telegram interface, and don't really have to think about switching networks or anything else. So that's where I'll step by. I know it's a lot of information to take, but we want to take sort of nearest technology to help scale Ethereum and also sort of abstract the chains that Ethereum ecosystem has been launching. And that's it.
Hello. My name is Kyle. I'm the DevRel at Phoenix. And our goal is to build on-chain composable private contracts using Solidity. So what is Phoenix? Phoenix is basically an L2 project that, again, is trying to leverage composable on-chain encryption. So obviously privacy in the smart contract space is very popular. Primarily, most of the attention is being given to proofs using projects using zero-knowledge proofs. In some ways, there's kind of some limitations in the sense where like maybe ZK isn't the end game specifically for composable on-chain privacy. Specifically in the sense where FHE allows you to run operations over ciphertext. Which kind of allows you to create an on-chain state so you can have more complex logic versus just point of attestation privacy, which scales a little bit differently. So if you want to get started with the private order flow example, here's a QR code to a sample repo. We also will have a lot of other aspects of the presentation to add to. But here's a quick contract import example. So one of the benefits of building on Phoenix is that you don't have to go and learn another language. You know, we're trying to prioritize the developer experience in the sense where it should be as simple as considering that an integer would be an encrypted integer. So here we have kind of an example where the FHE is just imported on the top of the contract. Here are some examples of how you could pass in ciphertext. And a ciphertext, for those of you not familiar, it's essentially sort of like, think of it like a hash value that kind of represents the knowledge of the plain text as well as noise. FHE is using kind of a noisy encryption here. And as you can see on line 11, we will move towards a type of a decrypt, which will kind of, that's essentially what is exposing the value to the rest of the network. So here's an example of a local setup if anybody also would like to use a traditional, like a hard hat repo. So this can be run locally through the plugin. There's other opportunities to build your contract out this way, using different testing that's possible. So feel free to fork it and give it a shot. We also have a remix plugin that will help you generate and format the ciphertexts so you can actually pass them as input params for your contract, as well as handle permissions in the sense of basically who can view what data. We'll get a little bit more to that later, but if you have any questions about any of the slides, we do have the link to the documentation for each corresponding part of the presentation. So here's an example of how you put an input into a function. Traditionally, you would probably just pass this in as an integer or a uint, I guess, of size 8, for example. However, different formatting is necessary in order to pass in the ciphertext. And we do try to set up tools to make it as easy as possible for developers to pass this in. But essentially, you can think of this as just a level of obfuscation on-chain. So instead of having to off-chain certain aggregation or security when it comes to MEV or basically anything, you can use FHE in this sense. And so if you see here, there's actually 2 different ways to save to this encrypted integer 8 of 8-bit length. So it could either be arbitrary bytecode, for example, if you want to develop using, for example, if it needs to get passed in from the call from another function, or if you just directly want to call it in terms of the ciphertext here. OK, so conditional logic also does apply a little bit differently when you're trying to advance the state over an encrypted field, because it's not as deterministic as like natural blockchain execution, because what the state could branch to is dependent on a value that isn't known. So this does have some issues when it comes to like gas estimation, but again, this is filled through in terms of like just kind of estimating as an arbitrary sort of block of bytecode, if that makes sense. So as you can see here, the first example was kind of something that would be more natural to any of us that have really run like kind of simple if-then logic. However, having to apply this logic like the conditional case over something that's encrypted, again, has kind of the issues I was talking about earlier. So the bottom is basically kind of using a selector method, which is kind of like a multiplexer in the sense where it takes in a Boolean value of is higher here, and then we'll slot either the value or the existing bid and set that to the corresponding, wherever it needs to be. In this case, it's a specific mapping. And we'll kind of get to why this mapping is important later. But it's good to keep in mind of, specifically if you want to check if a value is less than and then apply conditional logic, you would use some sort of a selector here and then branch based off of the encrypted integer. It could be a Boolean, could be an encrypted Boolean. And require statements. So require statements are also different in the sense that sometimes you don't want the contract to execute if a certain threshold is or isn't met. Traditionally, this is a relatively simpler thing to calculate, and oftentimes you can do it before the contract even needs to be run. However, obviously with FHE, especially when it comes to multi-party, a lot of this information isn't going to be known. So require statements also need to be a little bit different. Another thing to be cognizant of is what information does leak. Because at the end of the day, if you're trying to build a really secure encrypted application, one of the things that, one of the core design principles is information leakage, because that can take down entire systems. But the FHE require here is sort of like an example of a condition of what's not going to make this contract work. So if you have a Boolean condition, for example, and you can look at how the contract executed, you would be able to tell if the contract got reverted or not without necessarily seeing the contents. So to go on a little bit more about conversion leakage. So from a high level, I like to think of it in the sense where if it happened at some point, there's a trail of it, right? Because in general engineering principles, right, everything's sort of deterministic. That's how we can build forward and expand on top of things. Some would say stand on the shoulder of giants, I suppose. But when it comes to information leakage, by ever exposing an unencrypted integer here, so a standard uint256, to try to convert that to something like a uint32 or uint256 for that matter, that conversion is going to have some issues because the plain text value that it ever existed will have leaked. So the safest way of encrypting your data this way is to make sure that it's formatted as a ciphertext. And like I said, we believe that this is kind of an extension of sort of an application use of zero-knowledge technology, zero-knowledge proof technology. Like under the hood, part of our operating system, we actually do use zero-knowledge proofs of plain text knowledge to verify that the developer or that the participant knows that the ciphertext was constructed correctly and that the contents, the plain text contents are known so that logic can be applied and a certain level of construction trust can be built in towards the application moving forward. Okay, so what is FHEOS? So we have heard, I've kind of gone on about how to build with Phoenix, but from a high level, what Phoenix is working on is we are building an encrypted L2, but also we are working on the general ecosystem around what's going on in the FHE space. For example, we have use of the threshold network, which is kind of like if you think about it in terms of multi-party compute and the threshold encryption, this is kind of what some of the FHE oracles that eventually are going to be read for necessary decryption. But basically, the FHEOS library specifically is kind of a wrapper around Zama's TFHERS library. Which is a Rust library that's, again, maintained by Zama and uses a specific FHE encryption scheme to handle certain operations. And from there, we try to keep our stack as modular as possible, even in the sense where, there's a lot of trendy stuff about, atomic execution, fragment and liquidity, et cetera. So one of the aspects of keeping this modular is that we could attach it to, different WASM execution environments. In this case, we're using the test environment is using the Arbitrum 4 prover, the Nitro prover, for the integration for stylus so that we can actually run the TFHERS functions, I guess you could say the Solidity endpoints, import them as stateful precompiles. And so, again, this could be applied to different stacks as it's getting more and more popular. Right now, we can convert to networks run using the GoETH client. But from a high level, this is kind of what we're doing. Like I said, under the hood, if you dig into the TFHERS library, it is using ZKPOK for the construction of the plaintext and knowledge of the plaintext. And the threshold service network, will apply a lot of the security that can be used between different networks that eventually get added to. So It's kind of interesting because it kind of comes down to like how do you give encryption as a service? I suppose there's some trains of thought, like some people might advocate for using some sort of bridging, but then you're bridging a ciphertext. Ciphertext value is still relatively large. They could be as large as like 8 kilobytes. Trying to send that through some sort of bridge obviously is going to have its own issues. You could try to segregate it, the message. However, I think also as an argument for just applying the stateful precompiles directly to the client itself. And then they can connect to each other using the threshold service network, which is sort of kind of like the shared state of, kind of like leveraging the network effects for encryption and just general security. So what is PhoenixJS? PhoenixJS is a library that you can import into the client, and it'll help you kind of earlier where I was going over ciphertext formation, and when it comes to permission viewing, basically who has access to this data. This is a way to integrate it into JavaScript, however developers want to build on the front end, and basically it just kind of helps you integrate with the ABI a little bit easier, just in the case of formatting. So again, hopefully the developer experience, we're trying to make the developer experience as seamless, hopefully, as building with anything else in the Web3 space. So what are permissions? I've been talking about permissions. So it's kind of a long-winded way of saying that like who can see the encrypted data, right? Like maybe I want another contract to be able to read a certain value. Maybe I want to lease out my information to some sort of like, I don't know, machine learning model or something that's doing training over an encrypted data set and monetize it that way. But essentially, in practice, this is kind of, you can kind of think of it as like a modifier. Which will check to see that the sender is actually the one that's reviewing this. So if I want to check my own permission, I'm the only one that I want to be able to view what my current balance is for some sort of application. Basically, this permission object gets passed in as a parameter in the function, like passed into the function as an argument. And what it's doing under the hood is that it's kind of checking to see if this permission key, if the key matches the same, if it's the same public key as the one that corresponds to the message.sender, basically kind of making sure that the person that's actually sending this message is the person that has access to the correct key. And so this is another one of the aspects of the Phoenix stack that we try to simplify by using different plugins, such as the Remix plugin, which is, I think, kind of a good way for people that are more visual learners to sort of kind of go through the process and get onboarded that way. But also, it can be more complex in the sense if you need multiple contracts to talk to each other. But yeah, so here again is kind of an example of a permission. Basically, sort of like, if you wanted to have an ERC20 balance, where the address would map to a certain integer value, I guess an encrypted integer value of what a specific user would have. But again, you only want to make sure that that's revealed in the right context. And so the implications of like basically a lot of these technologies could be interesting in the form of like solving generalized sequencer issues, whether that pertains to like bundler user ops and like something like account abstraction versus it has to do with like MEV front running, other issues with MEV when it comes to the more financial space. And I think generally speaking, like sequencing is sort of one of the major issues that we're facing. But again, here's like a version of a sample contract. As you can see, it's pretty similar to the last one in the sense where you just really have to import the contracts, basically one line of code. And then most of the other stuff is basically, kind of think of it as like importing a different like integer type versus, so for sometimes there's libraries that let you import a float that you can use. This kind of, instead of a float, you kind of think of it as like it's an import of an encrypted integer. And so this can kind of be used as like sort of like, similar as like you would with like potentially like a database association to build like cascade, like more complex logic with your application on your contract. And so what are kind of the downsides of this? We've been going over, or what are the things to keep in mind in terms of constraint, right? Because basically it seems sort of like the next logical step of using ZK for privacy in terms of it just being more composable, which opens up a lot of options and the ability to actually have the state be encrypted and not having to decrypt. For example, if you wanted to do something similar to like what I kind of said, like the database association system for like, I don't know, some sort of game or a complex application or some sort of like social media, anything, right? Like you basically need to be able to run a query on encrypted space, or else like what are you doing with these numbers? It's always kind of, so like for example, in a lot of standard is kind of like you would have to be decrypted and then the logic would have to be applied that way. Obviously that leaks, so the solution is maybe we bring that off chain. What is the cost of that? What's the cost of security? some could make the argument that that kind of goes against the ethos of what blockchain technology is supposed to stand for. But FHE is still pretty new, and in the sense where like the hardware acceleration, we're still in the pre-ASIC days, and like there's a lot of funding that is going into hardware acceleration specifically. I mean, for me personally, I know I've run into issues where we were trying to work on like a decentralized DEX, for example. Not being able to use anything larger than like a 16-bit encryption does have its trade-offs. For example, you try to have a fee on a DEX and you can only use 8-bit. How can you can't really get a fee if you're trying to divide by 1,000 because 8-bit only goes up to like 256, right? So these are kind of the design constraints that have to be kept in mind. But for example, even a few months ago, like a division over two cipher, like a cipher, even if you kept the numerator in ciphertext, but the denominator itself even had to be in plain text. And even though those type of divisions, you could maybe pack like 1 in a transaction. Now I think, even in the short period of months, like there has been improvements to figuring out the best way to do these like arithmetic expressions, especially because for now divisions actually is possible. You can have multiple divisions in one specific transaction. But if you want more details and like going over each specific operation, and how that corresponds to each specific data type, the gas used, how to fit that in a block to prevent overflow, here's the documentation. But anyway, that's the end of the slides. Again, if you want to check out the blind auction, which I think is a pretty good example of using the FHE technology to kind of build something out that could be used, and it's kind of something that we're sort of familiar with. Other than that, also there's caveats to the design that need to be considered. Like I said, we only support up to ETHDenver24 values right now. So for example, if you wanted to encrypt an address, which was like 25 characters, right, you could turn that each 8-bit into a representation of a byte and then use that sort of to represent a string. So I mean, because essentially if you can create bits, you can create bytes. But these are just like the development caveats that sort of need to be considered, especially when it comes to like the runtime execution, like general tips of performance. But yeah, that's thank you for listening.
Hello, hello. My name is Erman, and I'm here with Flat Money to talk to you about flat coins. Maybe first, a show of hands. Anyone here who has not heard of the term flat coin before? Not heard of flat coin, never heard of flat coin, not surprised. I'm assuming others have heard of flat coin. Have you heard of the term, but you're not too sure what they are, or you might have a small guess? A few hands. And someone who's really familiar with flat coins, the current kind of standards, and kind of where things are at? Nope, it's very new, right? So yeah, hopefully, you know, we can learn a few things from this talk. Before I dive into flat coins, I'll talk a little bit about stable coins and why flat coins are a natural progression with on-chain stable assets in general. Maybe your first question, is ETH money? Show of hands for anyone who thinks that ETH is money. Quite a few show of hands. Maybe I'll ask it at the end again. Well, anyone feel strongly that ETH is not money? One at the very top, and no other hands. We've got a contrarian up top there, probably a very good trader as well. So this is an interesting question for me that I like to ask people. And if you asked me in 2017 through the ICO boom, I would have said, yeah, ETH is definitely on-chain money. A lot of ICOs during that era, if you were around, were raising a lot of money, and a lot of that was done with ETH. And that was really great for a lot of projects that did that at that time. With varying levels of legitimacy as well. But ETH was going up in value, their treasuries were looking really strong, the runways were looking very long, the party was getting started, and just as it was, the hangover kicked in. And what happened there is the projects that were left holding ETH just saw their treasuries just absolutely get crushed, their runways dwindle, many didn't even get to launch, some launched but weren't able to basically continue. So going through this, and the projects that actually did quite well, what they did is they decided they wanted to hop off this train at some point, and some of them timed this very well, and they essentially sold their ETH into their local fiat currency and were able to sort of continue with their projects, again with varying levels of success, but at least they had a runway. So fast forward to 2019, and at this time, a little-known website called DeFi Pulse and Decentralized Finance was starting to kick off. And what I love about this screenshot is the list of assets down the bottom there. You can see Uniswap at number 3 at 3.6 million TVL, which is crazy to think about today. You got Lightning Network at number 4 at 2.8 million, which is probably still the same today. You've got MakerDAO and Compound at number 1 and 2. So this side actually, really got my interest, is like, why are these lending projects kicking off? And really the catalyst for growth of DeFi at the start was stablecoins. So I'm assuming most of you are familiar with stablecoins, and what we're talking about essentially is on-chain USD and different ways that they're collateralized, which we can dive into. And since then, since the growth of stablecoins, we've seen it increasingly being used as a medium of exchange, even with crypto natives and ETH less and less. And that started happening a lot during DeFi summer around 2020, 2021. And we saw really the DeFi protocol starting to integrate things like USDC and other stablecoins as well. So I want to talk to you about stablecoins just because there are some serious shortcomings, and I'd like to sort of dive into, later on how we can improve that with the flat coin models. So if you're not familiar, you can categorize stablecoins with 3 main categories: fiat-backed, crypto-backed, or algorithmic. And I'll just go through those and just to sort of give an overview and where things can go wrong. So with fiat-backed stablecoins, we're mainly talking about USDC, Tether USDT. Essentially, these tokens are minted on chain, and there are some US dollars or treasuries, US government debt, held in a bank in different jurisdictions depending on the asset. And that's all fine until one day I woke up a year ago and I saw this with USDC, which was a real shock. And it was kind of the opposite to what I actually expected when people were thought that USDC was the safe haven compared to USDT, and still you got the USDT bears. And you know, you look at the news and you're like, okay, there's a bank in the US, okay, that's going under, okay, there's contagion, okay, there's a bank run, and it's affecting USDC, it's affecting DeFi, and this was quite a shock. And obviously, it didn't just affect crypto. There were a lot of people talking about it. You know, the government has to step in immediately, otherwise there's going to be a loss of trust. And of course, the Fed steps in, and back to where we are, and it's kind of like forgotten about. Everything's great. But I mean, this kind of introduces, I don't think it's something we should just look over, because there are these black swan events with these centralized stablecoins, and we are tied to a single jurisdiction with these assets. And of course, you know, there are other risks. Good luck with that. But at the end of the day, Circle, who issues USDC, you know, if the government said, okay, we need you to freeze arbitrarily accounts, or we're introducing these new regulations, this could happen, and this is an event that is plausible. Talking about crypto-backed stables, a little bit different. Collateralized on-chain, typically with crypto assets, but traditionally with ETH. The disadvantage with that is you need to lock in, say, $200 of ETH to mint, you know, $100 of your stable, and you know that's less capital efficient. But also, you know, typically you have to pay. There's a borrowing cost when you're borrowing the stable coin. But also you're riding the volatility of a collateral asset. So if you're collateralizing with ETH, you're riding that volatility. If ETH goes down, you could get liquidated, and you could use that. You could lose that collateral. So it's not ideal. So as a result, you know, the growth of these crypto-backed stable coins really, you know, didn't take off as much as the fiat ones. So MakerDAO, they decided, okay, I think we can actually create some better incentives. What we can do is we can back this with real-world assets. So we can actually mint DAI to institutions, and they can, you know, pay us some interest for that, and they can maybe add some extra interest on top. And this is great for growing. This is great for growing their TVL. So it might look something like this. You know, someone comes in, an institution comes in with a proposal, you know, give us 600 million DAI. We're going to sell it. We're going to put it in the bank. We're going to re-lend it to another, you know, institution for more interest, or we'll buy, you know, short-term treasuries and earn higher interest than what we're paying you. And that's like a win-win situation until you kind of, you know, dive in and go, okay, from a MakerDAO DeFi perspective, you know, everything looks great. DAI goes out, DAI comes back in plus interest. But as you dive down, you know, what happens on the, you know, on the TradFi layer, it's like, you know, there's a lot of flows, there are counterparties, you know, there's all this stuff. So at the end of the day, you got the DeFi layer on top, and underneath you got all the TradFi down the bottom with, you know, with everything that comes with that. So it's just less than ideal. And of course, the algorithmic stablecoins are very controversial. So you could say they're unbacked. Technically, they're backed with a token that's tied to the protocol itself. So there's very circular logic there, as we've seen with Luna's UST. So you can actually, you know, have this super fast flywheel where you can have really fast growth, which is great, and it's gone. But the biggest issue, at least for us, it's these are all pegged to the US dollar. Now, if you ask me, you know, what would be great, you know, on-chain, you know, money, the new currency, you know, of the internet, I wouldn't have guessed, you know, years ago, it's on-chain dollars. At the end of the day, we're tied to a single jurisdiction, and with that, obviously, you've got all the inflation, you know, you've got all the monetary policy issues, you know, the debt, and the question is, you know, can we do better than that? Can we create better internet money? Now, what does that mean? Can it maintain or beat purchasing power? In other words, can it beat inflation? Can it be done in a way that's fully backed with a very pure on-chain asset like ETH? But can we make it capital efficient, none of this locking up 200% collateral, just make it 100% capitalized? Can we just power it with smart contracts, do it fully on-chain, forget about off-chain traditional finance systems? Make it accessible. Can we do it on L2s? Can we build it on Base? And really, can we keep those external dependencies as minimal as possible to create a new primitive that can last for a long time? So that's where we really thought about building the flat coin with flat money. And with the flat coin coming to the term, I believe it was coined by Balaji initially, and all it means is having flat purchasing power over time. So if your bill say your electricity bill costs 100 flat coin today. In 10 years' time, it still costs 100 flat coin, not more. And that's really where the term flat comes from. And the idea in some projects takes this literally is to track CPI. And this is, again, very US-centric. Let's track US CPI. But for us, it's really about, can we create a sustainable yield that can not only track, beat some inflation metric in a certain country, but can it even beat inflation? And can we make it decentralized? So what we came up with was Unit. So Unit is 100% backed by Rocket Pool's staked ETH. So we find this to be the best staked ETH liquid staking derivative. And what we built is a two-sided marketplace. So on one side, we've got Unit, which is the flat coin. And on the other side, we've baked into the protocol a perpetual futures leverage for our ETH. And I believe this might be the first perp for liquid staked ETH. And the way that works is you got the two sides, and basically both sides just deposit our ETH, like no other assets. There's no stable coins involved. It's just our ETH. And the volatility for the flat coin is taken out by the long positions for the long traders. In other words, they are the counterparty. So another way to visualize this, we'll say like the perp stacks. So you got the leverage traders on the right-hand side, and they can take leverage on our ETH. But on the other side, instead of just being short, you've actually got a delta neutral position on the Unit side. And that's how the flat coin basically works. If ETH goes up, if ETH goes down, in real dollar terms, there's no real impact. And the beauty of baking the perp side directly into the protocol is really the yield you can generate out of this. Obviously, if the market is bullish, you typically have a funding rate in a perps market. We call it the borrowing rate, but essentially it's the same thing. The leverage traders are going to pay some interest to the unit holders. So that's one source of yield. All the trades, because the protocol itself doesn't use any external exchanges, every time someone trades, opens a leverage position, closes a leverage position, or even gets liquidated, all those trading fees, again, funnel into the unit holders. And what we've seen is the perps dexes, they're popping out left, right, and center because they know there's demand for traders, the market is there, and the yields are good, and they're sustainable. But instead of having to sort of bet on the market, what you can do is you can build a position like this where you don't have to take any volatility. You can get the leverage traders to do that for you. To use a simple example, you might mint one unit with one RETH. Now, if RETH drops in price or ETH drops in price by 50%, essentially when you withdraw after that, because you are the counterparty to the long traders, you're going to get 2 RETH, or roughly 2 RETH back. But you're going to, on top of that, also in RETH, you're going to get the borrow fees paid by the leverage traders. You're going to get the trading fees, and you're going to get the liquidation fees as well. I should say the borrow fees are the funding rate fees. When the rates are positive, which is typically in the bullish markets, it can flip the other way around as well. So it's not a free lunch, but the yields in general are very, very good. So essentially what we're creating here is we're taking ETH, which is already a fantastic asset, great collateral, which is used deeply in DeFi. We're making it even better by leveraging the best decentralized LSD that's available right now with Rocket Pool ETH, which has staking yield built into the token itself. We take that, we put it in Unit, but what we do is we strip out the volatility at the protocol level itself without any other external dependencies. But on top of that, we got the perps yield that comes in with the protocol also. So there might be there's probably going to be a lot of presentations during ETHDenver this year that talk about real-world assets, how we need to bring the real world into crypto to legitimize it, to scale it. But we believe that we can. This field is very, very new. We can build new, pure, on-chain assets that can be better, many times better than the traditional financial system. So if anything, we should be bringing on-chain to the real world and not the other way around. So thank you for listening. We're going to have a booth at the main event. Come visit us. Come have a chat. Flat Money Unit launches in March very soon. Thanks very much.
Hello, my name is Chris Cordell. I go by Chris Co. I'm here to present how to do on-chain chess in Rust using Arbitrum Stylus. For those of you that aren't familiar, Stylus is a new parallel execution VM on Arbitrum chains. Basically, any WebAssembly programming language is supported. That includes C, C++, Rust. Other niche languages like AssemblyScript and Zig are also supported. It allows up to 70 times more computation per unit of gas and as much as 1,000 times more memory per transaction compared with the EVM. All the while, it remains fully composable with the EVM, so you're able to write Solidity smart contracts, and you're able to write Rust contracts and have them talk to each other as needed. So you can still plug into the broader Arbitrum ecosystem. You don't have to give anything up. You just choose which execution environment that you want for your smart contract. Some of the other benefits of using Stylus is that you get access to general purpose language tooling, such as like crates.io, which is a package registry that Rust provides. Many other languages also have package registries. Solidity does not, so you really just have to import based off of GitHub repos and whatnot. So you get access to that. You've also got access to different coding paradigms, different design paradigms. Solidity is a very opinionated language. It has a lot of warts. So if you want to explore more of a functional style, or you want to use, kind of Rust paradigms, or different design paradigms, it's a powerful concept there. Additionally, like the point of additional programming languages is to allow us to onboard Web2 devs more easily and gain access to all the libraries and tools like cryptography and gaming libraries that exist in the ecosystem for that other developers are out there creating that we can tap into in smart contract development as well. So just I'm just going to briefly go over what some of the prereqs are. If you want to develop on Stylus, you can look all this up on docs.arbitrum.io to review and go through a little more slowly than this 20-minute presentation. So a little hard to keep up, but I'm going to go through it pretty quick. But just as a high-level overview, you need Rust installed on your system. You're going to need to make sure you have Rust up, Rust C, and Cargo, the CLI tools that you can use when you're coding in Rust. Also, just as a suggestion, you can use whatever editor you want, but VS Code with the Rust Analyzer is a good go-to for beginners in Rust. To deploy and test your Stylus contract, you're going to need Docker. And if you look up under Run a local dev node on the Arbitrum Stylus docs, you should find a section that will explain how to install a local Arbitrum Nitro test node that will allow you to run a local node and deploy locally on your system. We also have a public testnet that is currently in L3 on top of Arbitrum Sepoya. Stylus is currently still in audits, but we're getting very, very close to presenting this to the Arbitrum DAO to get approval for our mainnet. So we're very excited about that. But in the meantime, you can deploy on top of the testnet. And the RPC for the testnet is right there, stylustestnet.arbitrum.io/RPC. So in order to write a contract in Rust, you're going to probably take advantage. You don't have to. You can make your own SDK if you want. But we provide a Rust SDK that leverages the library called Alloy, which is part of the Foundry team. A lot of the devs from the Foundry team also wrote Alloy. And that provides Solidity ABI compatibility. It helps, like convert between Rust primitives and Solidity primitives, and kinds of does it in a very aesthetic way that enables you to like quickly switch back and forth between them and declare your state variables in a Solidity ABI compatible way. Optionally, you can use while you're coding, and I'll show you in a sec. You can use either Solidity style declarations, so you can literally write basically Solidity syntax as part of your smart contract to declare your variables. So that makes it easy if you're like porting over something like an existing Solidity contract. Makes it really easy to make sure everything's lined up and in the same slot that it would be, especially if you're doing something like a proxy upgrade. A nice thing that we did with the SDKs, we disabled reentrancies by default. Reentrancies have caused like a lot of hacks and exploits. So we just disable it by default. You have to write unsafe code in order to enable it. This is just kind of like a high-level overview of the syntax, just a like real simple example. So basically, you just declare a struct. This is a counter contract with just a single count variable. And the Silas SDK provides a set of storage primitives that you use when you're declaring your state variables on your contract. And this one is a U256, so it's just a standard 256-bit integer. So it's just a struct with counter. The count field with a U256, we declare that entry point to let the that's a macro that just lets us know, lets the SDK know which struct is the highest level or the root level of your contract state. You can declare multiple structs, and you can reference those from this root state, but this is just a very simple example. And then just to like implement methods on that contract, you just declare this external macro, and then you write your implementation methods. Very simple. Here we got getters, setters, and an incrementer. We're just returning a result that either has an OK or error. For the get, it's just returning the count. It's just called self.count.get. We tried to make getters and setters pretty explicit because accessing state, reading state, writing to state is the most expensive type of operation you can do on chain. So we wanted to make it a little more intentional than maybe Solidity is, where you kind of can accidentally refer to state variables just as easily as local variables. So we kind of try to make certain things like that getting and setting explicit. But moving on to chess. So if you want to make chess on chain, what are some of the key challenges that you're going to find? Well, the board is 8x8, 64 spaces. There's 32 game pieces. It's a complex move space, and you have to like validate the moves to make sure that each move is legal based on the rules that each piece has. There's 6 different types of pieces. They all have different rules about where on the board they can go. Doing this in Solidity is very difficult. In fact, I couldn't find an example of a full 8x8 chessboard. I found a 6x6, but I couldn't find a full 8x8 Solidity implementation. It might exist, but it's very expensive to do on Solidity due to the gas limitations. And one of the benefits of Silas is you get that additional computation that allows us to validate whether a move is legal or not every time a player makes a move. And we're able to do it with a reasonable amount of gas. So one approach that a lot of developers figured out a long time ago about chess, if you want to make an efficient computation, even with this, it's something called bitboards, but even with this, it's difficult to do in Solidity. But essentially, like, it keeps this is kind of a simple 3x3 example to just kind of give you a high-level overview of what's going on under the hood to like make this computation more efficient rather than like iterating through a list of pieces and checking whether or not it can move through each individual possible move. Iterating through all that would be computation expensive. So this makes it easy where you can just do like simple XOR operations to like bitwise operations to see which piece moved and to see whether that move was legal or not. I'm not going to go too much into bitboard implementations on this example because I want to get to the Rust code, but it's something that you can look up another time. It's used in a lot of gaming, for even in gaming environments where the computation is a bit restrained, and that includes on-chain. So, but you can kind of see here, as a simple example, we've got a board, a 3x3 with a pawn and a knight. On the pawn, there's basically 9 bits that represent the pawns, where pawns exist on the board. and you would have, I guess you would have two pawn bit boards, one for black, one for white. And then you can validate, for example, on the lower right, you can see where there's an old board, there's a new board, and how do you track which one moved? You just XOR the old board with the new board, and you get the diff, which tells you that the knight moved from B1 to C3. Again, if you want to review this, there's lots of resources online, lots of great YouTube videos. It's a very cool technique to understand. The other alternative is you can just use a library, because somebody's probably already rewritten this in Rust by now. So Rust has a nice package registry called crates.io, and if you want to use a library, you just look for certain things. You gotta when you're looking through for a stylus implementation, you have to look for something that doesn't use the standard library usually, because it can be a little bulky for on-chain. It could be lots of megabytes or whatever. So you might want to just look for something that's usually made for a no standard library environment. Usually those are focused on like systems or embedded systems types of deployment, but they work for on-chain too. You want to make sure there's no async operations in that code. No randomization. Randomization doesn't really work on chain. We need to be very deterministic about how execution goes. And currently there's no float, but we're planning on implementing a version of float soon. So something to look out for. But the library that I used for this demo is called just Chess Engine. You can find that on crates.io. And I'm going to kind of walk through the code real quick. So just to kind of give an example of what this looks like, and maybe I need to increase the font size. Maybe that's too big. No, let's do that. OK, that's reasonably good. Might want to close that altogether. OK, so I'm going to kind of skip over some details because I got to move quickly. This is just dependencies, and I've set a few constants to declare, like track game state, whether you can continue. After a move, it will return a game status, and it'll be one of these 4 integers that tells you whether that move was legal. If it was legal, it's going to return continuing. Otherwise, it's going to return an illegal move. Otherwise, it's also going to detect whether stalemate or victory was reached. If somebody's got checkmate, the engine will catch that and will return victory and set the game state on chain correctly. 0 is white, 1 is black. I've got a couple of consts for the different piece types, a couple of bit masks that I use because I'm basically storing the game state in a single 256-bit integer. That is to say, like basically each piece has one color and a row and column that I need 3 bits for and 1 bit for the color. So if you've got 4 bits per piece and there's 64 pieces or 64 there's 64 positions on the board. To track a board, you need 64 positions times 4 bits. So that's kind of like how I'm storing this in the games object here. So I just got a simple counter, tracks the total games, whether or not there's a pending game, and just a simple mapping that takes an ID and returns a game info struct. And notice I'm using Solidity style syntax here. I'm using mapping with the arrow, fat arrow. So it's using this like sol storage macro. So I'm kind of writing a little bit of Solidity syntax. Again, that's optional. You don't have to. You can just write pure Rust if you want. But it's nice to know. And if you're familiar with Solidity, it makes it a little easier for the ABI compatibility. But yeah, game info object is just made up of player 1's address, player 2's address, the status, the turn color, whose turn it is, whether there was a victor or not, which color won, and then the board state object that I just mentioned. The methods are quite simple, just tracking total games here. And again, I'm importing this chess engine, so it's doing the bulk of the computation. I didn't have to figure all this out by myself. I'm just leveraging the Rust ecosystem to use this chess engine to build this game. So that's just a simple counter. That gets the color of the current term. That gets the current player, whether it's player 1 or player 2, and returns their address. This is a meteor function here. This is a play move. To play a move, we need to pass in a game number, a from row, a from column, a to row, and a to column. And it's a 0 through 7 based, 0 based index to track the row and the column. So in a typical chess game, you might say A7 to B3 or whatever. This is just a 0 through 8 index. So just kind of walking through. We've only got a few minutes, so I'm kind of going to really go through quickly so I can kind of show you all live demo real quick. But yeah, it's checking to make sure that the current sender for the game is the current player, making sure that the game isn't over already, and then it makes sure that the move, it goes through and makes sure that the move was legal and returns the state and updates the state if it was a legal move. If victory, it's going to go ahead and set the victor. It's going to set the game status, and it's going to return that victory status code. It's also going to do the same for stalemate. And otherwise, the legal moves are just going to return a legal move and not change state. I got a simple printer function that you'll see in a sec that just shows you how to print the game board to the console. So nice thing about Stylus is while you're developing locally, you got access to a local console output that you can just output locally while you're developing, and it's really helpful for debugging. These are a couple of other methods. Let me just kind of do a quick demo just so I get a chance to show the game state. Let me go ahead and pull up my console real quick. So I've already got this deployed, but I think it should just go through. I should go through quick. So what it's doing right now, it's trying to get the code size under 24 kilobytes. That's the max size. It goes through a couple, Cargo Stylus goes through a couple of optimizations. It just deployed locally to this address. So I can copy that. And then I've kind of got this in my history. So I'm just going to use some of these functions that I've already written. But I've got a brand new contract that I just deployed, so I'm going to create or join that. So I'm going to go here and paste that contract address in, and I'm using Foundry's cast CLI. So I'm just calling cast send. That private key is public, so don't worry about seeing that on there. That's a public testnet private key. And then I'm calling creator join. I'm letting cast know what the function is that I'm calling on the contract, and that's just going to create a contract. It's going to create a game locally, and if I call total games, it should say 1 now. Now that I've created the 1, and let's move quickly because I only got a couple minutes. Well, this should be, one sec. Yeah, you went 256. That's going to, let me call it. Hard to do this. Hang on. Hard to do this with the mic in my hand. I'm used to doing this 2 hands. Call. Okay, so we got the 1 game. We're gonna go ahead and call creator join again. I can play against myself if I want, and then I'm going to call. I'm going to call. I want print game. Print game. Oh, come on now. One sec. Plate move. Print game state. Sorry, one sec. One. Okay, that's. Okay, call. And what that's going to do is print, yeah, it's going to print the game state. So we've got a fresh board. And then to make a move, I'm just going to demo the move real quick. Just basically, like I've got a board here, 1 through 8, row 1 through 8, column A through H, which corresponds to 0 through 7, both on the column and the row. So if I go back here to play a move. Let's go back here. Play a move. Okay. And I'm just going to make a move on one of the pawns. I'm going to move the pawn from row 1, column 3 to row 3, column 3. And that should send, and then if I call print game state again and go back, it's moved the chess piece. So, and every time it's making that move, it's also like on the yeah, on the green and the red kind of shows, and the monitor's a little messed up on the colors, but it'll show which piece is in threat mode right now. It's able to calculate all the pieces that are currently threatened, and yeah, it's a very cool little demo. Just to kind of go back to the presentation real quick, if you guys want to look at this example, you just go to github.com/offchainlabs/styluschess. It's on our, if you can't find it, just look up Offchain Labs, GitHub, and look through our repos. You should be able to find it on there. Docs.arbitrum.io for more SDK resources. We also have a Telegram Arbitrum Stylus Devs channel. And if you need me, I'm on Twitter and Telegram at ChrisCrow512. Thank you very much.
on? Are we going? Okay, cool. It's an absolute honor to be here talking to you on a stage shared with Phoenix and Arbitrum. And I walked in and saw Blueberry up here and thought, okay, he's talking about stable coins, and then there's been somebody else talking about stable coins. So you may see things that has a little bit of overlap because there's only so much story we can tell about stable coins. But all right, so it's full screen on my screen. Looks like we're in presenter mode on this screen here. Can we get this to full screen? Because I don't have notes. Although it really doesn't matter. So look at the little one over to the left here. This is kind of my bold claim so that they would allow me to come up here and talk. I think Ethereum and the Ethereum ecosystem and EVM is going to be critical if we're going to save the US dollar, and I mean the big US dollar. A little bit about me, who I am. I am a lot of different roles over my lifetime. I sold a screenplay with my wife to Adam Sandler. Might be the only one up here who can say that. Helped recovery efforts at Ground Zero after 9/11. Sold wallstreet.com domain name for $1 million. Should I do something? Oh, so it's me. Looked good over here. That was crazy. I have an identical twin who I shot. Another probably only person that can say that. I used to mine Ethereum when it was proof of work, and Bitcoin, which is still proof of work. And I am the editor of Stansberry Research's newsletter called Crypto Capital, and also Stansberry Innovations Report. And I am the author of a book called America versus Americans, How Capitalism Has Failed a Capitalist Nation and What We Can Do About It. And apparently I operate on a laptop that is difficult to work with because this guy seems to know his shit and my laptop is giving him trouble. Sorry about that. I could hold up the laptop and turn it around. I'm just gonna keep going. Okay, it's not on screen though. Awesome, so hit me into slideshow and we'll be good. Oh, well, we tried. I got 16 minutes. Let's get through this. Okay. I'm Eric Wade. Oh, I went too fast. First off, when I say if the dollar is to survive, I'm not talking about stable coins. I'm not worried about stable coins. Yes, I do know that the US dollar has lost 97% of its value since 1913. So it seems a little, maybe a little late to come up here and say if the dollar is to survive, right? You might have seen this slide earlier with Flatcoin. And I know it's really hard to get in this day and age when we're looking forward into the future and we're here talking about blockchain and cryptocurrency technology. It's hard sometimes to get people to give a darn about 1913. But I think maybe we could reverse that trend, that 110-year trend of the dollar losing value. And again, I want to reiterate, it's not stable coins that need to be saved, it's the US dollar. Stable coins, even though they're difficult, even though there's multiple wallets, multiple exchanges, problematic for people to get their money on and off, even though they're not FDIC or NCUA or SIPC backed, even though there's fees to buy and sell and move them, they may or may not be backed by assets at all. I don't know what's going on, but we'll just keep going. Hey, look, you guys can read ahead at the bottom if you've got really good vision. And stablecoins aren't in your bank account. So those are all the negatives about stablecoins, but we all know there's about $135 billion in stablecoins right now. So obviously our market likes stablecoins. In fact, I have too many clicks in here. Remember that $135 billion number for later. Stable coins are a big part, in my mind, of saving the US dollar. It's not what backs stable coins that concerns me. There were people up here talking about different backings for different stable coins. I'm not that worried about it as much as I'm worried about what backs the US dollar that I'm worried about right now, today, for our presentation. Because if the US dollar or the team behind the US dollar was a DAO, I don't think any of us would touch it, would we? Because they don't know what they're talking about. They don't know what they're doing. Here's a great example of our leaders at work. Tesla literally lowering the price of their cars so they can qualify for tax credits that our US dollar DAO team was in charge of. That sounds like failure to me. Corporate debt defaults surging. Here's a nice one about, I can't read that. I'm going to go back to my screen here. Banks tightening standards for commercial and industrial loans, shooting up. Bank rate U.S. 30-year mortgage national average, shooting up. This is the economy that we're all being subjected to, right? Retail money market funds are really rising, and that usually rises before a recession. We haven't gotten the recession yet, but job openings dropping. These are the people that are in charge of our money, right? Default rates rising. Percentage of the population living below the poverty line. You can see why I'm worried about what backs the US dollar, right? Countries around the world with the best educational system, not America. I'm not an anti-American, I promise you that. Federal debt, rising and never stopping. Federal government current expenditures. These are the interest rate payments on our federal debt. You can see why I'm worried about what backs the US dollar, right? This is credit default swaps. The fact that there's a possibility that the US could default on their credit and it's more than zero should shock everybody. So this is what I'm worried about. So we have three choices. Obviously, I wrote a book that I say fixes all of that. So you can all run out and buy my book and start pushing for low tax, hard dollar, free unlimited lifetime education. Yeah, those three all work together in my mind. In my book, it's called America versus Americans. That's one of our three choices, so how we can survive this. Another choice is we can start using ETH for everything. Just start spending it like it's cash. Flat Money asked, do we think ETH is money? Well, it could be. We could use ETH as money. We know it's volatile, but it is hard money, right? You guys probably recognize this from ultrasound.money, that ETH is actually going down. So, I mean, in supply. So we could make it into ETH if we wanted to. Or we could tokenize everything. And by we, I mean everybody here who came to this can start thinking in terms of tokenizing literally everything. We could unlock quadrillions of dollars of real-world assets. There's a reason why you hear about real-world assets so much. That's because it's potent. We could start using and building dollars that are backed by assets. So that's something that we've heard about a couple of times on this stage today, right? In fact, as far as tokenization goes, the first mover was the US dollar. Remember I said there was $135 billion in dollar stablecoins right now. You might be surprised to know that the entire supply of US dollars in 1980 in circulation was only $120 billion. So the point I'm trying to make with that is we already have as much dollars on chain right now as what it took to run the American economy in 1980. We're not that far behind. I get it. 1980, some of you think, oh, wow, 1980, different world. Yeah, absolutely it was a different world. We didn't have TikTok. We didn't have the internet. We didn't have cryptos. But we ran the entire country off of $120 billion in US dollars in circulation. So we're not that far behind. So, hey, what would happen if we built an asset-backed stablecoin that everyone could swap their unbacked dollars into? Could we change the world? Other real-world assets are moving on chain. We have gold on chain already. We have diamonds on chain already. We have real estate on chain already. We have treasuries $845 million worth of tokenized treasuries already. Stocks moving on-chain and derivatives. Is this blurry to you guys? Because it's blurry to me, maybe because I'm so close. If that was hard to read, I'm sorry. Someday I think we're going to tokenize everything. I'm in that camp. I agree that we're going to tokenize everything. So the next step for saving the US dollar could be only use currencies that are backed by assets, that are provable assets. We only need to tokenize $6.7 trillion worth of dollars to catch up with the real M2 money supply. Then we retire that whole full faith and credit line that everybody talks about with the US dollar, that the dollar is backed by the full faith and credit of the United States. And my clicker is not clicking anymore. There we go. We can do that. Once we make all of America's assets publicly owned and trackable, those real world assets that I'm talking about, we could back our dollars with them, and we can then start saying that the dollar is backed by hard assets owned by the United States of America. I'm saying if we take the initiative to start that process ourselves, then the dollars themselves will stabilize. Has anybody else seen this chart before? It's hard to read, but it starts at 1970. This is 1970. So you can imagine what it is, right? Everybody knows what happened in 1971. That's not a crypto, that's the dollar index. It's been very unstable. That's how much we believe in our full faith and credit of the US dollar. That blue arrow, 1970. 1970, 71. Okay, so what am I here? What am I trying to get across to you? It makes sense that moving the US dollar back to being backed by assets, that makes sense. We haven't had an asset-backed dollar since 1971, right? Could be made possible by blockchain, by tokenizing America's real-world assets. I believe in that. I believe we should do that. We could save the dollar. We could use the technology that we all came here to learn about, that we all like, that we all use, to literally save the dollar. And that could put us back towards America returning to constrained spending, because a hard dollar is psychologically difficult to waste. Nobody wants to waste a hard dollar as much as they want to waste a dollar that's always going down in value. And possibly America could reverse the possibility of losing the dollar as the world's reserve currency. So yeah, I'm a macro guy, obviously, right? And maybe avoid US dollar hyperinflation, which none of us want. So we can make it possible, save the dollar, if we start to work with stablecoins backed by provable real world assets. That's not all it takes, but that'd be a good start. Is if you have a choice of what stablecoin you want to hold as you're trading in and out of something, look for the one that's backed by provable real-world assets. So obviously, I'm not dumb enough to say that if we start this, the U.S. Treasury is going to start changing their policies just because we made it possible for them to do so. But we should make it possible to do so. If we build if we lead the effort, then we can make the dollar ultrasound money as well. And I believe that's possible. And I guess I spoke a little quickly even after that slow start. I'd like us to start thinking about the first $1 trillion stablecoin. Just that concept, that idea that I get it. Bitcoin, $1 trillion, it's been there before and then lost it. And we're not there yet. Tether, 100 billion, I think, right? I could be right, I could be wrong about Tether, plus or minus $1 billion. Tether's 100 billion. I'm not saying Tether needs to be the first $1 trillion stablecoin, but what kind of a world would we live in if we built something that drew $1 trillion into an on-chain, real-world asset, blockchain-powered $1 trillion stablecoin? That's the kind of world that I want to live in. That's what I'm hoping maybe that we have the energy to accomplish between now and the next time we come back here next year. So I'm Eric Wade with Stansberry Research, and that's what I wanted to get you guys to think about. So I am done early. Thank you. Thank you.
Check, 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 check.
Hey, how's everyone doing? Well, thanks for taking the time. I'm Albert. I'm a product manager here at MetaMask, and I'm here to talk to you about assets experiences. So who here uses a crypto wallet? Just raise your hand. Awesome. OK. What do you like about your crypto wallet? Just shout it out, because apparently this is not great engagement, but shout it out. Security. OK. What else? Multi-chain. Oh, yeah, I heard multi-chain. Great. Anything else? UI. OK. Anything else? Bridges? Bridges. Great. Bridges. So some of the answers I expect are, it's secure, it's easy to use, connects to the dApps I use, right? I can see all my assets and how much they're worth, et cetera, et cetera. What if I asked you what you like about your credit card? So shout out why you like your credit card. All right, money back. What else? Rewards. I love my rewards. Anything else? I didn't hear that, but yeah. Speed. Speed's an important one. So I would expect something more like, hey, it saves me on international fees. I literally get money back for paying rent. That's a new one that I started using. I get points back when I travel, and all the things I usually pay for, I get, the right experience and the best experience. So as you can see, these two answers have quite a lot of division, right? Like, they're very different. In the Web 2 world, these would be a given. You expect your credit card to be secure, right? That's not why you choose a particular credit card. In other words, infrastructure is no longer the reason or the level that we talk about in the Web 2 world, right? Framed another way, in Web 3, we're still working on an infrastructure problem. So there's, we want to get accurate real-time data. There's a lot of scam airdrops. I am a proud Bored Ape holder, but I've lost a lot of other community members through malicious links, right? Transaction simulations, and on and on. But what if we solved Web3 infrastructure? Let's just take a moment, not a moment, let's take 20 minutes. Imagine if we solved Web3 infrastructure. We solved all these issues. Then what is the future of assets experiences once we solve all these infrastructure issues? To really get into this, we need to understand what the future of assets experiences in general. So let's start by examining the history of money. So this is really interesting for me to do research on, because to understand what could be in the future, it's important to look at the past. So the first sign of money was actually not money, it was bartering. I had a cow, I want some tea, I'll exchange 1 cow for 2 barrels of tea, right? We started documenting them on, clay tablets. At some point, we had coins to carry out fractional money, which was actually money. Then we had cash, paper currency. We created banks so that you could exchange currencies from different countries. The gold standard came in Europe so that we could actually have real value. Credit cards were introduced so that you could not only buy fast, but also borrow. Bitcoin, obviously, everyone here knows about Bitcoin, I assume. And finally, Apple Pay, Alipay, because of the digital and mobile revolution that we have today. If we look at history, there's a reason why every single time we have a technological revolution, it came to be. Right? For clay tablets, we wanted to document, like a ledger, what happened. For coins, it became an easy way to fractionalize value. No longer did I have to trade a single cow. I didn't have to cut up my cow in half to get only half a barrel of tea, right? Then I had cash. Carrying me all this coin is really heavy. So cash helped it be a lot lighter and a lot more, transportable. Then banks made it easy to exchange, right? If my friend didn't have what I wanted, then I had no luck. Banks made it easier. At some point, we knew that with cash, you could print unlimited cash. So you would go and actually use gold as a stable value peg. We introduced credit cards, debit cards, because we want money now. Also, cash is a lot, so I just want to carry a single piece of plastic. Obviously, Bitcoin introduced decentralization. And finally, Apple Pay, Alipay introduced a way to pay with the mobile devices that we use every single day. In summary, there's 5 main money trends I've seen in the past. First is fractionalization of money. We went from trading whole cows to cents on the dollar. Second, we have a much easier access and use. We had banks. We have places that swap money. We have easy ways to just tap and go. We have money now. That's a really big one, right? In the recent days, there's a lot of payday loans, a lot of ways you can just borrow, pay now, like buy now, pay later, right? That's a huge trend that we've seen. And that obviously is amounting to a lot of credit card debt. There's a whole nother issue. And then 4 is we get money back, right? You have experiences that you want to do no matter of the form of payment. It just happens that this payment gives me 4% back. So I'm going to choose this one. And 5, looking at all these types of money, we actually are really good at accepting new forms of payment. Right now in this world, it seems like it's going to take ages for crypto to be accepted as a payment method. But looking at what we've done in the past, it's very feasible and it's going to happen. So how does crypto tie into these trends? Right? When you're building a product or you're solving a problem, the problems that we have as people haven't changed in the last 1,000 years. So here are the money trends that apply to crypto. Right? With fractionalization, we can now fractionalize and digitize physical assets on-chain. We can have ease of use because we have fewer middlemen, fewer government oversight to how we want to use our money. Money now, DeFi enables instant borrowing, no more long approval processes. Right? Money back, we get to generate yield at any asset. And 5 is just a totality of everything here, which is with crypto, it's a new form of payment. So now, if you haven't been paying attention, this is the time to pay attention. This is the future of assets experiences in crypto. As everyone knows, crypto is a borderless digital money system. Or actually, more specifically, crypto is a borderless digital assets system. And that word assets is super important here because no longer do we have to look at just single dollar values, right? We actually can look at assets as anything that has value. And we also support the fractionalization of that particular piece of asset. And assuming, in the next 15 minutes, we're assuming that the infrastructure is in place. Anyone with an internet connection can participate, and that's huge. So it starts, where does the future of crypto, where does the future of assets experiences start? It starts with the unbanked. Can anyone guess why the unbanked in the US are unbanked? Just shout out answers, because again, I can't hear you. Sorry, can you say it? KYC, okay. KYC, that's a great reason. Any other reasons? Poverty, great reason. Any other reasons? All right, so according to an FDIC study, 29% cited not having enough money to make the minimum bank requirements. That's huge, right? A lot of them just distrust banks, largely because of the last reason, which is bank fees, right? So in the US, there's a huge problem with the unbanked. But it's more than just the US. All right, another guessing game. How many Americans do you think in the US are unbanked? At least. This is just some query, some amount of number. How many Americans? It's probably more than 0. Okay, I heard no answer, so I'm just going to give you the answer. 6 million Americans. 6 million Americans are unbanked. It's at least, also because it's hard to report this number, so it's at least 6 million. And then how many people in the world do you think are unbanked? 1 billion. Oh, I heard 1 billion. Any other guesses? 2 billion. Oh, hey, let's actually go right down the middle. It's 1.5 billion people. Great guesses. Right, so the market is huge. And the final trend that we're seeing is emerging markets are adopting crypto. So last Q&A for this whole session, I promise. Why do you think emerging markets are adopting crypto? Inflation, okay. Inflation is actually probably the biggest reason. So it's a hedge against inflation. In 2023, Turkey's currency had a 50% inflation. Argentina suffered 104%. So their crypto growth rate naturally was higher than the global average because citizens there are seeing that crypto is potentially the only way that they can keep the money that they have. Furthermore, there's more reasons like restrictions on buying foreign currencies. You're going to go and you want to send money to your friend in another country. Wire fees may be up to 7%, right? Those are huge numbers, and so crypto actually makes it easier and faster and cheaper. Okay, so said all this, what is the future timeline for crypto? First, as we've seen, the unbanked and the emerging markets will adopt crypto as their money system because they have nowhere else to turn to. And we're actually, as a pause, we're actually seeing this today. There are actually a lot of businesses, international businesses, supporting stable coins, as the speaker before was talking about, to actually run their businesses because their local currency is so inflated. All right, so second, to unlock these global customers and crypto customers, vendors are going to support crypto payments. That's because they're pro-crypto, they're pro-money, they're pro-business, they're pro-TAM, right? If you include the amount of people who just take cash, people are like, oh, I can't, go to your business because you don't take credit card. So now people have to take credit card. And then now the number of people are like, hey, I only have crypto. Now they're going to have to take crypto, right? So it's not that they're pro-crypto, they're pro-business. And then provenance and asset verification, which are some things that are purely baked into crypto, will start introducing new financial instruments and new experiences. And finally, crypto becomes as commonplace as cash and credit cards. So finally, going back to the original purpose of this whole talk, what does this mean for the future of assets experiences in crypto wallets? First, we're going to have integrated e-commerce experiences similar to Shop or Amazon Checkout, right? You can sometimes, we started with Stripe, where you just enter your credit card information. Now it's just one-click checkout. Now it's going to be one-click checkout with your crypto wallet. Second, it's going to be a seamless identity and asset verification. No longer, once we have the infrastructure, right, there's legal, there's government, but assuming all that, it's going to be super easy to buy a house, take out loans on that house. It's going to be easy to enter events like ETHDenver with token proof. And assets don't just sit there, right? Today, our money sits in a high-yield savings account, gets 4%, 5%. We want to do the same thing, not just with our money, but also with our assets. And then finally, there's also, or actually second to last, there's going to be a digital access layer. You can think of this as GameFi, right? Their experiences are unlocked through only the digital world that we have. And finally, loyalty. Like being a whale, having 1,000 ETH in your wallet, different wallets are going to compete for your business. And so we're going to unlock lower swap fees just for that whale customer because we know that that customer is extremely valuable. So back to the beginning, back to the first questions I asked here. In the future, showing blockchain data in a secure manner, that's going to be table stakes. That's going to be expected to even have a crypto wallet that's even competitive. But when we are asked why we choose a specific wallet, crypto wallet, we'll say, hey, this wallet, I choose this one because it unlocks the most money for me. It's the most yield. This wallet integrates with the most places I shop with. This wallet allows me to borrow against my house in one click, right? No longer do I have to wait many, many months for approvals and lawyers. Functionality, loyalty. I get to unlock specific experiences because I've been a customer of this wallet for 5 years. And then finally, ease of use. This was just so easy to set up and pay with in the real world. Thank you.
It's live.
It's live? Okay. All right. Hey, guys. My name is Boba. I'm the CTO at Drosera. Today's talk is going to be about ascending security, the new frontier. Super bullish title, right? What does this even mean? Ascending security, the new frontier. What are all those things? The talk is basically to talk about how we can ascend security and how do we handle security for the next frontier in crypto, right? So rather than just talking about like kind of general security things, I wanted to start with a thought experiment for you guys to think about when thinking about crypto and what we're doing with advancing all of this technology. And the concept here is risk debt. Developers are familiar with the concept of tech debt, right? You add a feature, you add more logic, and you add some like huge epic, right? But you need to be able to go back and you need to clean up the code, you need to refine things, right? And I think the same thing goes for complexity. When you add more complexity, you add more risk, and that risk debt gets built up over time. And you need to be able to manage it because at the end of the day, risk debt will eventually make you pay, right? Whether it's through a vulnerability or some dependency that you're using that has some other risk associated with it that is going to have a bad effect on your protocol and your users. So like I was saying, crypto is quickly evolving, and the pro to that is that evolving is essential for survival, and it's essential for innovation, right? Survival is the thing that I think most protocols care the most about, right? If you can survive a couple cycles, you can continue to grow TVL, grow users, and this is fantastic. But the con is that increasing complexity leads to increased risk. So the parallel I like to talk about here is that back in the day, websites and services had like maybe 1 or 2 or 3 dependencies that they used, and now they have like 15 different services, right? And I think the same thing is going to happen in crypto, where rather than just using one oracle or one bridge, we're going to have protocols that are using like 15 different other protocols and other tokens, and there's risks associated with being connected to all those different protocols, and then those protocols being connected to all these other different protocols, right? So what do we do about it? And kind of what I'm proposing here is that we need to evolve our security infrastructure in lockstep with industry, right? We need to continue to add more security infrastructure as we add more complex systems and as risk grows, right? This idea of risk debt. And it's really important that we actually maintain alignment with the ethos of DeFi when we're making the security infrastructure. That's like making decentralized bug bounties, decentralized auditing, right? Just making sure that we're honing in on like this permissionless, transparent, decentralized nature of crypto. And so there's a really big piece to this infrastructure that hasn't really been tackled quite yet, like across from audits, bug bounties, and alerting infrastructure. But I want to get to that. The first thing to think about here is this idea of layered security. If you're a protocol and you're using audits, bug bounties, and alerting platforms, you're doing layered security. You're adding many different layers to fill the holes in this bulletproof vest. But the thing with security is that it's an iterative process. You're never going to be able to like have a silver bullet, one solution that just protects you from every last thing, right? So you need to be able to have multiple defenses in depth, right? So this is the missing piece, I think, that we really need, incident response infrastructure. Essentially, you can think of this like nodes that are running 24/7, that are doing risk analysis on the ecosystem, on protocols, and they're essentially just emergency systems in place to take some automatic action. Like if a bridge goes down or some lending protocol gets like some insane amount of bad debt, we need systems in place to help protect the users and then protect other people's users that are maybe even using your protocol as a dependency. And then obviously we can't rely on devs waking up at 3 a.m. To sign a multisig. I'm sure everybody loves to do that, but I don't. So we should try to put things in place to make sure that we don't have to do that anymore, right? That would be fantastic. So this is risk mitigation 101, right? You have some type of backup plan put in place to be able to do something if you're not at your computer, or your team is asleep, or your team is maybe coming to ETHDenver and they're in an airplane, right? Like that would be very important for you to have something in place so when you land, you say, oh my God, thankfully our users are protected, the system is paused, or there's some type of mitigation that was performed by our incident response infrastructure. And so this is like the big question, right? Like, why am I talking about this now? Why hasn't there really been this much of a focus on this stuff? And I think that a big reason is because of industry-wide tech upgrades, right? Advancements in ZK, advancements in restaking. That's like risk zero on the ZK side, eigenlayer restaking, obviously on the restaking side. And obviously with something like restaking, this allows us to build security infrastructure that is Ethereum aligned, right? We're like leveraging Ethereum to be able to like have some type of shared security. And especially on the ZK side of things, what's really important here is the fact that we can do general purpose verifiable compute. Whereas before, it wasn't as possible. We didn't have things like risk zero in place to be able to do some really advanced stuff. So on the restaking side, like how does it fit into all of this? One thing I'd like to think about here is like if you think of staked ETH from a validator perspective, that's like securing Ethereum from the consensus layer, from the execution layer. But you can also think of restaked ETH as securing Ethereum's applications at the application layer. And that's something that is available to us with things like AVSs and just restaking in general. Having slashing allows for us to build rules around these, this node software. And rules that weren't embedded into like your Ethereum clients. We can have like sidecars that are running and making sure that not only are these Ethereum validators caring about Ethereum, but they're actually caring about your application. And if we have a lot of those, then we can see applications in general becoming more secure and Ethereum becoming more secure. And then obviously on the ZK side, what I was saying earlier about general purpose, zero knowledge VMs, like the thing here that's really important is that when it comes to security, it's a always changing landscape. Like there's some new 0 day that's occurring, or there's like some ecosystem-wide event, like a bridge going down. Having general purpose zero knowledge VMs allows us to quickly innovate and add more security infrastructure to handle new threats as they come. that's something that's like 101 in the Web 2 space. Like we should be doing that in Web 3. There's no doubt about it. And then as for usage, like how have we seen ZK been used? Fraud proofs, validity proofs. Those are things that you can use for incident response infrastructure, security infrastructure, and you can use it for like disputing, having a dispute window with fraud proofs if there's like consensus between a bunch of nodes that some incident has occurred, or you can have validity proofs where a proof is sent saying, hey, this incident occurred mathematically, take some action. So this brings me to essentially my last slide, talking about Drosera. Drosera is an incident response protocol, and it's an AVS, so it's leveraging restaking, eigenlayer. The whole point is to reduce risk debt. The whole point is to handle the complexity that is constantly growing because it's just going to continue to go, right? We need to be able to have something like Drosera in place to be able to handle this risk debt so that we don't have to pay for it when exploits occur. The idea is to have nodes running 24/7, looking at your protocol, and for them to be Ethereum aligned as well. So you have security that is aligned for your protocol's needs and Ethereum's needs. And then the coolest thing about Drosera really is this kind of like catchphrase at the end, security infra as smart contract code. I think that's something that's super important in this space, is making sure that we fully leverage the EVM rather than making like some Node.js backend thing that we're running in the cloud. I think that if we can fully leverage smart contract code to make systems like Drosera, then we're going to see kind of an expansion of more complex systems that have reduced risk. And I think that if you think about this in terms of the eigenlayer space, what's really cool about something like Drosera is that it's like an AVS that can provide protection for other AVSs. And you can think of that as like eigenlayer protecting itself, Ethereum protecting itself. It's added complexity, but it's like targeted complexity to reduce risk. All right, that's the end of the talk, guys. Bullish.
Hey, can you hear me? Nice. Hello, everyone, and thanks for joining. In the next 20 minutes, we will try to establish two things. First, we will try to understand who is the blockchain architect. And next, we will try to kind of understand what are the questions and considerations that should be taken by the blockchain architect when designing a blockchain-based product. So my name is Slava Serbriani. I'm leading the developer relations efforts for Fireblocks. Before actually running in this role, I was leading the solutions engineering team at Fireblocks. I've been working with our clients on integrating Fireblocks into their systems, helping them to design their product, understand their needs, and that's pretty much it. A few words about Fireblocks before we actually deep dive into the topic. So Fireblocks is a digital asset management platform. At the core service, we provide secure wallet infrastructure, and we designed that in a multi-layer security approach. At the basis, you can see that we are using secure hardware elements. Basically, we are using secure enclave technology, trusted execution environment technology, such as SGX, provided by Intel, and also AWS Nitro enclaves. On top of that, we have the MPC CMP algorithm that basically allows you to split your private key into n parts and store every shard on a different physical location. And basically by that, eliminating the single point of failure of your private key existing as a whole in a single place. And on the top layer, we have the transaction authorization policy engine that basically allows our clients to define a set of rules and actually segregate duties across their stakeholders in their platform and basically to govern the flow of the assets out of their wallets. Okay, so what are the blockchain product concerns? What you should be thinking about when you define or when you're designing a blockchain product. At the top, we have the traditional tech stack question, and we are not going to focus on that, but basically this is questions around which cloud providers you should use, which programming languages we should use, how would my networking architecture would look like, so on and so forth. Then we are deep diving into choosing the relevant blockchain layer or choosing the network for our product. Which blockchain should we use? By nature, blockchain products are financial products. So you should be thinking about trust, security, risk management, custody model and architecture, wallet structure, wallet operation, smart contract operations and management and architecture. There are so many more aspects that should be taken into consideration here, but we'll try to close this list in that way. So who is the person that actually makes all of these decisions? Who is the person who actually takes those questions and takes those considerations into account? In your organization, it might be the CTO, a solution architect, technical product manager, or maybe a group of people that actually work together on defining that. But we at Fireblocks try to define this person as the blockchain architect. And the definition that we kind of trying to establish here is the following. So as any architect, the blockchain architect basically is responsible for the high-level design, strategic planning, and tech decisions of the blockchain-based product. As part of his job, blockchain architect takes into account business needs, product requirements, compliance and regulatory guidelines, security concerns and software requirements, and basically produces the best possible solution that addresses all the business needs. Okay, great. We defined the blockchain architect role. Let's try to define the considerations or ask the questions that should be asked when designing such product. So we decided to view that in a kind of multi-layer approach or a stack, where at the bottom you have the blockchain layer, and this layer is all about the questions that you should ask yourself when you're designing and when you're trying to choose the relevant blockchain. On top of that, we have the core services, which is basically the layer that is in charge of all the core services or the core products that you need in order to run your blockchain-based product, such as wallet, trust and model security assessment, etc. And on the upper level layer, we can see the connectivity and interoperability, basically integrations that you need to have in order to kind of complete all of the required use cases in your product. So let's get started and actually deep dive into the first layer, which is the blockchain layer. But just before that, I would like to, sorry for that, I would like to mention that we only have 20 minutes, so it's really hard to cover all of these aspects, right? So we'll go quite high level. So blockchain layer, what do you need to ask yourself when you're choosing a blockchain? There are so many blockchains, right? I put some logos here on the slide, but there are actually so many more that I missed. And how do you know which blockchain works the best for your product? So we kind of built a list of questions that you should ask, that the blockchain architect should ask himself when he's going for this decision. The first one is quite easy. If it's a specific oriented blockchain product, let's say Bitcoin ETF product, it's easy, right? He will probably go with the Bitcoin blockchain. And if it's not the case, it's getting much more complex than that. And then you are going into the aspects of private or public blockchains. Now, I know that some of you don't think that private blockchains are blockchains, but in reality, they are. And it really depends on the use case. And for example, I can give an example of a traditional financial institution that builds his product on the blockchain. They will probably go first with the private blockchain, just because of legal and regulation concerns that they might have. On the other hand, if you're designing a product that should be accessed by anyone in any place in the world, you probably will go with the, of course, public blockchain. It's not only about public or private, it's also about centralization and decentralization. So if we are going back to the example of the financial institution, basically by nature their product will be more centralized because they will probably own the blockchain, the private blockchain, unlike the DEX or the dApp that you will build, and it will be on a fully decentralized blockchain, public blockchain. And also there we have kind of a range of decentralization, right? There are blockchains with 10, 20, 30 nodes or validators, and there are blockchains with hundreds and thousands of validators. Ecosystem. Ecosystem is really important. Most of the products or most of the companies actually decide which ecosystem they will choose before they actually choosing the network or the blockchain. And it's driven mostly by 3 questions. If you are looking for a specific feature that is provided by a specific ecosystem, you are locked to that ecosystem, right? If your product is relying on other projects that on a specific ecosystem, you are also locked to that ecosystem. And the third one is actually the developer community around that specific network, right? So if you're looking for a strong developer community that actually innovates, improves, and builds all the tools that are needed in order to access your product, this is something that you might want to consider as well. Scale and speed requirements. So when blockchain started, right, they were producing blocks like in minutes. And that was fine because that was the standard. But today we have really fast blockchains, right, that produce or validate transactions within seconds or even sub-second. And also handling high gas prices or fees. Some use cases are more sensitive to that, some use cases are not, but you need to make sure that your business model actually works with that kind of fee structure, fee structure in your use case. Sorry for that, just a second. Good to go? Great. And security analysis. Of course, you need to understand the security structure of that network. You don't want to expose yourself or your clients to unnecessary security incidents because you haven't explored that before you chose that specific blockchain. So if you answered all of these questions and got into some answer, you probably did a great job or reasonably great job. But if you want that decision to be even better, you need to make sure that you answer also these. So blockchains are breathing, living products. Unlike your cloud provider, they are upgrading, they have hard forks, they have roadmaps that you need to be familiar with, right? So don't forget about that because it causes a lot of maintenance burden that you might want to think about before designing your solution. And of course, regulation. Regulation is very important. Regulation drives a lot of decisions that the blockchain architect actually does. We will talk about it a bit more in the next slide. Hype and company growth. So you might want to design your product on a specific hype blockchain. The hype will be over until by the time that you will release your product, so you won't be irrelevant, right? Make sure that you are not choosing blockchains because they are hyped. And then if you decided to go with a specific blockchain, right, and in the future would like to expand or to migrate, make sure that you design your system in a way that helps you to migrate or expand in a very easy manner instead of reconstructing or re-architecturing your entire infrastructure. Great. So we discussed the blockchain layer. Let's deep dive a bit into the core services. This is an example of quite simple architecture of a blockchain-based product. Most of our clients would say that it is very simple. Actually, it gets much more complex than that. But the core layer is all about building a trust and security model around your product. So custody model is something crucial that you need to be thinking of when deciding how to design your product. Custody models is driven by two things. Mostly by two things. Regulation, as I mentioned before, and end-user requirements. So if your end-user actually require you to hold their keys, and they don't want any responsibility for that, you are becoming a custodian. And that means a lot. In terms of regulation, you might need to have all the licensing and whatever is required for that. On the other hand, if they want to have the ownership of their keys, you probably need to go with a non-custodial wallet solution. Wallet structure, there are mainly two wallet structures out there, omnibus versus segregated. Omnibus works better for products that are retail-facing products. Basically, it's like the regular bank account model that you can think of. Your end user deposits his funds into his account. Those funds are swept into an omnibus wallet, and that's basically it. Segregated wallet structure is more for institutional-facing clients. So if you're serving institutions, probably you would like to go with the segregated wallet structure, and there is a huge difference between those in terms of operation and financial aspects of the system. Wallet trust model, so security is everything about security. If you don't have security in your wallet infrastructure, you can close the shop and go home. So you need to make sure that you have the highest level of security in your wallet. If you are doing that in-house or going to a third-party vendor, you need to make sure that you take things like cryptography and zero trust architecture into consideration, thinking about MPC, multi-sig, account abstraction wallets, and all of these kind of considerations out there. Blockchain data access. If you want to access data on the blockchain, this is hard. Every blockchain has its own interface for accessing data, and then if you want to manage nodes, you need to make sure that you have disaster recovery, high availability procedures in place. And again, if you are taking a third-party vendor here into consideration, you need to make sure that you are going through the entire counterparty risk assessment as discussed before. Smart contract trust model, basically, if you're developing a product that is built upon or on top of smart contracts, you need to make sure that you are going through all the relevant audits. And internal operation security, making sure that you have all the access policies or internal access policies in place. Great. So we covered blockchain layer. We covered the core services. Let's talk a bit about the connectivity layer. Connectivity layer is all about beyond the keys and signing, what you actually need beyond a wallet. So we have the transaction approval flow integrations. If you want to make sure that you have the relevant approval processes and regulation compliance processes in your place, such as AML and KYT, you need to make sure that you define those when designing your product. Transaction status and balance updates. So this is actually similar to getting access to on-chain data, right? You want to make sure that all the balances in your system are valid and there's no discrepancy between the balances that you run into your system or transaction statuses, and they are the same as in the blockchain itself. Fee estimation. So basically, we want to know how much we are going to pay for a specific transaction. So we need to have the all the fee estimation processes in place to make sure that we understand how we build that estimate and how we estimate these fees, in addition to recovering stock transactions such as CPFP processes, RBF, and boosting your transactions in general. Fiat and exchange transfers. So if you need an off or on-ramp fiat into your product, make sure that you understand that you need integrations to fiat providers. And smart contract management, the entire full life cycle of smart contract management, such as deployment, minting, upgrading, and basically performing different contract operations. Liquidity network integrations. So if you are looking to get access to liquidity, market makers, OTCs, you need to make sure that you're establishing all of these integrations with them. So probably you noticed all of these things that we just discussed in the connectivity layer is about integrations. So you are going to manage a lot of vendors and a lot of integrations to different third-party providers. So you need to make sure that you understand that it's going to be a lot of effort in terms of development and maintenance. We came up with this formula, which is basically if you're running a retail service solution and you are operating on 3 blockchains, you will probably have something around more than 20 integrations to build and maintain. Okay, great. So we cover all of these layers. Thank you for listening. I would like to invite you to get a free sandbox environment in Fireblocks by browsing to fireblocks.com. You can also check out our developer portal, publicly available documentation at developers.fireblocks.com. And also, we are going to host a side event here at Denver tomorrow. All the details can be found in the side event website, ETHDenver side event website. Thank you so much.
actually better. Yeah, that's perfect. And then I can talk right into it like that. Yeah. All right, welcome everybody. It's great to see all you guys. Thank you so much for coming to my talk. My name is Kevin Jones. I am a developer relations engineer working for Edge and Node, working on the Graph protocol. I am also one of the members of the Build Guild, working on Scaffold-ETH. So this talk is actually kind of like geared at both subjects, but more importantly, we're going to be talking about how to build a subgraph with Scaffold-ETH and also how to build a subgraph with a studio. It's going to be a bit of a speed run, so I hope you guys are ready because we're not going to do a lot of slides and a lot of talking, and it's going to be actually like setting everything up. So This is kind of what we're going to build. Basically, Scaffold.eth is a toolkit that you probably have heard of. It's got everything you need to basically build a dApp really quickly. So it's really good for hackathons. It's really good for prototyping. And there's a direct integration called the Subgraph package, which is available as a branch in GitHub that we're going to use. The value add here is that we're going to use Next.js as our front end. So React with Next.js. We're going to use Hardhat for our backend for writing smart contract. And then we're going to use the graph as a middleware layer to basically do all of our indexing. The reason we want to do this is because really the Ethereum blockchain is not ideal for reading data. You have this issue where it's not easy to interface with the JSON RPC. And so you really need something like the graph to do that. And that's the value proposition for what we're going to do. I only have one more slide, and this is what the graph is. So if you haven't heard of the graph is a decentralized indexing protocol for a lot of different blockchains, Ethereum one of those. And it essentially takes the design theory where you build a dApp, and instead of querying for data from the smart contract via a JSON RPC, you write your transactions like you normally would via the normal blockchain. And that's incentivized for writes, really. And as your smart contract emits events, those events are picked up by Graph Node, and those are indexed using a WASM module that's written in assembly script. This is then stored on Postgres inside of a database running on the indexers, and then it's exposed with a GraphQL API. So the value is that you can utilize GraphQL for blockchain data, right? That's the only 2 slides I got. We're just going to kind of dive in. So, Scaffold.eth is an open source toolkit. It's available on GitHub. You can go to scaffoldeth.io. You can basically, there's 2 ways to install Scaffold.eth. You can install it with Git, or you can install it using NPX. NPX is in beta. And if you want to do this subgraph package, you're going to want to use Git because it's a special branch. And right now, there's no way to set up the graph with the NPX way. So you're going to want to just click on the GitHub link right here. And when you come here, you can see Scaffold.eth. So you can see here, this is the main branch. It's got like all the kind of walkthrough, the README, how to set it up. But then there's a special branch right here called subgraph package. So you can just select that. And this is going to be a special branch of Scaffold.eth that comes with the graph. So it's the same, it's pretty much up to date with the main branch of Scaffold.eth, but it's just got an additional package called the subgraph package. So I've gone ahead and I've basically already checked out the repository. I'm using tmux, which is a terminal multiplexer, so it just allows me to give 3 windows open here. Everything you do in Scaffold.eth, you kind of have a few windows open, so that's why I've got 4. We're going to need 1 for our back end, we're going to need 1 for our front end, we're going to need 1 to do deploys, and then we're going to need 1 to run the graph infrastructure that I just talked about. So we can set this up. If you do a yarn install, it's going to go in there. Once you check out the package, it's going to install all the requirements that you need. Okay, that takes anywhere from a minute to 2 minutes, depending on your internet connection, and then you're pretty much up and running. Then you can do a yarn chain. So yarn chain is going to do exactly that. It's going to spin up your chain. If you're using the subgraph package, that's Hardhat. If you use the npx command, that could be Foundry. If you do choose, there's an option for that. But for this sake, we're going to be using Hardhat. So it spins up Hardhat on localhost, and it also gives you all of your accounts, like to basically play around with fake ETH, right? Then what we can do is in the second window here, we're going to do yarn start. So this is going to spin up a React with Next.js. And pretty much all the code base is in Next.js. It uses app router, and it also is written primarily in TypeScript, but it also does support JavaScript if you want to write in JavaScript. But as you can see, it's nice and snappy, super fast, right? We're up and running. So we're always going to keep kind of those windows up. The next thing we can do is we can do a deploy. So as you can see, everything's kind of like around these yarn commands to make it easy. So the next one is to do yarn deploy. So yarn chain, spin up your back end, yarn start for your front end, yarn deploy to take your smart contract that's in the package and deploy it. So it does come with the smart contract that we're going to look at in a second. And you can see that we got our deployment basically was successful. We can see the address for it. We can see that it created the types in TypeScript. And the cool thing is actually, as you deploy your contract, it injects the ABI into Scaffold.eth as well, which I'll show in a second. And it gets you kind of up and running. The last thing that we want to do is spin up the graph node infrastructure. So On top of the front end and the back end, we also want to spin up the stack for Graph Node. So the stack for Graph Node, we just do yarn run dash node. So this is going to be all running in Docker, so you need Docker installed on your machine. Obviously, when you want to ship to like a testnet or to like mainnet Ethereum, then you can move it to the decentralized network. If we have time, we're going to deploy a contract there as well. But you can see here that the Graph Node is basically coming up. You can also see that IPFS is coming up, and you can also see that Postgres is coming up. So that is the stack for the graph. It is Graph Node, which is written in Rust. It is Postgres, which is for the database. And then it's IPFS for all of the configuration files and the manifests, right? So that's it. So we were able to kind of, with these 3 windows, set up a complete environment for doing some local development, OK? So let's go back to our browser, and let's go to localhost 3000, which is where Scaffold.eth is running, right? So Scaffold.eth, again, it is a React app. You can see here that we've got Scaffold.eth up and running. It kind of gives you some hints on how you can get started editing your application by going to page TSX, tells you where your contracts is located. And then really, what's really cool is this debug contracts folder. The debug contracts basically is automatically generated based on your smart contract. So if you make a change in your smart contract, redeploy it, you will automatically get all of the read and the write functions and all of the reads for your variables as well. So we can instantly know what our contract does without even looking at the smart contract. It's a very basic contract that has a read to get a counter. It has a write function to basically write a greeting, a new greeting. And then it has a section to add value to the transaction as well. And it has a function to withdraw funds from the smart contract. And then it has a greeter called Building Unstoppable Apps. It has an owner variable that's set up, so it has some kind of like access control out of the box, some booleans and a counter. So we could come in here and say, all right, biddle week like this, and hit send. It's going to basically tell me that I don't have funds to pay for this transaction. Okay, out of the box, you'll notice too that we don't really need to connect to MetaMask because we have a burner wallet in the top right corner. So you can see here that it's actually empty, doesn't have any ETH, so I don't have any gas to pay, but I can just hit this little button right here and get some funds from the faucet. So I'm instantly able to do that again and then hit send, and then now we can see that that state variable was updated, right? So really easy, we can start prototyping. So let's take a look real quick at the code base so that you guys can see what it looks like, okay? It is a mono repo. So what that means is that you have a base yarn package repo. And then inside of that packages folder, you have like sub repos, like repos within that main repo. And so we have 3. We have Hardhat, which is our chain. We have Next.js, and then we have the subgraph, okay? So if we go to Hardhat and we go to contracts and go to your contract, we can see that contract. So here we have a contract that's basically called your contract. It has that string that is the greeter function right here. And then it has an event that gets emitted every time that the greeting changes, okay? And that's the important thing that we're going to talk about right now. And it also has a function here that allows us to set a greeting by taking it in as a new value, right? So that's what allowed me to make my change on the front end right there, right? So let's say now at this point, we wanted to be able to see the data for these. We've made some transactions, and we want to actually see that data, right? How do we get that data? Well, normally you would need to have a listener, and you would need to subscribe to all the events that are happening on your smart contract. But in this case, we don't want to do that because that's a little inefficient, because we would need to loop over and like create some kind of like for loop to get all that data. So we're not going to do it that way. We're actually going to use the graph. So if we go back to our package and go to the subgraph package, we can look at what the subgraph looks like. So as we have a subgraph, we have a smart contract that is already written for us. We also have a subgraph that's already written for us. So out of the box, you have one here that is exactly matches what needs to be for your smart contract. And so really a subgraph is 3 files. It's the manifest, which is this kind of like main YAML configuration that we're looking at now. It's a schema, which is basically how you want to store that data and organize it, which is written in like GraphQL. So if you're familiar with GraphQL, you've probably seen this before. And then you have a mappings, which is the assembly script that is compiled down into WASM to process the data. So this high-level subgraph YAML is basically telling you, OK, well, what network do we care about? So this is localhost, right? what contract address do we care about? It's right here. It's also injected when we do a deploy. Well, what entities do we care about? Well, we want to track the greetings as they change, and we also want to track the senders, like who actually sent the greeting. And then we also want to tell it exactly what handlers to run, right? So this is what needs to happen every time that an event happens. So here we're going to say, OK, here are our entities, and this is what should happen every time that this particular event is fired off, OK? So we're going to say here, handle this event and process these data types. So we can see here we have a greeting change. It has an address, string, Boolean, and then an unsigned integer. And those match exactly what is inside of our smart contract. Our smart contract. So if we go to the event, that's exactly what we see here in these values. So what we can do is take this subgraph and take this mapping module, and we can deploy it to the graph node infrastructure. So we can do that also with simple yarn commands. So we can say yarn local-create, which will, you only need to run this once, but what it does is it takes your subgraph and it deploys a instance of it on your graph node instance. And you only need to do that once. Then you just need to do yarn local-ship. And what this is going to do is it's going to read in the subgraph configuration. Again, it's already written for you. It's going to compile it down. It's going to check to make sure there's no errors in it. And then it's going to ask you to deploy it. So you can see here we have this, sorry, that might be hard to read, but on the very bottom, there's a version that it wants to know. So just like you make changes to your smart contract, you also need to make changes to your subgraph, and because your smart contracts evolve, they add new events. You also need to add new events to your subgraph. So this version might change. We can just do one. Now it's going to take the subgraph and deploy it. So now we can see here that our subgraph is taking the data from Hardhat, and it's pulling all that data and dumping it into Postgres for us in the back end. So, and it's also going to give us a query URL, which is right here. So we can grab that query URL, and we can load that up on our browser, and we can start looking at the data. So if we go to Explore, the cool thing about GraphQL is GraphQL gives you the ability to kind of like, you already know what the data is going to look like based off the schema, which is here. And we can see that there's two entities, greetings and senders. And so if we come here to Explorer, we can start to explore that data. Again, this might be hard to read. Let me zoom in. But you can see here we have greetings. So let's go to greetings. And we can say, OK, well, I want to get the first 5 or first 10 greetings. I want to order them a certain way. We can do it by the transaction date or created at. We can do it order ascending or descending. We can choose what we want to get. So we can get the greeting, the ID, the premium, whether it was paid, how much value, and then we can hit play. And then we can get this data back in a single query. So this is a lot more efficient than having to do a listener where you're actually like having to pull the JSON RPC over and over and over and over and over again to get the data. Instead, we can just do one simple HTTP query against the graph node instance and get back that data. Okay? So this data, as you can see, it's the first 10 that I did. I kind of spammed it at the beginning. And we can basically load that into our front end. So if we look back here, I want to touch base on this real quick, too. So what's the magic? What's the magic that's doing this? Well, it's really this assembly script code. This is kind of like the power to like how the graph works. What it's basically doing is it's ingesting all of the ABI. And it's basically creating types to basically interact with those using GraphTS. And then it allows you to do things with those. So you can see here we have one handler that is called handle greeting change. And if we look back at the subgraph YAML, that's what's referenced here. So if we go to the mappings again, we can see that what happens is every time there's an event called greeting change, we check to see what the sender is, the sender string, and then if it's there, it basically loads it in based on the string. If it's null, it basically creates an object here, and it sets all the data for those the key values. So in this case, we have the sender, the message sender, the address of who actually set the greeting, when it was created based off the timestamp from the Ethereum block, and then the counter, which is 1. Now, if this already existed in the database, then it would actually increase that counter by 1, right? So it's doing some logic here. And then we also do the same thing with the greeting, we create a transaction, basically ID, and then we load in all the parameters from the event here. So the greeting, the sender, the premium, the value, the timestamp, and then we put the transaction hash as a hex value, and then we save it. So like these last two steps is basically where it's saved inside of Postgres on the indexer. Now, this is all local development, right? What we could do is we could then deploy our smart contract to an actual test net or to a main net, and then we could create a subgraph from there. So that would be the kind of like the next steps. The other thing I just want to show off too is like Next.js. If we go to Next.js, we're using the app router version of Next.js, and you can see that there's a subgraph section here. And if we go back to the UI and go here, sorry, here, there's this subgraph tab. And we can see it's kind of the same kind of hints, tells you how to start the node, how to create it, how to ship it, and how to clean up data if you want to like reset everything. But what's more importantly is down here on the bottom, we have a table that is basically indexing that data. So if you want to kind of see what it looks like to put into your front end, you can reference this subgraph page that's here. And it kind of shows you exactly how it's getting the data. It's basically a component that is making the query, which is here, formulating the query. It's using GQL and useQuery to basically get that data back. If there's no data, then it just displays nothing. If there is data, then it kind of parses that and displays it in a nice, pretty table. So yeah, really easy out-of-the-box experience. Now, as you start getting more into subgraph development, you might make some changes. What I would recommend that you guys do is go to thegraph.com and go to products, and you can go to Subgraph Studio. And you can create a subgraph on any contract that we support. So you can just say create subgraph, name it whatever you want, like Biddle, hit create subgraph, and it's going to give you all the instructions you need to create a subgraph from this portal. So this is very useful because if you, let's say you want to use, like earlier I did one on the Buffacorn Biddle Brigade, so I have it here deployed. We can take a look at it. I indexed the Buffacorn NFT contract, and we can see that I did it 7 hours ago. It's fully synced, all the data's there, and now I can go to the playground and I can do the same thing. I can say, all right, well, let's get the events for all of the transfers. So I can say, all right, what are the transfers for the first 10, order by transaction timestamp, and order descending. And then actually, let's just grab the very first one. And let's get the to and from and ID. And you can see how easy it is to get the data you want and hit play. And then so now we can see that the very first, based on timestamp, descending data for a NFT being transferred was here, which is 4210. It's the token ID. So it's a really seamless experience, developer experience, to basically create a new subgraph from scratch. There's also other subgraphs. So you can go to Subgraph Studio. You can go to Graph Explorer. And there might already be a subgraph. So if you're like building, let's say, a DeFi aggregator, or you're building like a no-code or like a dashboard or something for DeFi, you might search for a specific subgraph. So the most popular one is Uniswap. We can click that, and we can start to get interesting data about Uniswap. You can also see sometimes that there is a link to the source code so that you can go there and see how it works. You can look and see how a subgraph is created on their end. And then, yeah, then you can start exploring the data here. And then from there, you might get to the point where you actually want to signal your subgraph, put it on the network, and then it would be picked up by the decentralized network. And so the value proposition here is that the graph aims to make data for blockchain truly decentralized by distributing all this data across the blockchain, the indexer network. And yeah, so I hope that was useful. And I'll be here to answer any questions that you guys have, because I only have 12 seconds left. But I hope that was useful. Thank you, guys.
All right, we're all set. Hello, everyone. Thank you all for joining the last session of the day, so I appreciate you all sticking around. I'm excited to be here at ETHDenver. My name is Kev Silk. I'm a senior product manager at Anchor. We're a globally distributed blockchain infrastructure company, but today I'm thrilled to talk to you all about how ZK proofs and blockchain technology are going to transform ownership of our digital identities away from corporate networks back to where they belong, into the hands of the individual users of the internet. Now, in order for me to paint the picture for how ZK proofs make this possible and the true value of ZK proofs, I think it's important to consider and remember how our digital identities are currently used and stored in the Web2 world. Now, this is the Web 2 that we've known for the last, 20, 22 years, right? We have different logins, different passwords for the platforms that we use. And although we don't need to pay in the form of currency or monetary currency for that matter, nothing in life is free. That's something that I believe. And there's trade-offs with everything. So what we lose to navigate these platforms in a free way is our digital identities. And what do I mean by that? Well, while we're on these platforms, every move we make, every click of the mouse, click of the keyboard is a data point. And when you combine all those data points together, it creates your digital identity. And when we have different platforms that we use, this means that we have fragmented and numerous digital identities spread across the web. And not only that, the different platforms that we use, all of their servers are stored on centralized databases, right? Which means they're vulnerable to hacks and exploits from malicious actors. And the world is becoming more digital by the day, right? When we look around, we're all on our phones, we're all on our laptops, which means our digital identities are becoming just as important, if not more relevant, than our physical passports or our social security cards. Now, the real danger here is that as the world becomes more digital, we don't own our digital identities, at least in the Web 2 world. That's a severe concern, which is why we all love Web 3, right? It's why we're all at ETHDenver, because Web 3 and blockchain technology creates a shift. It transforms the users of the internet from products being sold to true owners, to consumers. It allows us to navigate the web in an anonymous way. We're able to interact with decentralized applications. We're able to transact in a peer-to-peer manner. We're not being tracked. We own our data. We're creating content that we own. But with that being said, there's trade-offs with everything, right? So what we gain in this level of being able to interact in the web in an anonymous way, we lose application security. And what do I mean by that? Well, wallets can be targets for hacks, and DeFi platforms can be targets for rug pulls and other scams. And it's not the fault of the platforms. It's not the fault of the chains or the dApps. It's just the inherent nature of Web 3. We gain more power to the consumer with less security. So basically, the trade-off here is consumer data privacy and application security. But what if there was a way that we could have both, right? What if there was a way that we could empower dApps and chains to have that Web 2-like KYC security without giving up consumers' digital identities? That's the missing step. Wrong slide. Which is right there. If we can somehow create Web 2-like KYC security that integrates ZK technology, it will empower dApps to build a more safe user experience while maintaining users the ability to own and control their digital identities. Now, what this could look like is something like this. Now, ZK proofs from a high level, as we all know, basically allows you to prove you know something without relaying what that something actually is, right? It's like Me going to my bank and proving that I am in fact an account holder without relaying my social security number or my account number, right? So if we incorporate this level of ZK Web 2-like KYC security, it will empower dApps or chains to create rules for entry. For instance, you need to be above the age of 16 in order to enter. But it will allow consumers to prove they do in fact meet that policy. For instance, they are above the age of 16 without revealing that their name is John, that they're an American citizen, that they're actually 19, and that they live on 1032 Broadway Street, Denver, Colorado. It's a win-win situation for both parties. It allows dApps to build safe and secure environments, removing malicious actors, incorporating KYC and AML. And it also empowers consumers to be able to maintain ownership of their digital identity, so having that true Web3 feel. Now, something like that is possible. Something like that is actually live out in the market right now, which leads me to my next slide, which is Anchor's latest innovation. Our latest product launch about a month and a half ago, Anchor Verify. Anchor Verify at its core is a ZK privacy authenticator tool. It allows dApps and chains to create policy, rules for entry, that users need to prove that they meet. But the real innovation, the real power of Anchor Verify is the fact that we enable consumers to create their digital identities and prove they meet those policies without giving up any irrelevant information that isn't important to the policy, so maintaining ownership of their digital identity. And we do that through our partnership with KYC protocol Synapse. So essentially how it works is consumers create their digital identity with Synapse. They connect their wallet address, and they implement their passport information. All of that information is stored on a smart contract held by Synapse. Synapse is the only controller, the only holder of that information. The Anchor Verify nodes, the decentralized set of nodes that we have, checks the Merkle root of the smart contract stored on Synapse to ensure that users do in fact meet the policies. The dApps and the chains don't have access to that digital identity. All they know is that consumers are truly meeting those policies. Now, there's a lot going on in this screen here, but let me break it down for you. This is essentially how Anchor Verify works. On the left-hand side is where consumers create their digital identities. So as I've mentioned, they go to a UI that's controlled by Synapse. They connect their wallet address, they put in their passport information, they create their digital identities. On the right-hand side, we have the dApps or the chains. So all of our clients at Anchor Verify have a simple UI, and they're able to create any type of policy that they want. Now, in this case, it's the user needs to be based in the US, and they need to be over the age of 18. Now, when a user wants to prove that they meet a policy for this chain or this dApp, they submit a proof request on the Anchor Verify UI, which means they are requesting proof to meet that policy. And when they do so, the Anchor Verify node checks the smart contract, the Merkle root of that smart contract held by Synapse, to ensure that this wallet address does in fact meet this policy. It doesn't look for any other information. And it's key that Anchor does not store this information, nor does the dApps or the chains. And if and when the user does meet that specific policy, we send the proof back to the consumer to hold in their wallet and to the dApp or the chain so the consumer can enter. Again, it's a win-win situation here because it allows dApps to create these policies that Web 2-like KYC security without the consumer data issues. It allows consumers to hold on to their digital identity. When I think of a user experience, what's key to a user experience? Safety, ownership of one's digital identity, but also convenience. A convenient user experience, which is why with Anchor Verify, when a user submits a proof and proves that they meet a policy, they only need to do it once. They don't need to continuously prove policies. This provides a more convenient user experience for the consumer, which of course makes the dApps and the chains more valuable. And speaking of a convenient user experience, one of the things that's very important is how do we empower developers to provide a convenient user experience as well as a safe user experience, which leads me to my next slide. Now, in order to drive mass adoption in Web3, we need to, of course, bring ownership of digital identities back to consumers, but we also need to have a quality and convenient user experience. Now, what you're looking here on the left-hand side is the login with Google feature, right? Now, this has nothing to do with KYC, but it's a convenient feature, right? When I'm on Spotify or YouTube and I don't have to go to another UI and I can easily just log in with Google, it's convenient. Or the Pay with Apple Pay, right? It's convenient if I'm on any type of website where I'm buying something and I don't need to go and grab my wallet and plug in all my credit card information. Although it only take about 3 minutes, it's just convenient to pay with Apple Pay. And the reason why I bring this up is because we incorporated a feature within Anchor Verify that's called Sign In with Anchor Verify. And what this means is dApps and chains don't have to force their consumers to leave the UI. They can stay right then and there. So for instance, if a consumer, say, hasn't created their digital identity yet, and they access a specific chain or a dApp that's a client of Anchor Verify's, they don't have to leave the UI. They click Sign In with Anchor Verify, and everything that happens here on the back end is hidden behind this UI. Meaning they can actually submit their passport information, create their digital identity right then and there. Or if they already have their digital identity and they just need to submit a proof, they can do it right there. Again, everything that happens here is hidden by this UI. And then, of course, the other situation is if they already have their digital identity and they've already submitted the proof, all they have to do is just log in. It's a safe, secure, and convenient user experience. Now, I can talk about Anchor Verify all I want, but I want to drive some evidence or proof, no pun intended, of this actually being used and the true value that it has. So, we partnered with Eclipse. Eclipse is an SVM chain that's on testnet right now. It's coming to mainnet very soon. And they wanted to incorporate a true security around their protocol. They wanted to empower consumers to own their digital identities while empower the developers who will soon be building high-quality decentralized applications on Eclipse to provide that level of security and safety and remove malicious actors. But they didn't want to have fragmented digital identities. They didn't want to have the poor consumer data privacy of Web 2. So they integrated Anchor Verify. And by integrating Anchor Verify, every dApp that will soon be deployed on Eclipse automatically gets to be able to leverage this security protocol, which means their application becomes automatically more valuable because it's a safe and secure environment where people on the platform automatically get KYC'd and AML'd, but they maintain ownership of their digital identity. And not to mention that these developers and these dApps don't need to build that security protocol in-house. They get it automatically. It allows them to focus on their projects rather than building an additional tool to make the user experience more safe. That's key. And it's a domino effect, right? Let's start with Eclipse. Eclipse is empowering developers with this tool, which attracts the top developer talent to Eclipse. Builders will want to go there. And consumers will feel a safe environment, which of course will attract more consumers to these dApps, driving more interactions, which of course drives more revenue for the dApps, which ultimately makes the Eclipse blockchain more valuable. And there's numerous industries that we've started to gain traction from this specific solution. And it could go from anything from supply chain to retail to sports to entertainment, because the level of customization that these dApps and these chains or these projects that will soon be building in Web3 it's endless. They can build any type of policy that they want, whether it's citizenship or age, residency, college degree, anything at all. The level of customization that they have is very important because each industry will soon have their own specific compliance requirements that they need to meet. Which leads me here. Enterprise use cases are probably the most important when it comes to Anchor Verify. And in fact, they're the most traction that we've gained thus far. Starting with dApps and blockchains, of course, as I mentioned, Eclipse and chains themselves, they'll be able to provide the value to the dApps building on top of them by not having to force them to build these types of privacy authenticator tools by themselves. But banks is also a very important one. It's one that we started to gain a lot of traction from. And the reason for this is because any bank across the globe, not just in the United States, of course, they're all starting to move into Web3, right? We've started to see Grayscale's Bitcoin ETF, and JP Morgan lately just announced plans to move into the blockchain space. But banks know that they will need to meet compliance. They will need to meet the regulation for the securities laws for their specific jurisdictions, which means they're going to have specific rules that they will need their consumers and their clients to be able to prove about themselves. And that's exactly what Anchor Verify allows them to do without giving up the ownership of their digital identity. That is what allows them to move into the blockchain space and provide that level of security. And for government level projects, this goes from anything from voting on presidential elections, if you need to prove that you're a specific citizen of a country, or even regional levels. This type of security is very important for these top enterprise use cases. And this is what we've started to see from some of Anchor's biggest partners, Microsoft, Tencent. All of the biggest names in the space, of course, are starting to move in, and they know that in order to do so, they need to provide a secure and safe, but also convenient user experience to attract developers to go and build on their platform, and to attract consumers to feel safe, to know that there's a far less chance for them to get hacked or to fall for a rug pull, right? Because at the end of the day, as I mentioned before, the world is becoming more digital. And it's imperative that we take control back away from corporate networks, the ownership of our digital identities. And that's exactly what ZK Proofs, and more specifically, Anchor Verify, empowers individual users of the internet to be able to have. Thank you all. Appreciate the time. If anyone has any questions, I'll be here for the rest of the week. And thank you all.